I'm Ranga Karanam. I'm excited to be your instructor for this course. Learning cloud computing is essential for everyone in the IT world today. Almost every enterprise out there is adopting the cloud, and therefore, irrespective of your role, whether you are a project manager, a business analyst, a tester, a programmer, or an architect, everybody in the team needs to understand the cloud. However, in my experience, I found that beginners to cloud find the first steps to cloud a little difficult. The most important reason is the wide range of terminology and the wide variety of services that each of the cloud platform offers. There are terminologies like infrastructure as a service, platform as a service, private cloud, public cloud, hybrid cloud. You have terminology like serverless, containers, container orchestration, and also each of the cloud providers provide a variety of services related to compute, databases, storage, DevOps, artificial intelligence, machine learning, data lakes, data warehouses, and a wide variety of them. For example, AWS offers 200 plus services. And because of this wide range of terminology and the wide variety of services, beginners to cloud find it really difficult. And that's why we spent a lot of time creating a simple path focusing on the fundamentals of the cloud. Once you understand the fundamentals of the cloud, once you understand the terminology which is associated with the cloud, you would see that you will be able to learn AWS very, very easily. And that's the goal of this specific course. Help you start your cloud journey with AWS. This course does not have any prerequisites. It does not expect you to have any prior experience with the cloud. Learning cloud can be tricky. You need to understand and remember a number of services. You're human, I'm human, and as humans, we tend to forget things. If I'm learning something new today, it is highly probable that I'll forget it in a few days' time. How do you improve your chances of remembering things for a long time? Here are a couple of recommendations based on my experience. Number one is active learning. Think and take notes. Whenever you see something interesting in the course, write it down. The second recommendation is to review the presentation once in a while. After completing a few sections, take a step back, review the presentation and videos, and think about what you have learned. The more you are actively involved with the learning and the more you review, the higher the chances for you to remember things for a long time. Now, what is our approach to building a great course? We are taking a three-pronged approach. We have amazing video presentations where we will introduce the different AWS services to you. We also have designed a number of amazing demos where you will be playing with a number of AWS services. We have also designed a couple of different kinds of quizzes to reinforce your learning. We have traditional text quizzes where you have questions, multiple choice answers, and you pick the right answer. We also have video quizzes where we discuss the scenarios, solutions, and the different variations that are possible on the solution. By using this three-pronged approach, we think you'll be able to remember things for a long time. Now, before we move into the next step, there are a couple of recommendations for you. Number one, this is not a race. Take your time, focus on understanding things well, and do not hesitate to replay videos when needed. The second, but the most important recommendation is to have fun. Learning cloud can get really boring, and that's why we invested a lot of time to try and make this course really interactive, really hands-on, and also making sure that you'll have a lot of fun while you learn. I'm really excited to help you learn AWS, and I'll see you in the next step. In this step, let's get started with what is cloud, why do we need cloud, and what is AWS. Let's go a few years back and see the world before the cloud. Applications have varying load throughout the year. Let's take a couple of examples. Let's start with an online shopping application. Online shopping applications have peak load during holidays and weekends, and they have less load during rest of the time. Let's consider another example. A startup suddenly becomes popular. So how to handle this sudden increase in load? A very important thing to remember is that as load varies, the infrastructure that is needed to support your application also varies. If you have more load, you need more infrastructure. And the approach that was taken by enterprises before the cloud was to procure the infrastructure, was to buy infrastructure for peak load. If the expected peak load is 1 million users, I would buy infrastructure to support 1 million users. Now think about this. What would that infrastructure be doing during periods of low load? Let's talk about the startup. What did the startup do before the emergence of cloud? They used to buy infrastructure assuming they were successful. What if they are not successful? So before the cloud, there were several challenges. Challenge number 1, low infrastructure utilization. I'm procuring infrastructure for peak load. What would the infrastructure be doing when there is less load, lesser number of users? It would be sitting idle, not used at all. Challenge number 2 is that it needs ahead of time planning. How do I know what is the peak load? Can we really guess the future? Challenge number 3 is the high cost of procuring infrastructure. Buying infrastructure is not cheap, and in addition to this, you need a dedicated infrastructure maintenance team. Think about a startup. Can it really afford an infrastructure maintenance team? This is the scenario when cloud started getting really popular. With the cloud, we don't buy resources. We actually rent resources. This is called provisioning. We provision resources whenever we want them and release them back to the cloud when we don't need them. This is called on-demand resource provisioning. You rent resources based on the demand on your applications. And the advantages of going for cloud are really clear. Number 1, you're trading capital expense for variable expense. Capital expense is the money you spend ahead of time to buy your infrastructure. Instead of that, we are going for variable expense, or we are paying rent. Advantage number 2 is that you can benefit from massive economies of scale. Each of the popular cloud providers handle millions of servers, and therefore they are able to get the best deals from the infrastructure providers. And because the cloud landscape is very competitive, typically the cloud providers pass on that advantage or the benefit to us. Another advantage is that you don't need to guess capacity anymore. Whenever the load on your application increases, you can provision more resources. You can request for more resources. Whenever the load on your application goes down, you can release resources back to the cloud. Another advantage is going global in minutes. Imagine a startup in India. With a click of a button, they can deploy their applications to multiple parts of the world, to different continents around the world. Cloud allows businesses and startups to avoid undifferentiated heavy lifting. If you'd want a highly available and highly durable database, setting it up takes a long time. You need to worry about setting up standbys. You need to worry about setting up backups for your database. And if you are making use of the cloud, setting up a database becomes really, really easy. So cloud helps you to avoid undifferentiated heavy lifting and helps you to focus on the solutions you are providing for your customers. Another advantage is that you don't need the data centers anymore. So you can stop spending money running and maintaining your data centers. Until now, we looked at why we need the cloud and what are the advantages it offers. Now, let's look at AWS. Why AWS? AWS is the leading cloud service provider. The main competitors for AWS are Azure and Google Cloud. Among these, AWS provides the most number of services. There are 200 plus services that AWS offers. And I'm sure by the time you watch this course, there will be a lot more services. In the last decade, AWS also proved itself to be very reliable, very secure, and cost-effective. There are a number of large enterprises which run their applications on AWS. For example, Netflix. You'll learn a lot more about AWS as we go further in the course. We go to the cloud because it's cost-effective. You can avoid planning upfront, and you can avoid undifferentiated heavy lifting. We go to AWS because it's the leading cloud service provider. Now, if your objective is to learn these services, is there a best path to learn AWS? Whenever we talk about cloud applications, they make use of multiple AWS services. Important thing for you to understand is that there is no single path to learn these services independently. There is no path which says, okay, learn this first, learn this next, and this is after that. All these services are really, really interconnected, making it difficult to create a path to learn these services independently. However, we have worked out a very, very simple path where we introduce the important services first and make it really, really easy for you to learn these services one by one. Are you excited to learn all these services and get started with AWS? Let's get started right away. In the next step, let's get started with setting up our AWS account. We'll create an AWS account and we'll also create a secure user to help you make use of the AWS account. I'll see you in the next step. Are you excited to create your AWS account and get started with playing with the cloud? These are the things you would need. Number one is your personal details, including your address. Number two is a valid debit or credit card. And you need your mobile phone as well. AWS is providing you access to very powerful infrastructure. You'll be able to create a number of resources in AWS. And that's why they want to be really, really sure who you are before they provide you with the access. And that's why this process can be a little tedious. I would recommend having a little bit of patience during this process. The great thing is that this is a one-time process. Once we get through once, you never have to go through it again. Let's get started. What I would recommend you to do is to search for AWS free tier. You can either click the ad at the top, or if you don't see the ad, you can click the free computing services AWS free tier link, which should be one of the first results. This would take you to the AWS free tier page. The goal of AWS free tier is to provide you with free hands-on experience with the AWS platform, products, and services. And to be able to make use of the free tier, we would need to create an AWS account. So let's go ahead and say, create an AWS account. Let's get started with the sign up process. The first thing you would need is your email address. This is called the root user email address. So enter your email address in here and choose an account name for your AWS account. Once you fill these two details, click verify your email address. If you check your email address, you should see a message like this with the verification code. So you should receive an email as soon as you enter the details on this specific screen and click verify email address. And on the next page, you can enter the verification code and click the verify button. If you didn't receive the code, the first thing I would recommend you to do is to check your spam folder. If there is no email in your spam folder, wait for 5 to 10 minutes. If you don't receive the code after 5 to 10 minutes, go ahead and click resend code again. So make sure that you enter the verification code and click the verify button, and you should be taken to the create your password screen. This is where you can enter your root user password. So your email ID is your root user, and the password which you enter on the screen is what is called root user password. So go ahead, enter your root user password and also make sure that you confirm it and click continue. On the next page, you'll be able to provide your contact information. You need to choose if you are using AWS for business purposes or personal purposes, and also your contact information, your full name, phone number, country or region, address, city, state, and postal code. Make sure that you read and agree to the terms of the AWS customer agreement and click continue again. On the next page, you need to enter your billing information. This is where your credit or debit card details will be useful. So go ahead and enter all the details that are requested on this specific page and click verify and continue. One of the things that you need to remember is that AWS will not charge you for AWS usage as long as you are within the AWS free tier limits. To verify your debit card or credit card, AWS might do a transaction or a hold up to $1. So you might have a transaction like this which happens to verify your debit and credit card. Once you verify your debit card and credit card, the last step is to confirm your identity. So what you need to do is to verify your phone number. You can choose either to get a text message or a voice call. So go ahead, enter your mobile number in here, enter the characters for the security check, and click the button at the bottom of the page. Once you receive the SMS or the voice call, go ahead and confirm the identity on the next page. As it says in here, sometimes there can be a little bit of a delay, up to 10 minutes, for you to receive your verification code. If it takes longer than that, you can go back to the previous page and try again. Once you enter the verification code and click continue, you will be taken to the page where you can select the support plan. There are multiple levels of support that are provided by AWS. We are just interested in the basic support, which is free. So let's choose basic support free and click complete sign up. Congratulations for completing the entire process needed to create an AWS account. If you click this Go to AWS Management Console button, you will be taken to the AWS Management Console page. You can also reach this page by searching for AWS Management Console in Google. Over here, you can click Sign into Console. This will take you to the sign in page where we would want to use the root user to sign in. The root user is the email ID that we made use of to create our AWS account. So go ahead and enter the email address in here and click Next. On the next page, you can enter your password. This is the password you would have chosen when you were creating the AWS account. Go ahead and sign in. This should take you inside your AWS Management Console. Congratulations! Creating an AWS account is a tedious process, but it's just one time. So all the hard work is now behind you. Let's start exploring the AWS Management Console, starting the next step. In this step, let's talk about IAM and some of the best practices related to IAM. What is IAM? IAM stands for Identity and Access Management. We are creating some powerful resources in AWS, and you need to control access to them. You need to identify the user, and you need to control the access to the resources. IAM is responsible for authentication and authorization. Authentication is it the right user? Authorization is, does the user have the right access? In the previous step, we created our AWS account. And while creating our AWS account, we created a root user. The root user credentials are the email address which we used to create the AWS account and the password which we assigned to it while we were creating the account. The important thing to remember is that the root user has absolute power. Anybody who has access to your root user credentials can do anything they want with your AWS account. And that's the reason why it is recommended not to use the root user for day-to-day activities. The best practice is to create another IAM user and use the IAM user for regular day-to-day activities. So what we'll do in this step is to create a IAM group. You might have thousands of IAM users. You don't want to manage permissions for them individually. That's where we would create a group, a IAM group. The group which we'll create is called developers. And we'll create a IAM group with the right access. And after that, we would create a IAM user. So we'll create a IAM user in 28minutes_dev, and we would make it part of the IAM group developers. And later on in the course, we'll be making use of this IAM user to do all our activities instead of making use of the root account. Let's get started with step 1, which is to create an IAM group. Before we'll be able to create an IAM group, we will need to log in into AWS Management Console. If you do a Google for AWS Management Console login, one of the first search results should be AWS Management Console. You can click that. And I would want to go ahead and log back in. This is where you can enter your root user. So we are choosing root user in here, and I'm entering my root user email address. What I would recommend you to do is to enter your root user email address and click Next. Once I click Next, I'll be taken to the next page where I can enter my root user password. I've entered my password and I would say sign in. And this would take me to the home page of AWS Management Console. There are a wide variety of things that you can do in the AWS Management Console. If you want to see the list of all the services in AWS, you can click the View All Services in here. So this would show actually a list of services in AWS. You can also get to this by clicking Services. So over here, if you go to Services, you can also see the list of services which are present under different categories in AWS. We'll explore AWS Management Console as we go further in this course. For now, what we want to do is to create an IAM group, developers. So what we'll do is to search for IAM in here. IAM stands for Identity and Access Management. It helps you to manage access to AWS resources. So let's go ahead and click IAM. In IAM, you can create users, you can create groups, and you can manage permissions for them. What I want to do is to create a group or a user group. So let's go ahead and click user groups, and you can say create group. I'd want to give the name developers to this group. and I can attach the permissions in here. Typically, you'd want to restrict the amount of permissions that you would give to your IAM users. But what we would do during this course is we'll be using the IAM user that we are creating to perform actions against all the AWS resources. And that's the reason why I would give him administrator access. You can go into the permissions and type in administrator. Make sure that you get the spelling right. It's ADMINISTRATOR. You can type it in and press enter. And then you should see something called administrator access. What you need to do is to check the checkbox which is right beside administrator access. So we are creating a developers group with administrator access. And I would now go ahead and say create group. So we now have a developers group created. We don't have any users that are assigned to this group. Let's now create a user. Let's go to users in here. And I would say add users. The name of the user I would want to create is in28minutes_dev. So I will use username in28minutes_dev. You can see that there are two types of accesses that you can provide. One is programmatic access and the other one is AWS Management Console access. What we are making use of right now is the AWS Management Console. The way we can access AWS Management Console is by typing in a username and a password. This is what typical users would do. Use a username and password and use the AWS Management Console. However, if you're writing any programs, in that kind of scenario, you can make use of programmatic access. That's where you'll also create an access key. Let's not worry about access keys for now. For now, let's focus on just creating a password. So I'll check this up. We want to create a password. What I would choose to do is to create a custom password. I would go ahead and enter my password. Because I'm entering my password in here, I'll uncheck this. I don't want the user to create a new password again at sign in. Now I can go ahead and click next, where I can assign permissions for the user. So let's go ahead and click next. There are a number of ways you can give permissions to the user we have created. You can add user to a group, or you can copy permissions from an existing user, or you can directly attach permissions with the user. The recommended way always is to add user to a group. The group has the right permissions. The developers group has the administrator access. And to give access to our user, what we would do is we would assign him to the developers group. So I'll check this checkbox and I would say next. On the next page, I'll click next again. And we can review the details in here. Username is in28minutes_dev. We would want to give AWS Management Console access. We have configured our own password and we are assigning him to the group developers. That looks cool. So let's go ahead and create a user. Awesome. The user is now created and we can now use this user to sign in. So now if I go in and type in IAM and go over to the Identity and Access Management Service, you'd be able to go over to user group. You'll be seeing that there is one user group and one user that we have created. Now we want to log in with this specific user that we have created. So we now have two users. One is the root user and the other one is the IAM user that we have created. Right now we are logged in with the root user. What we want to do is to log in with the IAM user. If you want to log in with the IAM user, the URL is a little different. The URL that you need to make use of to log in with the IAM user is the one which you are seeing in here. So what I would recommend you to do is to copy this URL and bookmark it as well. So what I'll do now is I would open up a new tab and I would paste this URL in. I'll go in here and now I would use the IAM user that I have created. So the IAM user that I have created is in28minutes_dev. I'll type in the password. We are going to frequently use this account. So I'll say remember this account and I would go ahead and say sign in. And now on the top right hand corner, you should see in28minutes_dev. So we are now logged in with the IAM user. Let's quickly summarize what we have done until now. When we created our AWS account, we made use of our email address and we provided a password. Those credentials are what are called root user credentials. one of the AWS best practices is to not use root user for your day-to-day activities. And that's the reason why we have created our own IAM user. We saw that the URL that we would need to use with an IAM user is a little different. So the recommendation is to go ahead and bookmark that URL. And from now on, we'll use that URL and we'll use the IAM user to log into our AWS account and perform our operations. I'm sure you're having a wonderful time, and I'll see you in the next step. Earlier, when we talked about the cloud, we talked about the fact that you can go global in minutes. You can deploy your applications to different parts of the world in minutes if you're making use of the cloud. How can you do that? The most important concepts that enable you to do that are regions and zones. In this step, let's focus on understanding why we need regions and zones. Let's take a simple example and discuss that. Imagine that your enterprise has a corporate data center in the London region and you have deployed an application in there. Let's assume that your users are distributed globally. What would be the challenges? Challenge 1 is slow access for users from other parts of the world. If I'm accessing this application, let's say from Sydney or Mumbai or Chennai or New York, the application will be a little slow. This is also called high latency. So we have high latency for users from other parts of the world. Number 2, let's imagine a scenario where this data center crashes. Because we have just one instance of the application is no longer available. Your application goes down. So your application has low availability. Now think about this. What can we do to improve this situation? What we'll do is let's add one more data center in London. We have one data center in London, so we are adding one more. So we have corporate data center 1 and corporate data center 2. What would be the challenges now? Challenge 1, slow access for users from other parts of the world, is not fixed yet. It remains. Challenge 2, on the other hand, what if one data center crashes? Is solved. Because even if this data center crashes, we can serve the application from corporate data center 2. That's awesome. So your application is still available from the other data center. However, there is a new challenge. Challenge 3. What if the entire region of London is unavailable? The application would go down. Now, we spend a lot of time thinking about this and we come up with a better solution. What do? We add a new region, Mumbai. We have London region, we have a Mumbai region, and each of these regions have 2 data centers each. Now, think about our challenges. Challenge number 1 is partly solved. At least the users who are nearer to the Mumbai region will get faster access to the application. We can solve challenge 1 completely by adding deployments for our application in multiple regions around the world. We can add a deployment in Sydney, New York, and multiple other regions in the rest of the world. Number 2, what if one data center crashes? This is already solved. Number 3, what if the entire region of London is unavailable? What happens if London goes down? We would be serving our users from Mumbai. So this is solved as well. By having multiple regions and by having multiple data centers in each of those regions, we can provide high availability to our users. Another thing which improves is latency. Users nearer to each of these regions get faster access to these applications. This is the reason why each of the cloud providers provide concepts called regions and zones or availability zones. In this step, we understood the need for regions and zones. Let's discuss this more in the next step. In this step, let's talk about regions and zones in AWS. In the last step, we talked about the advantages of having multiple regions and multiple data centers. Now, imagine setting up data centers in different regions around the world. Will it be easy? The answer is no. If you want to set up infrastructure all around the world, you would need a large team. Think about a startup. Can a startup deploy infrastructure on its own to different parts of the world? That would be very difficult for a startup. And that's where all cloud providers, including AWS, provides us with regions all around the world. AWS provides 25 plus regions around the world, and this is an ever expanding list. There are new regions added in every year. Now, what is a region? A region is nothing but a specific geographic location where we can host our resources. You can decide, I would want to host my application in Mumbai region, or I can say I would want to host my application in London region. By having multiple regions around the world, AWS makes it very, very easy for us to deploy applications to different parts of the world. Now, what are the advantages of having multiple regions? Number one is high availability. If you deploy your application to multiple regions around the world, even if one of these regions goes down, you can serve your users from the other regions. Number two is low latency. You can serve your users from the nearest region to them, and therefore they get low latency. If there's a request coming in from India, you can serve from Mumbai. If there's a request coming in from somewhere in Europe, you can serve from the London region. And if a request is coming in from United States, you can probably serve it from one of the regions in United States. The third advantage is global footprint. A startup in India can easily deploy applications to multiple parts of the world. The last advantage is adherence to global regulations. Different countries have different regulations. Let's say United States of America wants all the data related to its citizens to reside only within their country. In those kind of situations, you can create a region in United States and store all data to US customers only in that specific region. So regions help us achieve high availability, low latency, global footprint, and help us to adhere to government regulations. Now the question is, what is the need for availability zones? How do you achieve high availability in the same region? That's where availability zones are really, really useful. AWS provides multiple availability zones in each of the regions. Each availability zone is nothing but a set of one or more discrete data centers. Each of the availability zones has independent and redundant power, networking, and connectivity. The chance that two availability zones simultaneously fail is very, very rare. In addition, all the availability zones in a region are connected through low latency links. So there can be very fast communication between applications deployed in the same availability zone. The biggest advantage of going for availability zones is increased availability and fault tolerance while deploying the application in the same region. So if I'm deploying my application to multiple availability zones in the same region, even if one of the availability zones goes down, you can serve the application from the other availability zone. Let's look at a few example regions and availability zones in AWS. US East 1. This is called US East North Virginia. And these are 6 availability zones. You can see that the name of a region is US East 1. And the name of the availability zone is the name of the region appended by an alphabet. For example, you have 6 availability zones running from A to F. So you have US East 1A, 1B, 1C, 1D, 1E, and 1F. These are the 6 availability zones in the region US East 1. Similar to that, you have regions around the world. You have EU West 2, which is Europe London region. And this has 3 availability zones, 2A, 2B, and 2C. We also have a region in India, AP South 1, Asia Pacific, Mumbai. And this has 3 availability zones, AP South 1A, 1B, and 1C. In this step, we looked at regions and availability zones in AWS. I'm sure you're having a wonderful time, and I'll see you in the next step. Starting this step, let's look at EC2. Let's understand what is EC2 and why do we need EC2. In corporate data centers, applications are deployed to physical servers. If I would want to deploy an application, the first thing I would do is to provision a server. Now, how do you do things in the cloud? Where do you deploy applications to in the cloud? That's where we would be renting something called virtual machines. And in AWS, the virtual machines are called EC2 instances. EC2 stands for Elastic Compute Cloud. So if you want to create a virtual machine in AWS, we'd be creating an EC2 instance. And how can you create an EC2 instance? The service which you would be making use of to provision EC2 instances is called EC2 service or just EC2. Whenever somebody refers to EC2, they are referring to the service which is used to create virtual machines or EC2 instances in AWS. EC2 or Elastic Compute Cloud is one of the most popular AWS services. Now, what are the things that you can do with EC2? What are the important features of EC2? You can create and manage the life cycle of EC2 instances. You'll be able to create a EC2 instance. You'll be able to start it, stop it. You can terminate it. So there are a lot of actions that you can perform on EC2 instances, and all those can be done through the EC2 service. In addition, you can also attach storage to your EC2 instances. Typically, your laptop or your computer has a hard disk attached with it. And for your virtual machines or EC2 instances, you'd also want to be able to attach storage to them. That's where you can make use of something called EBS or Elastic Block Store. You can make use of EC2 to create Elastic Block Store instances and attach them to your EC2 instances. You can also do load balancing for multiple EC2 instances using EC2. Let's say you have an application which has 1 million users. You cannot run it on just one EC2 instance. You'd want to be able to run it on multiple EC2 instances. And when you have multiple instances, you'd want to be able to load balance between them. EC2 service also provides load balancing as a feature. So EC2 stands for Elastic Compute Cloud, and it is the service that helps you to create virtual machines in AWS. In the next step, let's start playing with EC2 instances. I'll see you in the next step. In this step, let's create an EC2 instance and play with it. The service we would need to use to create an EC2 instance is EC2. EC2, virtual servers in the cloud. EC2 stands for Elastic Compute Cloud. And when I click EC2 service, you'd be able to see that there are no instances that are running at this point in time. So instances running is 0. Right now, I'm making use of the Mumbai region. I'm in Hyderabad, which is very, very near to Mumbai. Therefore, I'm choosing the region Mumbai, AP South 1. You can choose any of the regions which is present in here, which is nearer to you. However, make sure that once you choose a region, you choose the same region for all the demos. So let's go ahead and pick up Mumbai from here. Now, we would want to create a EC2 instance. One of the ways you can launch EC2 instances is by clicking launch instance in here. Another approach is you can go into instances and you can click a launch instance in here. Once you click launch instance, you would get a screen where you would need to fill in a lot of details regarding the EC2 instance that we would want to create. The first thing you would need to enter in here is the name. I'll call this first EC2 instance. I've zoomed in a little bit so that the screen is really clear to you. The next thing that we would need to choose is something called an AMI. An AMI is a template that contains the software configuration, basically what operating system you would want to use, and what are the applications you would want to install on your EC2 instance. There are a wide variety of AMIs which are provided by AWS. What we'll do is we'll pick up Amazon Linux AWS, which is the default one which is suggested, and I'll choose Amazon Linux 2 AMI, which is the default one which is suggested in here. You can also see that this is free tier eligible. So let's choose the default AMI which is suggested in there. The next thing you need to choose is the instance type. The AMI is all about software and instance type is all about hardware. What kind of hardware do you want on your EC2 instance? That's what we are choosing when we are choosing an instance type. If you click this drop down in here, you would see that there are a wide variety of instance types that are present in AWS. You can see that each of these instance types has different amount of memory, different number of vCPUs, and they have different pricing. What I would do for now is to choose the default one which is suggested, which is T2 Micro. This comes with one virtual CPU and it comes with 1 gig of memory. And as you can see in here, it is free tier eligible as well. The next thing that we would need to choose is the key pair. You'd want to securely connect to your EC2 instance. And the way you can securely connect to the EC2 instance is by making use of a key pair. What we'll do in here is we'll go ahead and create a new key pair. So I'll create a new key pair and I'll call this EC2-default. and let's say create key pair. Once you create a key pair, it will also be downloaded onto your local machine. Make sure that you store the key pair securely, because anybody who has the key pair will be able to connect to your EC2 instance. I'll say allow and I'll download the key pair. And over here you can see that EC2 default key pair is chosen by default. So that looks good. The next thing we would need to configure is the network settings. As part of these network settings, one of the most important things that we would need to configure is a security group. A security group is a firewall. Basically, you can control what traffic is allowed into your instance and what traffic can be going out from your EC2 instance. What we'll do in here is to create a new security group. And what I would want to do is to allow SSH traffic from anywhere. Whenever I would want to connect to the EC2 instance, I would need to SSH into it. So I would want to allow only SSH into my EC2 instance. That's the only thing I'm allowing as part of my security group. The last thing we would want to configure is the storage that needs to be attached to my EC2 instance. I'll take the defaults for the storage as well. We are attaching a 8 GB general purpose root volume with our EC2 instance. Let's quickly review some of the important details that we have configured until now. We want to create one EC2 instance. We are making use of the Amazon Linux 2 kernel 5.10 AMI. And AMI is nothing but the operating system and the applications that you would want on your EC2 instance. We chose the instance type as T2 micro. Instance type helps you in choosing what kind of hardware you would want for your EC2 instance. How many vCPUs, how much memory you would want, what kind of IO speed you would want. You can choose all that by choosing the instance type. The next thing we configured is a security group. Security group is a firewall. This controls what traffic is allowed into your EC2 instance and what traffic can go outside your EC2 instance. We also attached a root volume of size 8 GB. Let's go ahead and launch this instance. You can see that it says successfully initiated the launch of this specific instance. What I can do is I can click that specific instance in here. So when I click that, a new page would open up where I'll be able to see that specific instance. Right now, you can see that the instance state of that is pending. If you give it a few minutes, you would see that the instance state would shift to running. Now, what I would want to do is I would want to be able to connect to this EC2 instance, and I would want to be able to execute a few commands against it. How can I do that? That's where you can select this and you can click connect. There are multiple approaches to connecting to your EC2 instance. What we'll do is we'll make use of EC2 instance connect. The default username is EC2-user. So you can take the default username and you can say connect. And within a little while, you should see that a new tab opens up where you can go ahead and type in a few commands. I'll go in here and type in who am I, EC2-user. I can go in and type in Python version. You can see that Python 2.7.18 is already installed on this specific EC2 instance. If you want, you can go ahead and install any software that you would want on this EC2 instance. For example, if you want to install Java or Node.js, or if you want to install Go, you can go ahead and install it on this specific EC2 instance. One of the most important things that you need to understand is the power of what you are doing right now. With a click of few buttons, we were able to launch a virtual server. And we were able to very, very easily connect to it. And we are now able to execute commands. And if we want, we can go ahead and install software in it and play with it. That's the power of cloud. You can get access to powerful infrastructure with a click of few buttons. Let's close this window down and let's go back to our EC2 instance. So I'll go back to EC2 instances, and you can see that right now we have one instance running. And if I click the instance ID, I can see all the details about this EC2 instance. You can see that this EC2 instance has an instance ID. The ID is what is used to uniquely identify this EC2 instance. The EC2 instance by default is also assigned a public IP address. If you install an application on the EC2 instance, you can use this public IP address to access that specific application. The EC2 instance is also assigned a private IP address as well. This IP address is only available inside the network in which the EC2 instance is created. You can see that the current state of EC2 instance is running. You can also see that the instance type of this is T2 micro. Now, there are a number of operations that you can perform on your EC2 instance. If you go to instance state, you can stop the instance. You can reboot the instance, basically restart the instance, or you can terminate the instance. Stopping the instance would only temporarily stop the instance. You can go ahead and start it at a later point in time. But if you terminate the instance will be completely deleted. You'll not be able to restart it again. If you scroll down in here, you'll be able to see a lot more details about the EC2 instance. You can see that we are making use of Amazon Linux. You can see the AMI ID, or we can see the AMI ID or the Amazon Machine Image ID that we are making use of. You can also see the key pair details and a lot of other details regarding this EC2 instance. If you go over to security, you'd be able to see the details of the security group that we have configured. Earlier, when creating our EC2 instance, we said we would want to allow SSH traffic. And that's why you can see that in the security group, it allows traffic on port 22. If you go over to networking, you can see the networking details of this EC2 instance. You can see the public IP address, private IP address. You can also see the VPC and the subnet details in here. VPC and subnets allow you to create your own private network in the cloud. We'll talk about VPCs and subnets a little later in the course. If you go to storage, over here you can see that there is a hard disk or a virtual drive which is attached with your EC2 instance. When we created our EC2 instance, we chose that we would want a 8 GB hard disk to be attached. You can see the details of it in here. In status checks, you can see the current status of your EC2 instance. You can see that all the system status checks are passing, and also you can see that the instance status checks are also passing. If you go to monitoring, you can look at all the metrics related to our EC2 instance. You can see the CPU utilization. You can see the status of the status checks. You can see how much network traffic is coming in and how much network traffic is going out. You can see the details of disk reads, disk writes. So if you want to look at metrics related to your EC2 instance, you can come to the monitoring tab. In AWS, the service which tracks your metrics is CloudWatch. So what's happening is your EC2 instance would send all the metrics to CloudWatch. And these are the metrics you are seeing in here. And you can also attach tags with your EC2 instance. You can see that there is a tag which is already created, name EC2 instance. What I would want is I would want to add more tags. So I'll go to manage tags and I would want to add a new tag. I'll call this environment. I'll add a tag called environment and let's say dev. And I'll also add a tag called business unit and let's call this business unit A. Tags are really useful in associating a specific resource in the cloud with, let's say, an environment or a business unit. Whenever you are working for a large enterprise, you'd want to be able to identify which resource belongs to which business unit or which environment so that you can associate costs with that specific environment or that specific business unit. So let's go ahead and save this. In this step, we were able to create our first EC2 instance. We were able to connect to it using Instance Connect. We were able to execute a few commands against it. And we saw that there are a lot of things that you can do with your EC2 instance. Before we end this step, what I would want to do is to terminate this specific EC2 instance. In the cloud, you don't want to leave the resources running for a long time. The best practice in the cloud is to always terminate the resources after you play with them. So what I'll do is I'll select this. I'd go to instance state and I would say terminate instance. I'd go ahead and say terminate. We have kickstarted the termination of this EC2 instance. The termination of the EC2 instance will take a little while. I would recommend you to take a break and I'll see you on. Welcome to the next demo on EC2. In this demo, let's create a EC2 instance and install a simple web server on our EC2 instance. I'll launch up EC2 virtual servers in the cloud. I'll go to our instances and I would say launch an instance. And I would call this my first web server. I'll take the defaults for AMI, for instance type. I'll create a new security group as usual. The new security group is configured to allow SSH traffic from everywhere. So we'll be able to SSH into this instance. And I'll take the default with the storage that is assigned. So Elastic Block Storage volume of 8 GB will be attached with our EC2 instance. The only additional thing I would need to do is to select the key pair. I would choose the same key pair which we created in the last step. So I'll go ahead and choose EC2-default. We are all set to launch our EC2 instance. You can see how easy it is to launch a EC2 instance in AWS. With a click of few buttons, you'll be able to provision powerful servers. Let's go and check the status of the instance. The instance state right now is pending. Let's refresh. It's still pending. Let's give it a couple of minutes. Okay, it's now running. It took about 30 seconds, I would think. And now I can go ahead and select this instance and I can connect to it. Let's use EC2 Instance Connect and let's connect to this specific instance. Now, what we want to do in here is to install a simple web application. We would install something called Apache Web Server. And to be able to install Apache Web Server, we would need to become a super user. And the way we can become a super user is sudo su. So sudo space su. This is the command which will make us a super user. So we are now becoming a super user. So we are becoming a root. And now I can go ahead and install any software I would want on my EC2 instance. To install software on any of the operating systems, typically we make use of package managers. In Amazon Linux 2, the recommended package manager is yum. So we'll be making use of yum to install our software, our web server. Before we install the software, we would need to make sure that yum is updated. So I'll say yum update -y. If you're facing any problems with the commands, or if you're finding it difficult to type these commands, these text commands are also available in the previous text lecture. So you can go to the previous lecture, copy these commands, and use them in here as well. So the command we are executing is yum space update space -y. Cool. It says no packages marked for update. That's wonderful. We are ready now to install Apache. And the command to install Apache is yum install httpd. And you can press enter. It's asking me if it's okay. Let's go ahead and install. I'll say yes. This is pretty quick. So we have our web server installed in here. Let's start it up. The way you can start it up is by using something called system control. System CTL. And I would say start httpd. So system control start httpd. System control start httpd. That's what we are doing in here. Let's press enter. Apache web server is now started up. Now we would want to see what's happening with it. How do I access the web application? I can go back to management console. I'll go to instances. Right now you should have just one instance running. So I'll go in there and I would want the public IP address. What I'll do is I'll copy the public IPv address. I'll copy this and paste it in to the browser. So 3.111.51.192. I'll paste it in and I'll press enter. Oops, nothing is happening in here. It's just hanging. Why are we not able to access our web application, which is installed on our EC2 instance? Earlier, we talked about security group. Security group is a virtual firewall which sits right before your EC2 instance. Let's check the rules that are configured for our security group. I'll go to security for our EC2 instance. This is the security group which we are making use of. And right now, in the inbound rules, we are only allowing access on port 22. 22 is SSH port. Because SSH is allowed, we were able to connect using SSH to our instance. But right now, we are not allowing HTTP traffic. How can we allow HTTP traffic? We can change the security group. So I'll go and click the security group which is present in here. This would take you to the security group. And if I go over to the inbound rules, I can go ahead and edit inbound rules. Right now, the only inbound access which is allowed is SSH. What we want to do is to add another rule. I want to allow HTTP. So we want to allow HTTP access. We want to allow access to our web application which is running on port 80. And I would want to allow it from everywhere. So I will choose allow from 0.0.0.0/0. This means allow from everywhere. And I'll say save rules. And now if I go back to my EC2 instance, so let's go to the EC2 instance and let's pick up the public IP address for this. Let's pick up this and you can type it in. 3.111.51.192 is mine. You might have a different value. Go ahead and type it in and press enter. You should see this page come up. If you're reading this page, it means that Apache HTTP server is installed at the site and it's working properly. Congratulations. If you have any problems, then make sure that you have modified the right security group. So go to your instance and inside the instance, go to security. And if you go over to your security group and look at your inbound rules, you should see a rule which allows HTTP access from everywhere. You can do edit inbound rules and you'll be able to see that we are allowing HTTP access from everywhere. Right now we have installed Apache HTTP server. If you want to install Java or Node.js or any of the other pieces of software, you can install them in a similar way. However, imagine setting up a number of EC2 instances like this. It would be a little tedious, isn't it? I have to connect to each EC2 instance, install the right software in there, make sure that the application is up and running. And that's a lot of work. How can we simplify this? We will explore a lot of solutions as we go further in the course. I'm sure you're having a wonderful time, and I'll see you in the next step. In this step, let's review some of the most important EC2 or the Elastic Compute Cloud concepts. Let's start with the Amazon Machine Image or the AMI. What operating system and what software do you want on your EC2 instance? That's what AMI represents. It gives you a starting point with a specific operating system, and you can also customize the software that you would want on your EC2 instance. AWS provides a number of pre-built AMIs. You can also take these AMIs, customize them for your enterprise, and use them as AMIs as well. The next thing we'll talk about is instance families. Instance families help you to choose the right family of hardware. There are a variety of applications. You might have a web application. You might be running a database on an EC2 instance. You might be using the EC2 instance as a cache. Or you might be using the EC2 instance to do graphics processing. So EC2 instances can be used for a variety of purposes. And therefore, EC2 service offers a number of instance families. These instance families are suitable for specific type of workloads, for specific types of applications. Once you choose the instance family, you need to choose the instance size. There are a variety of instance sizes that are available with each of these instance families. For example, you have T2 Nano, T2 Micro, T2 Small, Medium. So Nano, Micro, Small, Medium, these are all different sizes. These help you to choose the right quantity of hardware. For example, I would want 2 vCPUs and I would want 4 GB of memory. Next, let's talk about Elastic Block Store. Elastic Block Store helps you to attach disks or virtual disks to your EC2 instances. We'll explore Elastic Block Store a little later as well. This is something which is called block storage. Typically, you would attach a hard disk with your computer or laptop. Similar to that, you can attach an Elastic Block Store instance as a virtual disk with your EC2 instance. In the cloud, we are making use of shared infrastructure. So you'd want to be really careful about security. And you can control the traffic which is going into every AWS resource using security group. You can control traffic which goes into your EC2 instance or a database by configuring a security group and configuring rules saying what kind of incoming traffic is allowed and what kind of outgoing traffic is allowed. So a security group is a virtual firewall to control incoming and outgoing traffic to and from AWS resources, EC2 instances, databases, and a variety of other resources. The last concept which you are going to review is key pair. Whenever you create an EC2 instance, you can associate a key pair with it. A key pair consists of a public key and a private key. The public key is directly stored in the EC2 instance. And if you'd want to connect to an EC2 instance, you would need the private key. So the private key is stored by the customer or by you. You are the person who wants to connect to an EC2 instance. So you can store the private key privately and you can use it to connect to the EC2 instance. In this step, we reviewed some of the important concepts related to EC2. I'm sure you're having a wonderful time, and I'll see you in the next step. Do you want to continue running applications in the cloud the same way you run them in your data center? Let's say I would want to set up a Python application in my data center. I would first provision a virtual machine, then I would probably install my operating system, maybe then I would install Python, and then I would install the application and its dependencies. Do you want to continue running your applications the same way in the cloud as well? Or are there other approaches? To understand different approaches that cloud provides, you need to understand some of the terminology: infrastructure as a service, platform as a service, and a wide variety of other terminology. What we'll do in this specific section is to get on a quick journey to understand some of these terminology. Let's get started with a very, very important terminology, which is IaaS, or infrastructure as a service. Infrastructure as a service is all about using only infrastructure from the cloud provider. For example, you make use of the VM service which is provided by the cloud platform to deploy your applications and databases. When you make use of infrastructure as a service, cloud provider is responsible for hardware, networking, and virtualization. So the hardware, the networking part of it, and the service you would need to virtualize this. For example, if you are making use of AWS, you can use the EC2 instance to create virtual machines. So that's the virtualization part. So hardware, networking, and virtualization is the responsibility of the cloud provider, and you are responsible for everything else. For example, let's consider I'm deploying a Python application on a Linux instance. I would be responsible for installing Linux. I would be responsible for installing Python. I would be responsible for installing the application as well. So you will be responsible for OS updates and patches. If I need to do any upgrades to Linux, I would be responsible for that. I would be responsible for application code and runtime, the code and the runtime. For example, if it's a Python application, Python. If it's Java application, Java. If it's a Node.js application, then Node.js. You are responsible for all these things as well. You're also responsible for configuring load balancing. You might have millions of users on your applications. In that case, just having one VM instance is not sufficient. You'd want to have multiple VM instances, and you'd want to be able to load balance between them. When you're using infrastructure as a service, you are responsible for configuring load balancing. You are also responsible for auto scaling. The number of users on your application varies with time. And if I have a lot of users, then I would need a lot of instances. However, if I have less number of users, I would want to reduce the number of instances. This is what is called auto scaling. When you're using infrastructure as a service, you are also responsible for auto scaling the number of instances of your application based on the load which is coming in. And you are also responsible for availability. Some of these instances might have crashed. You'd want to be able to detect that, and you would want to replace it with an healthy instance. That would ensure that your application is highly available. When you're using infrastructure as a service, you are also responsible for availability. So infrastructure as a service is all about only making use of the infrastructure from the cloud provider. The cloud provider is only responsible for hardware, networking, and the virtualization software. That's all. The rest of the things related to your OS upgrades and patches, your application runtime, your application, load balancing, auto scaling, availability, all these become your responsibility. Now, the question you might be wondering is, how can we give some of these responsibilities to the cloud provider? The alternative to infrastructure as a service is something called platform as a service. Use a platform which is provided by the cloud. Let's consider an example. Let's say I would want to deploy a Python application. If I'm making use of a platform as a service, all that I would need to do is to tell the service, hey, this is my Python code and I would want Python 3. Go ahead and run it. That's it. You're not responsible for installing the OS or installing Python or anything of that kind. You are only responsible for the code of your application. So when you are using platform as a service, the cloud provider is responsible for hardware, networking, and virtualization. This is exactly the same as infrastructure as a service as well. In addition, the cloud provider is also responsible for OS, installing the right OS, including upgrades and patches. The cloud provider is also responsible for installing the application runtime, installing the right version of Python or Node.js or Java. Cloud provider is also responsible for auto scaling, availability, and load balancing. All that you are responsible for is to configure the services in the right way, and you are also responsible for providing the right code. So if you'd want to deploy a Python application using platform as a service, all that you will be responsible for is the configuration and your Python code. All the rest of the things become the responsibility of a cloud provider. Let's look at a few examples. Let's start with compute options. These are basically options that help you to run Python applications, Java applications, or Node.js applications in the cloud. If you are using AWS, then AWS Elastic Beanstalk is a good example of platform as a service. When you're using AWS Elastic Beanstalk, all that you need to say is, this is the code I would want to deploy. And I would want to make use of Java 10 or Java 18. That's all. Everything else is taken care of by Elastic Beanstalk for you. Similar services are provided in Azure and Google Cloud by Azure App Service and Google App Engine respectively. Now, is platform as a service restricted only to compute? Nope. You also have a variety of relational and NoSQL databases as well. Good example of a relational transactional database in AWS is Amazon RDS or the relational database service. In Google Cloud SQL is a good example. Azure SQL database is a good example of a platform as a service database offering in Azure. Platform as a service offerings are not just restricted to compute and databases. You have platform as service offerings in each of the cloud platforms with respect to queues, artificial intelligence, machine learning, analytics, operations, DevOps, and a lot of other things. The important takeaway from this step is when you're going to the cloud, you'd want to prefer going for platform as a service. When you're making use of the platform as a service offerings from the cloud platforms, you are reducing your responsibilities. You will no longer be responsible for operating system, application runtime, auto scaling, availability, and load balancing. I'm sure you're having a wonderful time, and I'll see you in the next step. Let's talk about AWS Elastic Beanstalk. Elastic Beanstalk is the simplest way to deploy and scale your web applications in AWS. Earlier, we talked about platform as a service. AWS Elastic Beanstalk is the platform as a service offering in AWS for running your compute workloads. If you have web applications to run in AWS and you'd want AWS to take most of the responsibility, in that kind of scenario, you can go for AWS Elastic Beanstalk. It provides end-to-end web application management. It supports a wide variety of languages and frameworks. It supports Java, .NET, Node.js, PHP, Ruby, Python, Go. You can even deploy containers created using Docker. There are no usage charges for Elastic Beanstalk, but you need to pay for the AWS resources which are provisioned. For example, if you're using Elastic Beanstalk to create a few EC2 instances and a load balancer, then you need to pay for EC2 instances and the load balancer. You don't really need to pay anything for the usage of the Elastic Beanstalk service. Let's look at some of the features related to Elastic Beanstalk. Automatic load balancing. If you have multiple EC2 instances, you can tell Elastic Beanstalk to configure a load balancer for you. Elastic Beanstalk can also do auto scaling for you, increase and decrease the number of instances based on the load, and it can also perform managed platform updates. If you want to update the OS or if you want to update the runtime, AWS Elastic Beanstalk can do that for you without any downtime. Let's now shift our attention to talking about auto scaling group and elastic load balancing. Applications have millions of users. Therefore, you would need multiple EC2 instances. So you would want to deploy the same application to multiple VMs. How do you simplify creation and management of multiple VMs? I would want to create multiple EC2 instances. How do I do that in an easy way? The way you can do that is by using something called auto scaling groups in AWS. Autoscaling groups allow you to create and manage a group of EC2 instances. You can create an autoscaling group saying, this is the desired capacity. I would want to start with 2 instances. And the minimum it can go up to is this, maybe 1 instance. And this is the maximum. I would want to go at a maximum up to 10 instances. And the autoscaling group can also increase the number of instances and decrease the number of instances based on the load which is coming in. So if you want to manage multiple EC2 instances in AWS, you can go for autoscaling group. And once you have multiple instances, you'd want to be able to distribute traffic between them. That's where you'd go for elastic load balancing. In AWS, one of the options is to manually set up an autoscaling group and manually set up elastic load balancing. However, the easiest way to set up EC2 instances with autoscaling groups and elastic load balancing in AWS is to make use of a platform as a service offering in AWS, which is Elastic Beanstalk. So Elastic Beanstalk helps you to create multiple EC2 instances using an autoscaling group and load balance between them using elastic load balancing. In this step, we got a quick introduction to Elastic Beanstalk. Let's see a demo of it in this subsequent step. I'll see you in the next step. In this step, let's start playing with Elastic Beanstalk. I would go in here and type in Elastic Beanstalk. And I'm making use of Elastic Beanstalk, run and manage web applications. Let's go into Elastic Beanstalk. Amazon Elastic Beanstalk provides end-to-end web application management. Elastic Beanstalk is an easy-to-use service for deploying and scaling web applications and services developed with a variety of languages: Java, .NET, PHP, Node.js, Python, Ruby, Go, Docker. A wide variety of applications can be deployed to Elastic Beanstalk. If I would want to set up an application using EC2 instances, then I would need to first create an EC2 instance, then install the right runtime on it, maybe something like Java or Python, and then install the application down there. And if I would want to have multiple instances, then I would need to manage load balancing for them. I would need to manage autoscaling for them. So all those things become my responsibilities. However, Elastic Beanstalk enables us to give all those responsibilities to AWS. As it says in here, Elastic Beanstalk makes it very, very easy to deploy your web applications. You can deploy your application in minutes. Let's try that out right now. I want to create an application. So what we want to do is to create a web app, and the application name I would say is my first Elastic Beanstalk application. I'll leave the tags empty. Next, we would choose the platform. You can see that there are a wide variety of platforms which are supported: .NET, Go, Java, Node.js, PHP, Python, Ruby, Tomcat, and you can also deploy any containers that you have. What I would want to do is to keep things simple. I'll go for a Python application. So I'll choose Python application. I'll choose the latest Python version which is suggested. And I would recommend you to choose the latest platform version which is present in here. The platform version which we are choosing in here is the version of Elastic Beanstalk. Make sure that you are using the latest version of Elastic Beanstalk which is available at the time you're watching this course. Next, we would need to choose the application code. If you have a Python application, a Python web application that you want to deploy, you can choose that application. What we'll do now is to keep things simple. What we'll do is to use a sample application. The next thing we'll do is to configure more options. If you go to configure more options, you'd see that there are a wide variety of options that Elastic Beanstalk provides for you. As part of software, you can choose if you'd want to enable X-Ray. X-Ray is the tracing service in AWS. If you want to trace your request across multiple microservices and multiple AWS services, you can make use of X-Ray. For now, let's keep it disabled. If you want, you can also enable log streaming and rotating the logs automatically. For now, let's not worry about software or instances. What we'll do is we'll go to capacity. Right now, you'd see that it's a single instance environment type. What I would want to do is to create multiple instances. I would also want to create a load balancer. So what I can do in here is I would go and say edit. And over here, if I scroll up, I would see that it is a single instance environment type. What I would want is a load balanced environment. So what I will do is to choose load balanced. When you choose single instance, only one instance is created. However, if you go for load balanced, you can choose how many instances need to be created. You can configure the min and the max. I'll leave the min at 1 and the maximum I would make it 2. So we are creating a load balance environment with multiple instances, and if you scroll down in the scaling settings, you can also configure how scaling needs to be done. What kind of metrics need to be used to increase the number of instances or decrease the number of instances. I would take the defaults for the scaling triggers as well. So let's go ahead and say save. The other things that you can configure in here are related to security, monitoring, how you want to handle platform updates. You can also set up notifications based on events which are happening in Elastic Beanstalk. You can also configure if you want your Elastic Beanstalk to be part of a VPC. And you can also associate a database with your Elastic Beanstalk environment. The last thing you can do is to add tags with your Elastic Beanstalk environment. What I'll do is I'll take the defaults for all these and I would go ahead and say create app. You can see that the creation of the Elastic Beanstalk environment has now been kickstarted. The creation of this Elastic Beanstalk environment will take a little while. We are creating multiple instances. We are creating a load balancer. What I would recommend you to do is to grab a coffee and I'll see you on the other side. In the last step, we kickstarted the creation of Elastic Beanstalk environment. It took about 10 minutes and at the end of it, I saw this screen pop up. You can see that the creation of the environment is successful. You can see that now the health of the environment is okay, and you can see that a sample application is running, and you can also see the platform details in here. You can see that the application that we are running is Python 3.8, running on 64-bit Apache Linux. And to be able to access the application, we can click the link which is in here. So if I click the link in there, it would take me to the running application. You can see that it says, congratulations, your first AWS Elastic Beanstalk Python application is now running on your dedicated environment in AWS Cloud. If you want to deploy a new version of this application, you can click upload and deploy your own Python web application in there. As you can see in here, Elastic Beanstalk makes it very easy to deploy web applications to AWS. You don't need to worry about EC2 instances. You don't need to worry about auto-scaling groups, or you don't need to worry about load balancing. Everything is taken care of for you by Elastic Beanstalk. That's why Elastic Beanstalk is a platform as a service offering. Now, before we go further and look at what is happening inside Elastic Beanstalk, let's take a step back and look at what's happening outside Elastic Beanstalk. Let's look at what are all the resources that are created by Elastic Beanstalk. If you type in EC2 and go to EC2 or the Elastic Compute Cloud, you'd see that there is one instance which is running. If you click in, you'd see that this instance is created by Elastic Beanstalk. So Elastic Beanstalk has created an EC2 instance, installed Python on it, and deployed the application on it as well. How is this instance created? This instance is created as part of something called an auto-scaling group. If I minimize all these things and go to the end, you'd see that an auto-scaling group is also created. Earlier, when we were creating the Elastic Beanstalk environment, we said we would want minimum of 1 instance and a maximum of 2 instances. If I would want to create a number of EC2 instances, the way we can do that is by creating an auto-scaling group. This auto-scaling group is automatically created for us by Elastic Beanstalk. If you click this auto-scaling group, you'd be able to see that the desired capacity is 1, minimum capacity is 1, and maximum capacity is 2. These are the 2 values that we configured when we created the Elastic Beanstalk environment. In addition to these, Elastic Beanstalk also created a load balancer. If you go to load balancers, you can see that there is a load balancer which is created for us automatically by Elastic Beanstalk. You can see that Elastic Beanstalk is doing a lot of things for us. Let's go back to Elastic Beanstalk. Elastic Beanstalk, run and manage web apps. That's where we are heading towards. And this is the thing that we have created earlier. Let's go in there. Let's now look at more details regarding this specific environment. The home page shows a high-level information about the application which is deployed. You can see the version of the application which is deployed. You can see the health of it. You can see the platform we are making use of. And you can also see some of the recent events. You can see that an EC2 instance is added to the environment. You can see that the environment health has changed from pending to OK, and the environment is launched up. And at the end, you can see that the instance deployment is completed successfully. If you go to configuration, you can see all the details about software, instances, capacity, the load balancer, how you would want to do updates. You'd see details about security, monitoring, and managed updates. If you go to logs in here, so if you click logs in here, you'd be able to request for logs from the application. So I'll say request logs and last 100 lines. And this would create a log file. What I can do is I can go ahead and click download on it. And you can see all the logs related to the application that we have deployed in here. So if you want to look at logs in Elastic Beanstalk, you don't really need to go to the EC2 instance and check the logs. You can directly check the logs in the Elastic Beanstalk console itself. You can also get details about the health of the environment in here. You can see that the health is okay. If you want to look at metrics related to the environment, you can go to monitoring. You can see that right now there is one healthy host. And you can see that there are certain requests which came in. You can see the CPU utilization. You can see the network in, network out metrics as well. If you scroll down, you'll also be able to see a few graphs related to these metrics. If you go to managed updates, you can look at any managed updates that are scheduled for this environment. For example, if there is a security patch for Linux or security patch for Python, these updates can be automatically handled for you by Elastic Beanstalk. If you go to events, you can look at all the events which are happening with your Elastic Beanstalk environment. You can see the events related to the creation of the environment, and you can also see the events related to the actions that we have performed. A little earlier, we looked at the logs. So you can see that there is an event saying pulled logs for environment instances. If you go to tags, you can look at all the tags that are assigned to your Elastic Beanstalk environment. Now, whenever we talk about applications, you might have multiple environments. For the same application, you might have a dev environment, QA environment, staging environment, and a production environment. Elastic Beanstalk also allows you to create multiple environments for your application. How can you do that? I'll go to applications in here and pick up this specific application, my first Elastic Beanstalk application. You can click there and you can see that for this specific application, we have one environment. Let's say this is the dev environment. If you'd want, you can go ahead and create other environments as well. You can say I would want to create a new environment, and you can say I would want to create a QA environment, a staging environment, and a production environment. In addition, Elastic Beanstalk also keeps track of your application versions. So if you want, you can actually upload a new version of the application in here. And once you uploaded a new version of the application in here, you can go ahead and say, I'd want to deploy this to a specific environment. I would want to deploy this to a dev environment or a QA environment or a staging environment. So Elastic Beanstalk by default has the capabilities to manage different versions of your applications, and you'll be able to create multiple environments, and you'll be able to deploy a specific version to a specific environment. In this step, we played around with Elastic Beanstalk. We saw that Elastic Beanstalk makes it very, very easy to deploy web applications to AWS. You don't need to worry about EC2 instances. You don't need to worry about load balancing. You don't need to worry about autoscaling group. Almost all the things are automated for you. The best practice in the cloud is to keep the resources running for the minimum amount of time. So what I'll do now is to go to applications, pick up this specific application, and delete this application. So let's go ahead and say actions, delete application. I'll type in the name of the application in here as well. So my first Elastic Beanstalk application, let's go ahead and say delete. The deletion of the application will take a little while. What I would recommend you to do is to take a break, and I'll see you on the other side. Almost every cloud platform offers a number of services related to containers and container orchestration. In this step, let's understand the need for containers and container orchestration. The journey towards container and container orchestration started with microservices. Microservices is one of the most popular buzzwords of the last few years. Almost every enterprise out there is heading towards microservices architecture. So what is a microservice architecture? The fundamental concept behind microservice architecture is, instead of building a large monolith application, how about building very, very small, independently deployable microservices? So microservices architecture is all about building small, focused microservices which are independently deployable. If you need to make a change to any of these services, all that you need to do is to change that service independently and deploy it. So if I would want to make a change to customer service, I'd need to just make change for the customer service alone, and I can deploy it. The great thing about the microservices architecture is that it provides you with flexibility to innovate and build applications in different programming languages. If I had a monolith application, I can only make use of one programming language to build it. However, with microservices, you can use different programming languages to build your microservice. For example, I can build movie service in Go, I can build customer service in Python, I can build review service in Node.js, and I can build booking service in Java. However, as they say, with great flexibility comes great problems. One of the challenges with microservices architectures is the fact that deployments become very complex. The way you deploy and monitor a Go application might be different from how you deploy a Python application. And this might be different from how you deploy a Java or a Node.js application. So the job of your operations team becomes really difficult. They would need to have individual ways of deploying each of these applications, individual ways of monitoring each of these applications, and that makes their job really difficult. How can we have one way of deploying and monitoring Go, Java, Python, or JavaScript microservices? That's where containers come into picture. Docker is one of the most popular ways of building container images. What does Docker allow you to do? Docker allows you to create Docker images for each of these microservices. And your Docker image contains all the needs of a microservice. It contains the application runtime. For example, if you're building a Java microservice, you might need JDK. If you're building a Python microservice, you need Python. If you're building a Node.js microservice or a JavaScript microservice, you'd need Node.js. The Docker image also contains the application code and all the dependencies that the application needs to run. And therefore, you can run your Docker image the same way on any infrastructure. Because your Docker image has everything that a microservice needs, you can run it in your local machine, your corporate data center, or in the cloud the same way. In summary, a Docker image contains everything that your microservice needs. If you're building a Java microservice, it would contain Java, your application code, and the dependencies. If you're building a Python microservice, it would have Python, the Python code, and the dependencies for it. And therefore, you'd be able to take this Docker image and run it the same way on any infrastructure. So what are the advantages of going for Docker? Number one, Docker is cloud neutral. Whether you're making use of AWS, Azure, or Google Cloud, you can run your Docker image the same way. Docker also brings in standardization. The way you do deployment, monitoring, and logging, everything becomes the same. It does not matter what's inside a container image. It might be a Java application, a Python application, or a Node.js application. Your operations team does not worry about it. They would do deployment, monitoring, and logging the same way. In addition, Docker containers are lightweight. The alternative to Docker containers is to make use of something called virtual machines. In a virtual machine, we had guest OS, and the guest OS has a big performance impact. It used to consume a lot of CPU. Because Docker containers don't have a guest OS, they are lightweight. Docker also provides very good isolation for your containers. Even though multiple Docker containers can run on the same infrastructure, Docker can ensure that one container does not impact the other running containers. So it's almost like each container is running in its own box, in its own isolated environment. If I have to summarize all that Docker enables in one word, it is standardization. In this step, we talked about Docker and containers. I'll see you in the next step. In this step, let's focus on container orchestration. In the last step, we talked about Docker and containers. We saw that Docker brings in standardization. Now, what is the need for container orchestration? Let's imagine that you have Docker images built for each of these microservices. So you have Docker image for movie service, customer service, review service, booking service, and fare calculation service. Now, you'd want to deploy them to a production environment. You'd want to be able to run these microservices in your production environment. The thing is, when you go for a microservice architecture, there are a number of complex needs. Let's look at one of these requirements. I'd want to be able to run 10 instances of microservice A container, 15 instances of microservice B container, and so on and so forth. Let's look at some of the important features that are typically needed in microservices architectures. Number one is auto scaling. The load on each of these microservices can be different. A review service might have a lot of load, whereas the booking service might have less amount of load. So you'd want to increase the number of containers for a specific microservice or decrease the number of microservices based on the number of requests or based on the number of users. So you'd want to be able to scale up and scale down the containers based on the demand. You'd also want service discovery. You'd want to help microservices find one another. A review service might want to talk to movie service, or it might want to talk to customer service. You don't want to hardcode the URL of the movie service and the customer service in review service. You'd want the review service to be able to dynamically find out the customer service. This is what is called service discovery. We already talked about the fact that we would have multiple instances of each of these microservices, and therefore load balancing becomes important. You'd want to be able to distribute load among the multiple instances of a specific microservice. You also want self-healing. Whenever we go to the cloud, we assume failure. Some of the instances of your microservices will fail. So you want to be able to detect failure. You want to be able to identify that a specific container is not healthy. And you'd want to be able to replace it with a healthy instance. So you'd want self-healing. You want to do health checks and replace failing containers with healthy containers. And you also want zero downtime deployments. Before the emergence of microservices architecture, you had one monolith. Maybe you are deploying it once a week, or maybe once a month, or once every few months. But when you're going for microservices architecture, you are doing constant deployments, maybe a few times a day. And therefore, having zero downtime when you're doing deployments becomes really, really important. You'd want to be able to release new versions of customer service, review service, movie service without having any downtime. So what we are talking about is the fact that having individual containers is not sufficient. We would want to be able to run multiple instances of these containers and orchestrate them. And that's where container orchestration comes into picture. With a typical container orchestrator, you can create a cluster. You can say, I would want a cluster of EC2 instances, or I would want a cluster of virtual machines. And you can use the container orchestrator tool to deploy your microservices to the cluster. So you can provide the container image and the configuration to the container orchestrator, and the container orchestrator would deploy the microservice to the cluster. In addition, typical container orchestrator tools provide all the features that we are talking about in here: auto scaling, service discovery, load balancing, self-healing, zero downtime deployments. These are some of the basic features that are provided by most container orchestrators. Now, what are the container orchestrator solutions in AWS? Let's look at them right now. Kubernetes is one of the most popular container orchestrator tools today. And the service in AWS, if you want to make use of Kubernetes, is Amazon EKS, Elastic Service for Kubernetes. I'm calling this a cloud neutral option because Kubernetes can be run in AWS, Azure, Google Cloud. So there are managed services for Kubernetes in almost all the cloud platforms. And one important thing for you to remember is that EKS does not have a free tier. So if you create an EKS cluster, even if you are in a free tier, you would need to pay for it. AWS also has a AWS specific container orchestrator solution. It's called Amazon ECS or Amazon Elastic Container Service. Even with ECS, you can create a cluster and you can deploy your microservices to the cluster. In addition to EKS and ECS, you have Fargate. Fargate is serverless ECS and EKS. When you're using ECS or EKS, you need to manage the cluster. You need to decide how many EC2 instances should be in the cluster. You need to decide what operating system, what hardware should be used for the EC2 instances in the cluster. However, when you're using Fargate, you don't need to worry about all that. You just need to specify your microservice configuration and Fargate would take care of the cluster. So I would call Fargate as serverless ECS and EKS. So if you want to use ECS and EKS in a serverless way, you can go for Fargate. Similar to EKS, it's very, very important to remember that AWS Fargate also does not offer a free tier. In this step, we talked about the need for container orchestration and we talked about the different container orchestration solutions in AWS. We talked about the cloud neutral option based on Kubernetes, which is Amazon EKS or Amazon Elastic Kubernetes Service. We talked about the AWS specific option, which is Amazon ECS or Amazon Elastic Container Service. And we also talked about how we can use EKS and ECS in a serverless way. That's where we can go for Fargate. I'm sure you're having a wonderful time and I'll see you in the next step. Starting this step, let's look at a demo for ECS, Elastic Container Service. I'll type in ECS in here, Elastic Container Service. highly secure, reliable, and scalable way to run your containers. Let's go and pick this up. Amazon ECS makes it easy to deploy, manage, and scale Docker containers. You can run applications, services, and batch processes. Let's get started with ECS. What we are doing now is we are making use of Amazon ECS using Fargate. So we are using the serverless approach to run ECS. Another important thing to remember is that Fargate does not have a free tier. So this demo is not part of the free tier. What I would recommend you to do if you want to remain in the free tier and if you don't want to be billed is to just watch the video and do not do the demo. Whenever we are talking about ECS, there is a hierarchy. The first thing that we would need to create is something called a cluster. Cluster is nothing but the hardware that you would need to run your applications. So you'd create probably a cluster with a set of nodes. What do you want to run in your cluster? You want to run microservices. And you might have multiple instances of each of these microservices. That's why you have concepts of containers, tasks, and services. Container is nothing but the final container that you would want to run, the container of a microservice. There are certain situations in which you might want to run two containers together. And that's why in ECS, you have a concept of task. A task is nothing but a group of containers. Most of the times in a task, you would just have one container. But task also gives you the flexibility to run multiple containers. And service is nothing but a group of tasks. For example, let's say I want 10 instances of a microservice. I can define that on my service. You can say I would want to have 10 instances of this specific task, and the service would ensure that there are 10 instances always running. This might be a little complex to understand right now. Let's do the demo and you'll be able to understand it really well. So the first thing that we are choosing is what application, what microservice you'd want to deploy to your cluster. Let's choose the sample app which is present in here. You can see the Docker container image for it in here. The Docker container image is HTTPD, version is 2.4, and we are configuring a memory of 0.5 gig. So we are configuring 512 MB of memory for it, and we are configuring 0.25 virtual CPUs for this specific container. So as part of our container definition, we define what is the image that contains the microservice, how much memory we want, how much CPU do you want. The next thing you would configure is a task definition. A task definition is nothing but a blueprint for your application. For now, let's keep it simple and take the defaults for this and click next. So we have defined the container and the task until now, and we are ready to define our service. A service allows you to run and maintain a specific number of tasks. Earlier, we created a task for our sample app. And now we would want to say, I would want to have at least 2 instances of this task running all the time. That's where you can configure your service. What I'll do is I'll click edit in here. And I would say I would want to have 2 instances of this specific task running. In addition, I also want to make use of an Elastic load balancer. So I would go ahead and choose a load balancer type of application load balancer. Let's take the defaults for the rest of the things and say save. So as part of our service definition, we are configuring that we would want 2 tasks and we would want to use a load balancer. I would say next. On the next screen, we can configure the cluster. As it says in here, the infrastructure in a Fargate cluster is fully managed by AWS. Fargate provides you a serverless option. You don't really need to worry about the cluster. You don't need to worry about what are the EC2 instances that are behind the cluster. You don't really need to worry about what is the hardware, what is the software, what is the operating system that you'd want to associate with your EC2 instance. When we are making use of Fargate, all those decisions are made for you by AWS. All that you need to worry about is defining your workload. We have already defined our workload as part of our container, task, and services. So let's go ahead and run it. I'll say next. On the next screen, we can review the configuration we have set up. So we have a container, task, and a service, and we have also configured a cluster. So we are running a sample app. We said we would want 2 instances of the sample app, and we took the default name for the cluster. Let's go ahead and say create. AWS has started creating resources for our service. As it says in here, it might take up to 10 minutes. Right now, the status is 7 of 10 complete. I would recommend you to leave this window running until it becomes 10 of 10 complete. While you wait for the service to get ready, go ahead, grab a coffee, and I'll see you on the other side. In the last step, we triggered off the deployment of our Amazon Elastic Container Service. And it took about 10 minutes before the entire service was ready. You can see that now the status is 10 of 10 complete. The cluster is created and the service is ready as well. And you can see that there are a lot of other resources that are created for us. What I'll do now is to go ahead and say view service. This would take us to the service which was deployed. The other way to get to this would be just to type in ECS, go to Elastic Container Service, and over here you can see the details of the cluster which we have created. So you can see the default cluster which we have created in here. We are making use of Fargate. So let's go ahead and say default, and this would also take you to the cluster, and inside the cluster you can see all the details in here. You can see an overview of all the things that are part of the cluster in here. You can see that we have 2 Fargate tasks which are running. You can see that we have 1 active service. Let's look at the details of this service in here. So this is where we have a service running, the sample app service which we have created. If you want to deploy more microservices, you can go ahead and create new services in here. For now, let's look at the details of the service which we have created. The service name is sample app service. You can see that the status is active. You can see that the service is associated with a specific task definition. And we would want 2 tasks of that running. And currently there are 2 tasks running. We are using a launch type of Fargate. When we are creating this service, we said we would want to create a load balancer. Where is the load balancer created? Let's quickly explore that. I'll go to EC2. That's where you can look at load balancers, virtual servers in the cloud. We have 1 load balancer which is running. You can see that this is created by ECS. You can see ECS in the name in here. And you can get the URL of the load balancer from here. So this is the DNS name which I would go. This is the DNS name which I'm going to copy. So let's copy this and I'll open up a new tab and run that URL. You can see that our Amazon ECS sample app is running behind that specific load balancer. So the service has also created a load balancer for us. Let's go back to the service. I'm going back to ECS, Elastic Container Service. And let's go to the default cluster. And this is the service which we are talking about right now. What I'll do now is I'll go inside this specific service. So let's click this link. And you can see all the details about the service in here, which cluster it is running as part of, what is the status of it. You can see the task definition which it is associated with. And also you can see that there are 2 tasks that are running. If I go to tasks, I can also look at the details of the specific tasks which are running in here. So these are the 2 tasks which are running. If you go to events, you'll be able to see the different events which happened as part of this specific service. When we started the service up, we said we would want 2 tasks. And it took a little while before the tasks were ready and the deployment was completed. And once that is done, the sample app service has reached a steady state. If you'd want, you can also configure auto scaling. You can increase the number of tasks and decrease the number of tasks based on the load which is coming in. You can also look at the metrics in here. You can see the CPU utilization, memory utilization for this specific service. And you can also look at the logs. You can go to logs and look at the different logs for different tasks that are running as part of this specific service. So if you want to look at the logs of the different tasks which are running, you can look at them directly in the ECS console. Now, to understand the need for a service, let's do a small activity. What I'll do is I'll go to tasks and I'll pick up one of the tasks which is present in here. Let's pick this task up and I would say stop. So what I'm doing is I'm killing a task which is running as part of our service. Let's stop this. So our task is now stopped. Let's see what would happen. Let's give it a couple of minutes. In the task, if I go to stopped status right now, you'd see that there is one task which is status running right now, but the desired status is stopped. You can see that within a little while, this last status is now changing to deprovisioning. So this task is now being killed by the service. And if you go to running, you would also see another task that is launched up and it's running as well. To understand this further, let's go to events. I'll go back to services, pick up our service and go to the events in here. So what we said is we would want to kill one of the tasks. So what has happened is the service has started to kill that specific task. So it started draining connections on that specific task. And what we said earlier is that we would want two tasks to be always running. So the service recognizes that right now only one active task is ready. And that's why it starts up a new task. It's starting up a new task and the task is ready. So it's adding in and finally it reached the steady state. So you can see that as soon as I killed a task, the service is able to recognize it and launch up a new task so that it can satisfy the requirement of having two tasks running always. So the goal of a service is to ensure that the desired number of tasks are always running. So if you have a microservices architecture and you'd want to deploy a number of microservices, that's where you would go for container orchestration. And a AWS specific container orchestration solution is Amazon ECS. And what we have done is we made use of it in a serverless way. We made use of Fargate and we were able to run a ECS service. As part of our service definition, we said we would want two tasks to be running always. And the service would ensure that two instances of that specific task are always running. If I would want to add a new microservice, if I would want to deploy a new microservice to the cluster, I can go and create a new service. So I can create a task definition, I can define the number of tasks, create a service, and deploy it to the cluster. In this step, we got a quick demo of using ECS in a serverless way. Let's go ahead and delete this cluster. Delete. And I would enter the phrase, and I would enter the phrase delete me in here. And I would go ahead and say delete. The deletion of the cluster will take a little while. I'll see you in the next step. In this step, let's start with serverless. What do we think about when we deploy an application? If you are like me a few years back, you'd think about where to deploy this. What kind of server should I make use of? What should be the operating system? I'd be thinking about how to take care of scaling. How do we take care of availability and load balancing? What if you don't really need to worry about servers and you can focus just on code? That's where serverless comes into picture. One of the first misconceptions about serverless is that serverless is no servers. That's not true. Serverless does not mean no servers. Even when you're using serverless applications, in the background, the application still runs on a server. However, the important thing is you don't really need to worry about the server. The cloud platform takes care of everything for you. All that you need to focus on is the code. So for me, serverless is all about having zero worry about infrastructure. You have zero visibility into the infrastructure as well. So you don't even know where your application is running. With serverless, you get flexible scaling and automated high availability. You don't really need to worry about how to make your application highly available. The serverless service would take care of it for you. And if you have varying loads, even that is taken care of by the serverless service. It would scale up the number of instances, scale down the number of instances based on the load. So it provides you with flexible scaling. And the most important part of serverless for me is pay for use. When you're making use of a serverless service, you don't pay for servers. You pay for the number of requests. You pay for use. Ideally, when you have zero requests, you don't really need to pay anything at all. So serverless for me is all about focusing on code and leaving it to the cloud managed service to take care of all that is needed to scale your code to serve millions of requests. You pay for requests and not for servers. And the most popular serverless service in AWS is AWS Lambda. AWS Lambda is truly serverless. You don't need to worry about servers, scaling, or availability. You only worry about your code. You pay for what you use. You pay for number of requests that are coming into your Lambda function. You also pay for the duration of the request, how long each request is running in for. And you'll also pay for the memory that is made use of by your Lambda function. The great thing about AWS Lambda is that it supports a wide variety of programming languages. You can build your Lambda functions in Java, Go, PowerShell, Node.js, C#, Python, Ruby, and a lot of other languages. In this step, we got a quick introduction to serverless and AWS Lambda. I'll see you in the next step. In this step, let's look at a demo for AWS Lambda. Lambda, Lambda, run code without thinking about servers. Let's click that. Right now we don't have any Lambda functions. What we want to do is to create one. So let's go ahead and create a Lambda function. I want to author one from scratch. So we'll start with a simple hello world example. Over here, we need to provide the basic information. I would want to create a Node.js Lambda function. So I'll call this my Node.js Lambda. You can see that there are several runtimes which are supported by Lambda. .NET, Go, Java, Node.js, Python, Ruby. So there are a wide variety of runtimes which are supported. I'll take Node.js and the latest version of it right now, and I would say create function. This would create our Lambda function. Typically, this should take about 5 to 10 seconds. So let's wait. At the end of which, your function is ready. Successfully created the function, my Node.js Lambda. And if you scroll down, you can look at the code for this. If you're not familiar with Node.js, or if you're not familiar with JavaScript, this might be a little tricky code to understand, but don't really worry about it. What we'll do now is we would want to test this. So I'll go ahead and say test. And to be able to test our Lambda function, we will need to create a test event. I'll call this first event. And I'll scroll down. You can see the default event JSON content in here. That looks good. So let's use that, and I'll say save. You can see that it says the test event, first event, was successfully saved. And now I can go ahead and take the first event, and I can say test. And you can see the execution results right in here. You can see that we are executing the first event, and the response which is coming back is status code 200, and the body contains hello from Lambda, and the body attribute contains hello from Lambda. You can also see the logs from the function in here. You can also see that our specific request is assigned a specific request ID. Now, if you go ahead and test it again, you would see that the request ID would change. However, most of the other things remain the same. Now, if you look at the response, where is it coming from? Where is the status code and body where are the status code and the body attributes coming in from? What I can do is to go to index.js in here. This is where we are defining the response. You can see that we are returning a JSON back, status code 200, and the body is hello from Lambda. Now, what we'll do is we'll make a small change in here. So instead of saying hello from Lambda, I would say hello from my first Lambda function. And in addition, I would also add in a console.log. So over here, I can say console.log. So I would want to log something to the log. What is the thing I would want to log to the log? I would want to log the event itself. Whatever JSON event is coming in, I would want to log it as is. So the code for it in JavaScript is console.log event. Now I would say deploy to deploy the changes. So the code is now deployed. So it says successfully updated the function my Node.js Lambda. And I can go ahead and test it again. Let's go ahead and test. You can see that we are making use of the first event, and the response back is saying hello from my first Lambda function. And you can see the logs in here. You can see that one of the things which is printed in here is the event itself. The first test event contains this JSON, key value 1, key value 2, key value 3. How can I see this value? Key 1, value 1, key 2, value 2, key 3, value 3. The way you can do that is by clicking test again and saying configure test event. You can see the JSON that is associated with the first event in here. It is key 1, value 1, key 2, value 2, key 3, value 3. Let's change one of these. Let's make this key 4 and value 4. So let's change the test event, the first event, and let's say save. And run the test again. You can see that now the event which is printed is key 4, value 4. You can see how easy it is to change the code for your Lambda function and run it. The thing is, the Lambda function that we have created right now is all set to handle millions of requests. Even if there are millions of requests coming in, AWS Lambda would automatically scale it to meet all the requests which are coming in. That's the beauty of going for a serverless approach. In this step, we created our first Lambda function. Let's explore this further in the next step. In the last step, we created our Lambda function. In this step, let's explore Lambdas further. If you scroll up, you'd be able to see Monitor, where you can monitor the metrics of your Lambda function. So you can go to Monitor and you can look at all the metrics related to your Lambda function. So you can see how many invocations were made. You can see the duration of each invocation. If there were multiple invocations, you can see what is minimum, what is maximum, what is the average duration. And you can also see if there are any errors while invoking the Lambda functions. The Lambda function metrics are coming in from CloudWatch. Lambda actually sends your runtime metrics to Amazon CloudWatch. That's where all the metrics are consolidated, and these graphs are shown in here. You can also look at the logs for your Lambda functions in here. So if you go to logs, you can see the recent invocations and the log for each of these invocations. If you expand this, you'll be able to see the details of the specific invocation. You can see that the duration it took to execute that request was 1.91 milliseconds, and you were billed for 2 milliseconds. And you can see a few more details about the log in here. I can click the link which is present in here to see the logs. If you click this, the CloudWatch logs is opened in a new window, and you can see all the logs for that specific invocation in here. You can see that we are printing the event in here. I'll close this window. Let's go back to the Lambda. Let's go back to the Lambda function. So metrics and logs, both of them are coming from CloudWatch. CloudWatch metrics and CloudWatch logs. For tracing, the service in AWS is AWS X-Ray. Right now, you'll not be able to see any tracing in here, because if you'd want tracing, you'd need to explicitly enable it. How do we enable tracing for our Lambda function? The way we can do that is by going to configuration. If you scroll down, you'd see something called monitoring and operation tools. And this is where you can go ahead and say edit. And I would want to enable X-ray in here. So I would want to activate tracing. When you enable and choose save, the Lambda console verifies your execution role permissions. There is an execution role which is associated with our Lambda function, and the Lambda function needs permissions to write to X-ray, to write the trace to X-ray. And what would happen is, as soon as we enable and save it, the permissions would be given to the Lambda function. So the Lambda console will give the permissions to the Lambda function execution role. So let's go ahead and save this out. We'll talk about permissions in AWS in depth when we talk about IAM, or Identity and Access Management. For now, we have enabled tracing for our Lambda function, and we also give permission to the Lambda function to be able to write a trace to X-ray. So what I can do now is again go over to our code, and now I can test this again. So let's go ahead and execute a few tests. So I've executed about 5 tests, and I would go to monitor now. If you go to monitor and go over to traces, and if you actually refresh, it took a little while for the traces to come up. It took about a couple of minutes. After that, I was able to start seeing these traces in here. So you can see the traces coming in. So if I click the trace, I would also be able to see the details for that specific trace. So you can see that we are calling the Lambda function, and the Lambda service is actually creating the Lambda context, and the Lambda function is invoked. If you scroll down, you'll also be able to see the breakdown of the time it took to execute the Lambda function. Now over here, we are doing a very, very simple thing. We are just calling one Lambda function. But if we had a complex flow, if we had one Lambda function calling another and that function calling something else, then tracing will be really, really useful to understand what's happening with your Lambda functions. Let's now go back to our Lambda function. So I'll go back to Lambda, run code without thinking about servers. We were exploring the my Node.js Lambda function. Until now, we looked at the different ways to monitor your Lambda function. Metrics, logs, these are provided in integration with CloudWatch, and you can also enable tracing for your Lambda function. This would be done in integration with AWS X-Ray. There are a lot of other configuration options that are present with Lambda function. Let's explore them right now. If you go to general configuration, you'd be able to see that you'd be able to configure memory, ephemeral storage, and the timeout. Let's click edit in here. You can assign memory with your Lambda function. The default is 128 MB and you can assign up to almost 10 GB. It's about 10,240 MB. I would expect the maximum value to change with time. So you might see a different number in here. Always remember that you can configure the amount of memory that you'd want to associate with your Lambda function. Amount of memory is a very important configuration because this would affect the amount of CPU which is allocated as well as the cost. So if you increase the memory, you would pay more. And if you increase the memory, the amount of CPU which is allocated to your Lambda function is also higher. The next configuration which is present in here is ephemeral storage. You can associate a temporary storage or an ephemeral storage with your Lambda function. Typically, it's directory/temp. The default ephemeral storage which is associated with your Lambda function is 512 MB. And you can increase this up to 10 GB. The next configuration in here is the timeout. The default timeout is 3 seconds and you can increase this up to 15 minutes. So if I type in 16 in here, you would see that it says maximum timeout is 15 minutes. So the maximum invocation time of a Lambda function can only be 15 minutes. That's 90 seconds. So Lambda function is not a suggested architecture if you would want to run long running batches. Let's remove 16 in here. Let's go back to 0. And the next thing you can configure in here is the execution role. Your Lambda function might need to talk to a database. Your Lambda function might store something into, let's say, S3, which is an object storage service in AWS. And to be able to do that, your Lambda function needs permissions. The way you would give permissions to your Lambda functions is by making use of the execution role. I'll do a cancel in here. And let's go back to other configuration which is in here. One of the important things that you can configure for your Lambda function is a function URL. Right now we have created a Lambda function. Anybody wants to call this Lambda function, they can come to the Lambda console and execute it. However, you might want to give a URL for your Lambda function. That's where you can go ahead and create a function URL. You can go ahead and say create function URL. As you can see in here, it assigns a HTTP or HTTPS endpoints for your Lambda function. You can choose what kind of authentication you would want for your function URL. You can either use IAM, Identity and Access Management. That's the authentication service in AWS. You can either use that, or you can say this is a public function. I don't want any authentication for it. One of the important things that you need to remember is that if you don't have any authentication for your Lambda function, then anybody can call it. And if you have a lot of invocations, if you have millions of invocations for that specific Lambda function, then you will exceed the free tier and you might need to pay for the invocations as well. If I go ahead and actually save this, a URL would be created for us and we can use that URL to invoke the Lambda function. So what I'll do now is I'll go ahead and save this. And a URL is now assigned. So you can see that there is a specific URL which is assigned to this Lambda function. I can go ahead and use this URL to invoke the Lambda function. And you can see the response which is coming back. Hello from my first Lambda function. Now it is not recommended to have a public URL like this assigned to your Lambda function. So I would go ahead and delete it immediately. So I would say delete and delete the public URL. Next, you can also configure environment variables. You might have multiple environments, dev, QA, stage, and production. And in different environments, you might have different values for your environment variables. This is where you can configure your environment variables. I'll say edit. And as you can see, the environment variables are key value pairs. If you'd want to add an environment variable, let's say I'll call this environment. And I would say the value for this is dev. You can configure your own environment variables in here. In addition, there are also predefined environment variables which are made available to you by Lambda itself. If you click learn more in here, this would open up a new tab where you will be able to see a little bit of documentation about the environment variables. Over here, if you scroll down, you'll be able to see the list of environment variables which are predefined by Lambda function. For example, AWS region, which region the Lambda function is running in. this is made available as an environment variable. You can also get the execution environment details. You can also get the name of the Lambda function, the memory size, the memory assigned, or the memory available for that specific function. You can get the function version and a lot of other details from the environment variables. And the way you can access this environment variables is through simple code. In your Lambda function, if you're writing a Node.js Lambda function, you can say process.env.aws_region. This would get you the region. If you are using Python, then it's os.environ AWS region. And similarly, you have the code for other languages in here. We are making use of Node.js. So what I'll do is I'll use this process.env.aws_region. So let's copy this. I'll go back to our Lambda function. I've configured my own environment variable as well, environment with the value of dev. What I'll do is save this. And I'll go back to code of our function. And over here, I would want to go back to index.js and hello from my Lambda function executing in a specific region. So I'll say plus and put this value in process.env.aws_region. Let's deploy this and let's test it. You can see that the response is now hello from my Lambda function executing in AP-South1. I'm using the Mumbai region, which is AP-South-1, and that's the reason why you are seeing AP-South-1 in here. Similar to this environment variable, you can also make use of the other predefined environment variables which are present in here. You can try running it with AWS.execution-env as well. So if I would want to see the execution environment, I can go in here and I can, instead of AWS_region, I can paste in AWS_execution_env. So this would give us the details of the execution environment. We have also defined our own environment variable. We defined an environment variable called environment. So if I change this code and put environment in here, process.env.environment, it would return the value that it would log the value that we have configured for environment. So let's deploy this change and test this. And you can see that it's showing undefined. Hello from my first Lambda function executing in undefined. Let's see why it's coming in as undefined. Let's go over to configuration and let's look at our environment variables. We do have an environment in here. So environment dev. And let's go back to index.js. There's a typo in here. I typed in environment. A T is missing in here. So let's deploy it again and test it. You can see the value is in here, dev. So you can configure environment variables for your Lambda function in configuration. If you want, you can associate tags with your Lambda function. You can also run your Lambda function in a private network. We already looked at monitoring and operation tools. This is where you can configure the integration with Amazon CloudWatch and X-Ray. This is where you can play with logs, metrics, and tracing as well. The last thing that we'll be looking at regarding Lambda function is concurrency. The reason why we go for Lambda functions is to keep things simple. We just write code and scaling and everything else is taken care of by Lambda for us. So if there are 1,000 requests or 10,000 requests which are coming in, Lambda would automatically handle them for us. Lambda would be automatically scaling up. However, there are limits to this scaling. You can see a configuration called unreserved account concurrency in here. You can see that the default value is 10. This default value changes with time. AWS has been constantly reducing this value over a period of time. Right now it is 10. The unreserved account concurrency represents how many Lambda function executions can be happening in parallel across your account. So by default, in a AWS account, you can only have 10 concurrent Lambda executions. However, the thing is you can change that. If you want to change that, you can go ahead and say edit, and you can reserve concurrency. You can say I would want to allow 1,000 or 10,000 concurrent executions. I'll cancel that and go back to concurrency configuration. Another thing you can configure in here is provisioned concurrency. To understand provisioned concurrency, let's take a simple example. Let's say you have set the function concurrency to 10,000. So you are allowing 10,000 invocations for your Lambda function in parallel. Let's say the number of concurrent executions of your Lambda function right now is 100. And let's say in the same moment, there are 1,000 requests which are coming in. To handle this request, Lambda needs to immediately scale up the number of your available Lambda function instances. And typically, whenever there is a sudden increase of load like that, there is a small delay in handling these requests. And because of this, there might be a fluctuation in latency. If you want to avoid that kind of fluctuation, you can say, I would want to configure provisioned concurrency. I can go in here and configure that I should always have 1,000 instances of a Lambda function ready to handle requests. However, it's very, very important to remember that the pricing for provisioned concurrency is little bit more expensive. So you need to pay for provisioning the concurrency as well as execution. In summary, by default, across your account, there are only 10 concurrent executions of Lambda functions allowed. However, if you want, you can increase the function concurrency. Let's say you can configure it to 10,000 or 100,000 or whatever you want. The other important thing to remember is that by default, because a Lambda instance can take a little while to get ready, there would be fluctuations in latency. And if you don't want fluctuations in latency, you can make use of provisioned concurrency. However, provisioned concurrency is a little bit more expensive. In this step, we played around a little bit more with our Lambda function. We looked at a lot of configuration which is possible with your Lambda function. In this step, let's review some of the important AWS services related to compute. The most primitive way of running applications in AWS is to make use of EC2. Use EC2 to run your instances and use Elastic Load Balancing for load balancing between them. So this is the traditional approach, virtual servers plus load balancing. If you'd want complete control over your operating system, or if you want to make use of custom software to run your applications, then you can make use of this approach. Most of the times, it is recommended to go with platform as a service offerings in AWS because they would take care of scaling, availability, and load balancing. Let's start with AWS Elastic Beanstalk. AWS Elastic Beanstalk simplifies the management of web applications and batch applications. With AWS Beanstalk, all that you need to say is this is the code and this is the runtime I would want. And AWS Elastic Beanstalk can automatically create EC2 instances and Elastic Load Balancing for you. The next services we looked at are related to container orchestration. Kubernetes is the most popular container orchestration solution, and AWS provides a managed service for Kubernetes, which is Elastic Kubernetes Service or Amazon EKS. AWS also has its own container orchestration solution called ECS or the Elastic Container Service. If you want to run ECS or EKS in a serverless way, you can go with AWS Fargate. If you want to build your code or your functions in a serverless way, you can go for AWS Lambda. As you can see, AWS provides a wide variety of compute options to run your applications. I'm sure you're having a wonderful time, and I'll see you in the next step. In this step, let's look at a few scenarios related to compute services in AWS. You want to run a serverless function in response to events. The best way to do that is by AWS Lambda. You want to deploy a Python application using a managed service. The key word is managed service, so we can assume that we would want to go for a platform as a service offering, and that's where we can make use of AWS Elastic Beanstalk. When you are using Elastic Beanstalk, you don't need to worry about creating a load balancer or creating an auto-scaling group or individually managing the EC2 instances. All that you need to tell Elastic Beanstalk is that you'd want to run a Python application, and this is the code for it. And AWS Beanstalk would set everything up for you. You want to quickly set up a Kubernetes cluster in AWS. What can you do? You can go for EKS, Amazon Elastic Kubernetes Service. You want to set up a complex microservices architecture in AWS. If you want to deploy a simple application, then Elastic Beanstalk is the way to go. However, if you want to set up a complex microservices architecture, that's when we are talking about container orchestration. So you would either go with Elastic Container Service or you would go with Elastic Kubernetes Service. So you would go with ECS or EKS. If you want to go with a cloud neutral solution, probably you would go with Kubernetes and therefore you go with EKS. The next scenario, your application needs customized OS and custom software installed. If you'd want a customized OS and custom software and you'd want to make use of custom software, typically the solution is to go with Amazon EC2. So you're going with infrastructure as a service. In this step, we looked at a few scenarios related to compute services in AWS. I'm sure you're having a wonderful time, and I'll see you in the next step. In this step, let's talk about some of the best practices related to managing costs in the cloud. With great power comes great responsibility. Cloud or AWS provides you with ability to create powerful resources. However, it is very, very important to understand the associated costs. There are 5 best practices I would always recommend when you're making use of the cloud. The first one is, for the first week, monitor the billing dashboard every day. How do you get to the billing dashboard? Right now, you might be actually logged into your user account using IAM user. So you are making use of in28minutes_dev IAM user, and we are logged into our account and we are playing with it. Now, if you go over to in28minutes_dev and if you click billing dashboard in here, what you would see is that you don't have the permissions to access billing information for this account. And it says contact your AWS administrator if you need help. The way we can provide access to billing information to IAM users is through the root account. So what we would do now is we will sign out of the in28minutes_dev account. So I'll go in here and I'll say sign out. And what we want to do now is to log back into the management console. So I'll say sign into console. We would want to log back in as a root user. So I'll use sign in using root user email, which is the link which you see right below sign in. So I'll click this link, and over here I can sign in with my root user. The root user is nothing but the email address which you use to create your AWS account. So I'll enter my root user email address. I'll click next. I'll also enter my root user password, and I would say sign in. And now you can see that I am logged into my root account. And over here, I'll click the account name and I can go over to account. This is where you can manage your account. One of the things you can do as part of your account management, if you scroll further down, is to configure IAM user and role access to billing information. We have already provided our IAM user with administrator access. So from the IAM access perspective, he's set. So what we can do in here is to go ahead and say edit and say activate IAM access, and you can click update. So now it says IAM user role access to billing information is activated. Now that we have completed making the change that we wanted to do, we would want to log back in as the IAM user. What I would do is actually go into IAM and get the URL for this specific account. So let's go over to IAM. This is where I can find the sign in URL for IAM users in this account. You might have already bookmarked this, so you can pick up that URL. Once that URL is copied, I would go ahead and sign out of my root account. And now I can go in to the URL that I copied earlier. This is the direct URL for my account. And over here, I can enter my IAM user credentials. So I can enter my IAM user credentials and I can use these to sign in. And now if I go over to billing dashboard, this is where you can see your billing information. Right now, you can see that there is no data to display. But if you use AWS further, you'd be able to see more information in here. Over here, you can see a summary of all the usage of AWS. And if you scroll down, you'll be able to see the highest cost, and also you will be able to see the cost trend by the top 5 services. Right now, you don't really have any information in here, but my recommendation would be for the first week, go ahead and see the billing dashboard every day. When you're creating resources, you need to understand what is the cost for them. That's what the billing dashboard helps you to see. The second thing I would recommend you to do is to set budget alerts. There are 2 things I would want to do as part of setting our budget alerts. Right now we are in the AWS billing dashboard. What I would do is click billing preferences on the left. If you go to the billing preferences, you'll be able to request PDF invoice by email. So I'll turn this on, and I'll also turn on free tier usage alerts, and you can enter your email ID in here. You can also turn on billing alerts. So receive billing alerts, and you can say save preferences. So these are generic alerts which are provided by AWS. So what I'm doing is activating all of them. In addition, I would also want to set up specific budget alerts. And the way we can do that is by going for budgets. So you can see budgets under cost management. That's where I'm going next. So you can go to budgets. This is AWS budgets. This is where you can set custom budgets that alert you when you exceed your budgeted thresholds. So I would go ahead and say create a budget. We are making use of a free tier. The thing which I would choose is the cost budget, which is recommended. I would say next. Right now, we don't really have any cost data, so let's not worry about it. I need to give it a name, so I'll say my budget. And I would want to create a monthly budget, which is recurring. And I'll start from the current month. I'll take the defaults for most of the values in here, except for the budgeted amount. For the budgeted amount, I would enter $1. What we want to do is to make use of the free tier. We don't want to go beyond the limits of the free tier. So we don't want to actually incur any charges for our AWS usage. The thing is, I cannot enter 0 in here. That's why I would enter $1. And I would want to have all the AWS services in scope. I'll take the default for the rest of the things and I'll say next. So you can see the budgeted amount right now. It's $1. What we want to do now is to configure the alerts. And to be able to configure an alert, let's add an alert threshold. Let's click this button which is present in here. And this should expand and it should show a few details. So what we want to do is when we reach 80% of our budgeted amount, we would want to be alerted. So I'll say 80% of our budgeted amount. I would want to receive an email. You can enter your email in here. And you can go ahead and say next. I can go next and review the details. So I've set up a monthly budget of $1 and I would want to receive an alert on my email when 80% of the budgeted amount is utilized. So let's go ahead and create a budget. So our budget is now created. And in case our usage of AWS exceeds the limits which are set by our budget, we will get alerted by email. So right now, we have completed 2 of the best practices. The first one is for the first week, monitor the billing dashboard every day. So go to billing dashboard, make sure that you check it every day. The second one is we have also enabled a few budget alerts. Now, what are the other best practices? The third best practice I would always recommend in the cloud is to stop resources when you are not using them. In our data centers, we typically leave the resources running all the time. If you have a dev environment or QA environment, typically those environments are always running. However, when it comes to the cloud, if you have any expensive resources which you are not making use of, if there's a dev environment which you are not making use of and it makes use of an expensive database or it makes use of an expensive EC2 instance, what I would recommend you to do is to stop them when you're not using them. If you stop the resources, you don't really need to pay for them in the cloud. So it's always recommended to stop the resources when you are not using them. It is very important to get into the habit of stopping resources even when you are learning. Even though you are making use of the free tier, what I would recommend you to do is to stop the resources after each learning session. So that's number 3. What are number 4 and number 5? Number 4 and number 5 are to understand the free tier and the 12-month limits. Number 5 is to understand how pricing works for different resources. In my experience, I found that beginners to AWS find these 2 really hard. Because to be able to understand the free tier, 12-month limits, and to understand how pricing works for different resources, you need to understand the different services that AWS offers. And this is a little tricky. But what I would recommend you to do is to at least take a few basic steps. If you search for AWS free tier, one of the search results that you would see is aws.com/free. So this is the URL I would click. And over here, you can see all the details of the free tier offerings of AWS. If you scroll down, you can see that as part of the free tier, you get 12 months free Amazon EC2 for 750 hours per month. So you can see that there are a lot of things which are free for 12 months. You can also see that there are certain things which are always free. For example, DynamoDB, 25 GB of storage is always free. You'd also see certain things are offered under free trial. So for Amazon SageMaker, which is a machine learning service, you can go in and enable the free trial whenever you'd want to make use of it. So even beyond the 12 months, you can go to Amazon SageMaker and enable a free trial, and you'll be able to use SageMaker within a certain limits for 2 months for free. So as you can see, there are different types of offers as part of the free tier. You have free trials, you have 12 months free, you have always free, and these details vary from service to service. And for beginners, these are really complex to understand. However, what I would recommend you to do is to spend a few minutes in here. Try and understand what is free trial, what is 12 months free, what is always free, and also take a high level look at some of the services in here. So that's number 4, understanding the free tier and the 12-month limits. Number 5 is to understand how pricing works for different resources. If you do a Google for AWS pricing, you'll land up on the pricing page for AWS. This page explains how pricing works in AWS. If you scroll a little down, you'd be able to see all the different categories under which AWS provides its services. The pricing varies from one service to another. For example, if you're talking about Amazon EC2, you're paying for the amount of time you are running your EC2 instances. If you're talking about storage, you'll be paying for amount of storage, for example, 100 GB, and also the duration, if I'm storing it for 1 year or 2 years. So you'll be paying for the amount you are storing as well as the duration. So the approach to pricing will vary from one service to another service. As a beginner, some of these pricing things might be really complex, but what I would recommend you to do is to spend a few minutes on this page as well. Try and get a high-level overview of how different services are priced. In this step, we talked about the fact that with great power comes great responsibility. Cloud provides you with the ability to create really powerful resources. AWS provides 200 plus services where you can go in and create different kinds of resources. However, when we are making use of these resources, you'd also need to understand the cost implications. And that's where I recommended 5 best practices. Number 1 is to monitor the billing dashboard every day. Number 2 is to set budget alerts. Number 3 is to stop resources when you're not using them. And number 4 and 5 are related to getting a high-level overview of how free tier and pricing works in AWS. I'm sure you're having a wonderful time, and I'll see you in the next step. In this section, let's focus on data. Data is the oil of the 21st century digital economy. We are generating data in huge volumes. Every action I perform is generating data. I'm using a mobile phone, I'm generating data. My Apple Watch is generating data continuously. So mobile devices, IoT devices, applications, all of these are generating data continuously. The amount of data that is being generated is increasing exponentially year by year. And there are varieties of data. You have variety of data formats, structured data, semi-structured data, and unstructured data. And there are a variety of options to store this data in. There are a variety of data store options. You have relational databases, NoSQL databases, analytical databases. You have different types of storage, object, block, and file. Whenever we build applications, our goal is to store data efficiently and, more importantly, gain intelligence from data. And one of the most important goals of this section is to help you choose the specific data format to use and also help you decide the data store for your specific use case. As we discussed, there are a variety of data formats. You have structured data where you have data stored in tables, rows, and columns. These are typically called relational databases. You also have semi-structured data, key value data, or data which is stored in JSON. This is called document format. Or you have a graph, and there are a variety of other semi-structured data formats. You also have unstructured data, which is in the form of different files, video files, audio files, image files, text files, binary files. And we talked about the fact that there are a variety of data stores as well. Relational databases. You have NoSQL databases, which are not only SQL databases. Relational databases typically support only SQL, and NoSQL databases support other approaches as well. You also have analytical databases, which are typically used for business intelligence and reporting purposes. And you have different types of storage: object, block, and file storage. Now, you might be wondering, how do I choose the right data format and data store for my data? Data stores help you to store your data in an organized and persistent way. However, if you want to be good at choosing data stores, you need to understand a lot of terminology which is associated with data stores: availability, durability, scalability, consistency, transactions, and a wide variety of other things. And that's what we'd be doing in this specific section. Let's get started on a simple journey where we would understand the different data formats, different data stores, and also understand some of these important terminology. Are you excited to get on this journey? I'll see you in the next step. In this section, we would want to be able to understand the different data formats, data stores, and also understand the different terminology which is associated with data stores. And to be able to do that, we would take a very, very simple example of a database which is deployed in a data center in London. So you have a database which is in London region, and there is an application which is deployed in London region which is talking to the database as well. Let's use this as an example as we start our journey towards understanding some of the important terminologies which are related to data stores. Now, let's consider some of the challenges with respect to the architecture that we have right now. Challenge 1 is with respect to availability. Your database will go down if data center crashes or the server storage fails. If the storage fails or if the data center crashes, your database will go down completely. Challenge 2 is respect to durability of the data. If the database crashes, you will lose the data. Now, how can we fix this? One of the solutions that is possible is snapshots. Let's automate taking a copy of the database. Basically, we would want to take a snapshot every hour to another data center in London. So we are taking a snapshot to a different data center in London itself. Let's look at the challenges again. Challenge 1, your database will go down if the data center crashes. It remains as is. We have not solved it. Challenge 2 is that you will lose data if the database crashes. I'll call this partially solved. Why? Because you can set up the database from the latest snapshot. So if this database crashes, I can actually pick up a snapshot. I can create the database from it. So I might not lose all the data. Depending on when the failure occurs, you can lose up to an hour of data. Let's say I'm taking backup at 7 p.m., 8 p.m., 9 p.m., so on, so forth, every hour. And the failure happens, let's say, at 8:55 p.m. In that kind of scenario, I would have the backup from 8 p.m. So I will lose the data between 8 p.m. and 8:55 p.m. That's basically 55 minutes of data. So the maximum amount of time which I can lose data for is up to an hour right now. So right now, we would not lose all the data, but we can lose up to the last hour of data. And that's why I'm calling this partially solved. We also have a new challenge in here. The new challenge is challenge 3. The database will be slow when you take snapshots. When you take a copy of the data, the database will be slow. Your application users might see that the performance of the database is not the same as usual. Let's try and improve this solution further. What we'll do is we'll bring transaction logs into picture. So what we'll do is we'll add transaction logs to the database, and we'll also create a process to copy the transaction logs over to the second data center. A snapshot is one time. So every hour we take a snapshot. However, the transaction logs are continuous. So you are getting a continuous stream of transaction logs from the database. And we also have a process to copy this over to the other data center. Let's look at the challenges again. Challenge 1, your database will go down if the data center crashes. That still remains. Challenge 2 is you will lose data if the database crashes. This is now solved. Why? Because you can set up the database from the latest snapshot and apply the latest transaction logs, and you should have the data in the same state as it was when the database crashed. So we have not solved challenge 1 yet, but we are able to solve challenge 2. Our database is not still highly available. However, the data in the database is now a little bit more durable. The challenge 3, database will be slow when you take snapshots still remains. We are happy with the progress we are making, but we would want to improve our solution further. So instead of taking snapshots, transaction logs, what if we can set up a standby? What if we can set up a copy of the database and we can synchronously replicate to it? Whenever a change is done, we would want to immediately replicate it to the standby database. So what we are doing is to add a standby database in the second data center with replication. Let's look at the challenges again. Challenge 1, your database will go down if the data center crashes. It's solved. Why? Because even if this database goes down, you can switch the application to connect to the standby database. Let's talk about challenge 2. You will lose data if the database crashes. This is also solved, because if this database crashes, you have the data available in the standby database. Challenge 3 was that database will be slow when you take snapshots. Even that can be solved by taking snapshots from standby. Instead of taking a snapshot from the live database which the application is talking to, you can take the snapshot from standby database, and this would not cause a performance impact on the application at all. So the applications connecting to master database will always get good performance. My goal with this specific step was to introduce you to some of the challenges with respect to databases. Making sure that your database is highly available, making sure that the data in the database is highly durable. Those are very difficult problems to solve. The solutions which we looked at in the specific step are not perfect. The goal was not to focus on the solutions, but to be able to understand the problems well. Let's further explore this in the subsequent steps. When we talk about databases, there are a few important terminology that are frequently used. Availability, durability, atomic transactions, consistency, and scalability. Let's look at a few of them in this specific step. Let's start with availability and durability. Availability is a measure of, will I be able to access my data now and whenever I need it? If I have a database, will I be able to access the data from the database whenever I need it? Will an application be able to talk to the database whenever it needs data? That's availability. It's the percentage of time a database or an application provides the operations that are expected of it. What is durability? Durability, on the other hand, is about whether your data will be available after 10 years or 100 years or 1000 years. I have data right now. Will I be able to access the same data in 1000 years' time? That's the focus of durability. Let's look at a couple of examples of measuring availability and durability. 4 nines. This is 99.99. So 2 nines before decimal and 2 nines after decimal. 11 nines. 99.99999. So this is 2 nines before the decimal and 9 nines after the decimal. This is called 11 nines. When we talk about availability of 4 nines is very, very good. So 99.99% availability is considered to be really, really good. However, when it comes to durability, a durability of 11 nines is considered very, very good. Why? Why do we need such high durability? Let's look at a few examples. Let's look at examples for availability. Let's say you are having 99.95% availability. This would actually translate to 22 minutes of downtime in a month. So if a database is having 99.95% availability or an application has 99.95% availability, then it means that it can be down only for 22 minutes in a month. And if you want 99.99% availability or 4 nines availability, then you can only be down for 4.5 minutes. And typically, most online applications aim for 99.99% or 4 nines availability. Remember that this includes the downtime to make new releases to the applications as well. So if you have an application, it's V1 right now and you're moving to V2 or V3, even the downtime that comes when you are releasing a new version of the application matters when it comes to availability. So achieving 99.99% availability is difficult. And when we talk about 99.999% availability or 5 nines availability, we are talking about 26 seconds of downtime in a month. And typically achieving 5 nines availability is considered to be really, really tough. However, things are a little different when it comes to durability. What does the durability of 11 nines mean? Durability of 11 nines means that if you store 1 million files for 10 million years, you would expect to lose one file. Why do you need this much amount of durability? Why should the durability be high? Because we hate losing data. Once you lose data, it is gone. Imagine that you are performing a stock trade or you are performing a banking transaction and the data related to that is lost. This could cause significant impact, and that's why we don't want to lose data at all. Until now, we talked about availability and durability. Availability is all about, will I be able to access data whenever I need it? Durability is all about, can I access this data in 100 years, 1000 years? In the last step, we talked about availability and durability. In this step, let's talk about a couple of more important things related to databases, consistency and atomic transactions. Let's start with consistency. One of the ways of achieving high availability and durability is to create replicas, create multiple copies of your data. For example, if I have a database, I can create multiple copies of this database and I can increase the availability and durability. Even if one copy is down, the other copy is available, so the application can get the data from there. And by having multiple copies, maybe I can have multiple copies in different zones, maybe in different regions, and therefore the chance that I lose data is very, very less. That's how I can increase the durability of the data. So creating replicas increases availability and durability. But there is a challenge when it comes to consistency. What is consistency? If I try to access data from these two databases at the same time, will I get the same data back? Do you get the most recent updated data irrespective of the copy you are querying against? That is what consistency is all about. Having multiple copies of data makes consistency a challenge. Typically, whenever we talk about consistency, we talk about strong consistency and we talk about eventual consistency. What is the difference between strong consistency and eventual consistency? When it comes to strong consistency, any change you make in the data related to a database, the change is immediately replicated to all the replicas. If I have 5 copies, if I make a change here, the change is immediately replicated to all the 5 copies. So whichever replica you read from, you get the same data. However, guaranteeing strong consistency with multiple replicas would mean that there is a performance impact. If I'm inserting some data, if I'm updating some data in this specific copy, I would need to ensure that the data is immediately replicated to all the other copies as well. That means the inserts and updates will be slow. However, you would see that certain kinds of applications need strong consistency. For example, most transactional applications, if I'm talking about a banking application or a finance application, it's very, very important that they are strongly consistent. Irrespective of the copy I would read from, you would want to get the same data. If this copy tells that my balance is 1,000 rupees and this one tells that my balance is 10,000 rupees, then we have a problem in hand. The alternative to strong consistency is eventual consistency. A little lag, a few seconds before the change is available in all replicas. If we are making a change in this specific copy or replica, there would be a few seconds lag before the change is available in all the other copies. So in the intermediate period, different replicas might return different values. Now you might be wondering, what kind of applications can live with a little bit of a lag? Good examples are social media applications. In the case of social media applications, high scalability is really, really important, more than data integrity. If you look at Facebook status messages, Twitter tweets, LinkedIn posts, it is not important that everybody sees the message as soon as I post it. If there is a lag of a minute or so, it does not really matter a lot. So in use cases where scalability is more important than data integrity, we go for eventual consistency. So we started with availability, we talked about durability, and now we are talking about consistency. Consistency is whether you get the recent, most updated data, irrespective of the replica you are querying against. And at a high level, there are 2 types of consistency. Whenever a database guarantees strong consistency, irrespective of the copy you query against, you get the same data. However, if a database says it is eventually consistent, then there is a lag between when a change is made and when the change is available in all the replicas. The last concept that we would talk about in this specific step is atomic transactions. What are atomic transactions? A transaction is nothing but a unit of work. A transaction might involve multiple steps. For example, if I'm transferring $10 from A to B, from my account to my friend's account, in that kind of scenario, there are two steps which are involved. Step 1 is to deduct $10 from A's account or from my account. And step 2 is to add $10 to B's account. And what we want to do is to ensure that a transaction is atomic. What is atomicity? All or nothing changes. Let's say step 1 succeeded. However, step 2 failed. What would happen? $10 will be deducted from A's account, but they are not credited into the B's account yet. So these $10 vanished into the air. That's not good. Whenever we perform transactions, we would want atomic transactions. Either these two steps should succeed, or if any of the steps result in a failure, all the changes should be rolled back. So if step 2 fails, the change done by step 1 should be rolled back. And there are certain applications which need atomicity across multiple rows and multiple tables. You might have multiple rows in a single table, and you might have data in multiple tables. And during a single transaction, you might be making changes to multiple rows as well as multiple tables. And typically, whenever we talk about strong atomic transactions, it should support atomic transactions across changes in multiple rows and multiple tables. The thing with atomic transactions is that atomic transactions are easier to implement if all data is stored in one node. Let's say all the rows for the table are stored in the same node and all the tables are also stored in the same node. Then atomic transactions are easy to implement. Typical relational databases, for example, SQL databases, they store data on just one node, and therefore they have very strong support for atomic transactions. However, if you talk about most NoSQL databases or not only SQL databases, your data is distributed across multiple nodes. Even data from the same table, multiple rows from the same table might be stored in different nodes. Most NoSQL databases have limited support for atomic transactions across multiple rows and multiple tables, or they have atomic transactions which might have big performance impact. They might be expensive as well. In this step, we talked about consistency and atomic transactions. I'm sure you're having a wonderful time, and I'll see you in the next step. In this step, let's talk about scalability. What is scalability? Let's consider an example. A system is handling 1,000 transactions per second, and 10 times the load is expected next month. Can we handle a growth in users, traffic, or data size without any drop in performance? That's what scalability is all about. Does ability to serve more growth increase proportionally with the number of resources? Let's say I'm able to support 1,000 transactions per second using 2 servers. Can I support 10,000 transactions per second with 20 servers? That's what scalability is all about. It's the ability to adapt to changes in demand, changes in number of users, and changes in amount of data. There are multiple types of scalability. You can either deploy to a bigger instance with more CPU, more memory, or you can create more instances. Vertical scaling is when you are deploying to a bigger instance. Let's say you are using an EC2 instance to host your database, and you'd want to increase the number of transactions that are supported. So you can go for a bigger EC2 instance. So you can either go for a larger hard drive, a faster CPU, more RAM, more IO, or networking capabilities. That's what is called vertical scaling, deploying to a bigger instance. The other option is horizontal scaling. It is about using multiple instances. Instead of using one EC2 instance or one VM, you can use multiple EC2 instances or multiple VMs. For example, you can split the data in the database among multiple database nodes. There are a couple of important things that you need to remember about vertical scaling. There is only a certain amount of memory that you can have on the largest virtual machine. And if you're purchasing hardware with the best capabilities, it would typically be very expensive. And that's why typically these days, horizontal scaling is preferred. But horizontal scaling also can be complex. For example, if these are instances of an application, a web application running on VMs, you would need a load balancer or something to load balance between these instances. And in the case of databases, how do you split data? If I'm splitting data from a table among multiple nodes, how do I split data? What is the algorithm I would need to use to split data among these nodes? How do I ensure that the data is consistent when it's updated? So there would be a lot of challenges in horizontally splitting up a database as well. Let's look at vertical scaling and horizontal scaling from the perspective of databases. Challenge with vertical scaling is that there would be a limit on maximum amount of data. For example, 64 terabytes might be the maximum amount of data that you might have on a hard disk. And that's the maximum amount to which your database can grow up to. When you look at typical relational databases like MySQL, most of them only support vertical scaling for writes. So if you want to be able to make updates to the database, if you want to do update or insert data, then they only support vertical scaling. So if you want to support more writes, you have to actually go to a bigger instance. And that's why the scalability of these databases typically is limited. For example, they have a maximum limit of how much data you can store. And they also have very strict limits on how much you can scale up to. You'd see that most typical NoSQL databases scale horizontally. So the data is split across multiple nodes. When you split the data across multiple nodes, making sure that the data is strongly consistent is very, very difficult. And you'll also see that most NoSQL databases provide limited or expensive support for atomic transactions. If you want to perform an atomic transaction involving multiple rows in a table or multiple tables, it is very, very difficult if the data is split across multiple nodes. And that's why you'd see that most NoSQL databases that horizontally scale provide either a limited support for atomic transaction or performing atomic transactions has performance impact and is expensive. Now, you might be wondering, what if I would want to scale to unlimited amount of data, but I would want strong consistency and I would want atomic transactions? There are actually a new breed of databases which are being specially designed. So some specially designed modern relational databases actually support worldwide horizontal scaling and strong transactions. Good examples are Amazon Aurora and Cloud Spanner in Google Cloud. The goal of this step was to look at what is scaling, what is horizontal scaling, and what is vertical scaling, and also look at them from the perspective of different databases. I'm sure you're having a wonderful time, and I'll see you in the next step. In this step, let's look at a few scenarios related to data stores. What is good availability? Availability is basically whether your data is available whenever you would want it. Whenever you want to use the data or whenever your application wants to use the data, is your data available? And typically, 4 nines or 5 nines is considered to be really good availability. 99.99% or 4 nines availability is 4.5 minutes of downtime in a month. 99.999% availability is 26 seconds of downtime in a month. This might be really, really difficult to achieve. Typically, most applications and databases aim for something between 4 nines and 5 nines. What is good durability? Typically, we expect very, very high durability from our data. Why? Because once we lose the data, it is gone. If you make a stock transaction or a banking transaction and you lose it, that's not good. And that's why high durability is expected. 11 nines is considered to be the standard good durability. 99.99999. So basically 2 nines before the decimal and 9 nines after the decimal. Next, what are we measuring in here? Do you get the most recent updated data irrespective of the copy you are querying against? What we are measuring in here is consistency of data. Are we getting the same data irrespective of the copy of the data we are querying against? That's what consistency is all about. Next, what are some of the challenges with scaling databases horizontally? When we are scaling databases horizontally, we are splitting our data among multiple nodes. And we might also be creating multiple copies of our data. The typical challenges are ensuring strong consistency. How do you ensure that the data is consistent across multiple copies of your database? And another important thing which is difficult to support is atomic transactions. If I have my data split across multiple nodes, how do you if I have my data split across multiple nodes, Supporting atomic transactions across multiple rows and multiple tables in the same database becomes a little bit more difficult. Last one is, what is eventual consistency? A little lag, a few seconds before updates or inserts are available in all replicas. If you have multiple replicas of your database and you are making an update or an insert in one of the replicas, then when we are talking about eventual consistency, there is a little lag before all the updates are available in all the replicas. In the intermediate period, if you are querying different replicas, you might get different values. For certain scenarios like social media applications, scalability is much more important than having strong consistency. In those kind of scenarios, you can go with eventual consistency. In this step, we looked at some of the important scenarios related to availability, durability, scaling, and consistency of your databases. I'm sure you're having a wonderful time, and I'll see you in the next step. Earlier, we looked at the different types of data formats and data stores. Starting this step, let's focus on structured data. Structured data is data which is typically stored in tables and organized into rows and columns. This is also called relational data. Let's explore structured data right now. What is structured data? You have data which is stored in tables, rows, and columns. If you have played with any of the popular databases like MySQL, Oracle, or SQL Server, you would have stored structured data and you would have played with relational databases. In a relational table, you would define a table, you would define the different columns which are present in the table, and you would store the data in multiple rows. Over here, you have a course table. It has an ID column, it has a department name column, it has an instructor ID column, and duration and name columns as well. And over here, we have the data for the course table. You can see that we have 4 courses with IDs ranging from 1 to 4. Typically, relational databases have a predefined schema. What do you mean by a predefined schema? You define the table with what are the columns it contains. What is the primary key? What is the data type of each of these columns? If I try to store a row into the course table with the ID as string, it would fail. Why? Because we have defined the ID field as an integer. These tables also have relationships with other tables. A course needs to have an instructor. An instructor can be associated with multiple courses. A course is associated with a department, and the department can have multiple courses associated with it. So you have tables, you have relationship between tables, and you have constraints. In relational databases, you can also define indexes. By default, an index is created on the primary key. For example, ID is the primary key in the course table. So index is automatically created on it. So if I query, let's say, select start from course where ID is equal to 4, the query would be really efficient. However, if I query by name of the course, the query will not be really efficient. And that's where you can define an index on the name field in the course table. That would help you to query from this course table based on the name of the course efficiently. There are 2 types of use cases where relational databases are typically used in. One is OLTP use cases, online transaction processing use cases. I go to Amazon, I make a purchase, I'm making a transaction. In these use cases, relational databases are very useful. The other type of use cases are OLAP use cases. Let's say I have a data warehouse. The data warehouse has petabytes of data, and I would want to be able to run queries very efficiently. Even in those use cases, relational databases are useful. Let's now look at relational databases for OLTP use cases, for online transaction processing use cases. OLTP applications are those applications where large number of users make large number of transactions. Basically, we are talking about an application like Amazon or a banking application. There would be millions of users making a lot of transactions. The duration of these transactions would be pretty small, but there would be millions of such transactions which are happening in parallel. If you look at the technical definition of a transaction, it means a small discrete unit of work. For example, transferring money from your account to your friend's account. That's a small transaction. Typically, OLTP applications have heavy writes and moderate reads. For online transaction processing, we would want quick processing. You don't want to keep the user waiting for a transaction to complete. So the use cases for OLTP databases are typically most traditional applications, banking, e-commerce, and the most popular databases are typically MySQL, Oracle, and SQL Server. Setting up these databases and managing them, managing the availability, scalability, and durability of the data is not an easy job. And that's why there are a number of cloud managed services which makes it easy for you to run relational transactional databases. In AWS, the service you'd make use of is Amazon RDS. RDS stands for Relational Database Service. If you're making use of RDS, you can run MySQL, PostgreSQL, MariaDB, Oracle, or SQL Server. Or you can also try and run a special customization of MySQL, which is provided by Amazon, which is Aurora. There are managed services for relational transactional databases in other clouds as well. For example, if you go for Azure, you have Azure SQL Database, and you have Azure Database for MySQL, PostgreSQL, and MariaDB. If you are talking about Google Cloud, you have Cloud SQL, which supports MySQL, PostgreSQL, SQL Server, and you also have a global database, which is Cloud Spanner. Until now, we talked about the fact that structured data is stored in relational databases. And we can use relational databases for two purposes: OLTP or online transaction processing, and OLAP or online analytics processing. OLTP applications are where large number of users are making large number of small transactions. Most online web applications are OLTP applications. Banking applications, e-commerce applications, where a number of users log in and perform transactions. We also looked at some of the cloud managed services for relational transactional databases. Let's now shift our attention to relational online analytics processing databases. What are OLAP applications? OLAP applications are applications that allow users to analyze petabytes of data. Over here, we are talking about huge volumes of data. So reporting applications, data warehousing applications, business intelligence applications, analytics systems, all these process huge volumes of data. Typically, data for these systems is consolidated from multiple transactional databases. A good sample application is to decide insurance premiums, analyzing data from the last 100 years. And the cloud managed databases for doing online analytics processing are Amazon Redshift in AWS, Azure Synapse Analytics in Azure, and BigQuery in Google Cloud. Each of these services help you to manage petabytes of data. They help you to manage huge volumes of data, and you can run queries processing huge volumes of data efficiently. Now, you might be wondering, I can use relational databases for OLAP and OLTP as well. What is the difference between them? The thing is, OLAP and OLTP use similar data structures, but they have a very different approach to how data is stored. In OLTP databases, we use row storage. So this is the table. We want to store this data. And in OLTP databases, data is stored row by row. Each table row is stored together. And this is very efficient for processing small transactions because all the changes will be in the same row. OLAP databases, on the other hand, use columnar storage. Each column of data is stored together. Each table column is stored together. Why do OLAP databases use columnar storage? Because each table column will have similar kind of data, and therefore the compression will be huge. You'll be able to store huge volumes, petabytes of data efficiently. Another important reason is that you'll be able to distribute this column data across multiple cluster nodes. You can store one column in one node, the other column in another node, and the other column in a completely different node. Why is this important? This would allow you to execute a single query across multiple nodes. One query against the same table can be run against multiple nodes, and this makes running complex queries very, very efficient. In this step, we talked about the fact that structured data is stored in relational databases, and we talked about the fact that relational databases can be used for OLAP and OLTP use cases. We also looked at the difference in structures of OLTP databases and OLAP databases. We saw that OLTP databases use row storage and OLAP databases use columnar storage. I'm sure you're having a wonderful time, and I'll see you in the next step. In this step, let's talk about Amazon RDS, Relational Database Service. It's a managed relational database service in AWS for OLTP use cases. Amazon RDS helps you to manage the setup, backup, scaling, replication, and patching of your databases. And there are a wide variety of databases which are supported by Amazon RDS. It supports Aurora, PostgreSQL, MySQL, MariaDB, Oracle Database, and Microsoft SQL Server. Some of the important features of Amazon RDS are multi-AZ deployment. You can create a standby in another AZ. For example, you have a database in one availability zone. You can create a standby for it in another availability zone. This is called a multi-availability zone deployment. In case the master database crashes, the applications can directly connect to the standby database. Another feature is read replicas. You might have a reporting application which might want to read from the database. In that kind of scenario, instead of reading from the master database, you can create a read replica for your database. And the reporting applications and the analytic applications can query from your read replica. The read replicas can be created in the same availability zone or a different availability zone or in a different region. Amazon RDS also supports storage autoscaling. As the amount of data in your tables grows, the storage assigned to Amazon RDS database can also be increased automatically. RDS also supports automated backups. You can say, I would want to roll back the database to the state as it was yesterday at this specific point in time. And you can take manual copies of RDS database by creating snapshots. Let's quickly look at the sharing of responsibilities between you and AWS when it comes to RDS databases. AWS is responsible for availability, scaling based on your configuration, durability, maintenance, and backups. And you are responsible for security of the database, basically managing your database users. And you are responsible for the structuring of data and the data that you store in the database. So you are responsible for the tables, the data, indexes, and optimizing these. You are responsible for optimizing the tables and indexes to give you the best possible performance. One of the databases which is supported by Amazon RDS is Aurora. Let's look at Aurora in a little bit more depth. Aurora is MySQL and PostgreSQL compatible. Aurora makes use of a multi-AZ storage called cluster volume. You can see that this storage is across multiple availability zones, availability zone A, B, and C, and this whole thing is called a cluster volume. When you're using Aurora, it stores 2 copies of data each in a minimum of 3 availability zones. You can create up to 15 read replicas for your database. Aurora also provides a global database option. You can create up to 5 read-only secondary AWS regions. And this would provide low latency for global reads. Even if your applications are spread across the globe, they would get low latency. And this would also protect your database from region-wide outages. Even if a region is completely down, your data in the database is still safe. As we discussed earlier, whenever we talk about multiple copies of data stored in different AZs or different regions, you have a little bit of lag time. And the lag time in the case of Aurora is about 1 second. Aurora provides you with multiple deployment options. You can either go with single master, basically one writer and multiple readers. So you have one database which you can write to, and all the others are ones where you can read from. You can also go for a multi-master deployment where you have multiple writers. So you can write and read from any of the databases. Amazon Aurora also offers a serverless option. Basically, the storage which is assigned to Amazon Aurora will grow with the data that you are storing in the database. In this step, we talked about different databases which are supported by RDS, and we talked about Amazon Aurora in particular. Let's explore this further in the next step. In this step, let's focus on RDS, Managed Relational Database Service. Let's create a database using RDS and play with it. So we'd want to create a database in here. Let's go ahead and say create database. Over here, you can see that you can choose between standard create or easy create. What I would do is to choose the standard create. You can choose between any of the engines which are offered by RDS. Amazon Aurora or MySQL or MariaDB, PostgreSQL, Oracle, or Microsoft SQL Server. I would want to use MySQL, so I would choose MySQL in here. We are making use of MySQL community, and you can choose the latest version which is available in there. The next thing you can choose is the template. If you're creating a database for your production environment, you'd want high availability and you'd want fast and consistent performance. That's when you'd go for production template. If you select production and if you scroll down, you'd see that you're making use of db.m6g large, which is quite a big instance. You have 2 vCPUs, you have 8 gigs of RAM. It's configuring by default about 100 gigs of storage, and storage auto-scaling is also enabled. If your database grows, the storage would grow along with it up to a threshold of 1000 GB. And we are also setting up a standby instance. So we are using multi-AZ deployment. So in addition to the actual database instance, there would be a standby created in another availability zone. Now, what I would want to do is to not worry about using a production template. I've scrolled up and I would want to make use of the free tier. So let's make use of free tier, keep things simple. The first thing I would want to configure is a DB instance identifier. This is basically the name for our DB instance. The name I would give to this is MySQL database. What I'll do is I'll also maintain a simple text file with the details I'm storing in here. So the database identifier is MySQL database. That's what we have configured just now. Next, we would want to configure the username and the password. So I'll configure a username of admin. I'll take the defaults. So user is admin. That's cool. I'll configure my own password. And I would go ahead and confirm the password in here. So I'll put stars for the password in here. I would choose the default instance configuration that is suggested. I think 20 GB of storage is more than sufficient for us, and storage auto-scaling is also enabled. We don't really need a multi-AZ deployment. I'll take the defaults for the rest of the things. I'll scroll down, and what I would want to do is, in additional configuration, I would also want to create a initial database name. So you would want to create a database inside the database server, and the name I would want to give it is to-dos. So inside the database server, we are creating an initial database with the name to-dos. I'll also store it in here. Let's go ahead, take the defaults for the rest of the things, and I would go ahead and say create database. The creation of the MySQL database will take a few minutes. What I would recommend you to do is to take a break, and I'll see you on the other side. In the last step, we started creating our RDS database. It took about 15 minutes, and at the end of it, when I refreshed this page, I saw that the status of this database now is available. So this database is now available. What we'll do is we'll look at a few high-level details around this database, and a little later, we'll also try and connect to it, create few tables, and play with it. Let's get started. I'll click the MySQL database, and over here, you can see a summary for it. You can see the CPU utilization, you can see the current status in here, and you can see that we are making use of MySQL Community Edition. We have created it in AP South 1A availability zone. If you scroll down a little bit, you'll also be able to see the endpoint. This is the URL for this specific database. So what I'll do is I'll copy this and add it as host to my list of things. Over here, you can see which private network the database is part of, VPC, subnets, and things like that. And you can also see the replication setup. Right now, we only have one instance. There is no replica which is set up for it. And if you go to monitoring, you'll also be able to see the metrics around the specific database. So you can see CPU utilization, how many connections are made to this specific database. You can see how much storage space is remaining. And you can also see metrics around write and read IO operations. If you scroll up and go to logs and events, if you want, you can create an alarm. Based on metrics, you can create an alarm. For example, if there is less storage, you might want to create an alarm and get alerted. And you can also see the recent events. You can see that a DB instance was created, DB instance restarted, the DB instance was backed up, and the backup finished at a specific point in time. And if you scroll down, you'll also be able to look at logs of the database. If you go to configuration, you'll be able to see the configuration related to this specific database. You can see the DB instance ID, the MySQL engine version which we are making use of, how many virtual vCPUs are present, what's the RAM size, our admin username, and a lot of details about this specific resource. If you go to maintenance and backups, you'd be able to see details related to maintenance. You can see that auto minor version upgrade is enabled by default. And there is a maintenance window which is configured in here as well. If there is a OS upgrade or a database upgrade, RDS would take care of it for you. And you can also see that backups are automatically enabled. You can also see when the last backup was taken in here. If you want, you can also take a snapshot, a copy of the database. On the last tab, you can add tags for this specific database. If you go to actions, you'll be able to stop the database, you'll be able to reboot the database, you'll be able to delete the database. Or if you want, you can even create a read replica for this specific database. Let's say there is a reporting application which you are using to generate reports. Instead of having it talk to the main database, you can create a read replica and you can generate the reports or analytics from the read replica. If you want, you can also take a snapshot. You can also restore to point in time. Let's say if your data in the database got corrupted, you can say, I would want to restore to this specific point yesterday. As you can see, there are a wide range of operations that are supported by RDS. Let's now try and connect to this database and create a few tables in there. And to be able to do that, what I'll do is I'll launch up CloudShell. So I'll go and launch up CloudShell. I've already created a small list with the details I would want. So with the database identifier we made use of was MySQL database. I have copied in the host as well. We have the username and the password and the database name as well. We would need all these details to connect to our database. We'll be using MySQL client to talk to the database. The great thing is in AWS CloudShell, MySQL is installed by default. Use this command, MySQL --host is equal to hostname. The hostname is in here. So let's copy, paste the hostname. So --host is equal to the hostname. --user is equal to username, which is admin. --password over here means that I would enter the password on the console. And the database name is to-dos. So I'll replace that as well. So let's go ahead and copy this. And let's execute this. So MySQL --host is equal to this specific host. --user is equal to admin. --password. And we want to connect to the to-dos database. Let's go ahead and execute that. It's asking me for the password. I'll enter the password I've configured. So when I tried to connect to the database, I got an error. It says can't connect to MySQL server on this specific thing. The reason why we are getting an error is because the security group is not allowing connection to the database. Let's go ahead and look at the security group which is configured for this specific database. So in the management console, if you go to RDS and pick up MySQL database, you can see that a default security group is assigned to this specific instance. And if you look at the default security group, if you go and look at the inbound rules for the default security group, let's go ahead and say edit inbound rules. And you can see that this is only allowing incoming traffic from resources which are having the same security group. So what I'm trying to do is I'm connecting from the Cloud Shell. The Cloud Shell does not have this security group assigned. And that's the reason why we are not able to connect to the database from Cloud Shell. What I would do is I would go back to security groups and I would create a new security group. I'll call this My Database Security Group. What I'll do as part of my security group is to create an inbound rule. So what I would want to allow as inbound traffic, I can go ahead and say add rule. I'd want to allow custom TCP, and the port which is typically used by MySQL is 3306. So we'd want to allow incoming traffic on port 3306 from anywhere. So we are allowing incoming traffic. We want to allow it from anywhere. That's what we are configuring in here. So we would want to allow inbound connections to this security group from anywhere. We don't really need to worry about outbound rules. I'll take the defaults and I would say create security group. Oops, a security group description is needed. So let's go ahead and enter a description and say create security group. So the security group, the My Database Security group is now created. You can see the inbound rules in here. Basically, we are allowing connections to MySQL from anywhere. What I'll do now is go back to RDS, go back to our database. I'll go to the DB instances, choose the DB instance. I would say modify. Let's go ahead and modify our database instance. I'll scroll down and choose the right security group. So let's remove the default security group and let's attach the My Database Security group. So that's number one change. So we are now attaching the My Database Security group. So you can see in here that My Database Security group is attached with this. In addition, we need to also enable public access for our instance. So what I will do is go to additional configuration and say publicly accessible. You can see that the database port configured in here is 3306. That's exactly the port on which we allow traffic in. So let's go ahead and say continue, and we would want to apply the change immediately. So let's go ahead and say modify DB instance. And if I go back to the MySQL database, you can see that it's now trying to add the new security group, and publicly accessible is yes. Let's go over to CloudTrail and try and connect. Let's enter our admin password. Fingers crossed. I waited a little while more until our VPC security group is now active. Let's go ahead and try it again. And finally, we are now connected to our MySQL database. So the two key things that you need to check is that it's publicly accessible. And the second thing is to ensure that your security group allows traffic on port 3306 from everywhere. That's what we have done. And now we are able to connect to the SQL database. Ideally, you don't want to allow public access to your database. What you need to do is to create an EC2 instance in the same private network as this specific database. And then you can use the EC2 instance to connect to the database. However, over here, we are directly connecting to the database from CloudTrail. Now, I would want to create a table in this specific database. What I would want to do now is to create a table called users. So create table users. I would want to have a simple table. So let's create an ID with integer, and we'll have a username. Let's have varchar of 30 characters. Let's put a semicolon in here and create the table. So you can see that now our user table is created. What I'll do is also insert a row. Insert into users values. I want to insert 1, Ranga within quotes and press semicolon. One row is affected, and let's say I would want to insert a few more rows. Let's do a 2, Ravi, and let's also do 3, Satish. So as you can see, we can execute queries. You can also do a select star from users now. So we are able to connect to the database. We are able to create a table. We are able to insert rows. We are able to query things from the database. As you can see, creating database using RDS involves a lot of steps. The first thing is you need the DB instance. Inside the DB instance, we need to create a database. Inside the database, we need to create a table. And that's when you can start playing with the data inside that specific table. A little later, we'll be looking at some of the NoSQL database options in AWS. For example, DynamoDB. You'd see that over there, creating a table is much more simpler. You don't really need a database instance or a database. You can directly go in and create a table. However, RDS provides you with really, really strong transactions. So if you have a banking transactional application, you'd need very, very strong consistency. You'd need very, very strong transactions. That's when you'd go for RDS. What I'll do now is to log out of MySQL. So let's type in exit, and let's type in exit and close out CloudTrail as well. Now I'll go back to RDS and go to our databases, select MySQL database and say actions, delete. I don't really need a final snapshot, and I don't want to retain the automated backups as well. So I'll say delete me, and I acknowledge that upon instance deletion, automated backups, including system snapshots and point-in-time recovery, will be no longer available. we are deleting a database. So you need to be really cautious when you delete the database. Over here, we are just deleting a test database. So we don't really need the snapshots and backups. So let's go ahead and say delete. The deletion of the DB instance would take a little while. I'll see you in the next step. Starting this step, let's shift our attention towards semi-structured data. There are different types of semi-structured data, and there are different data stores that you can use to store semi-structured data. Let's explore them starting this step. What is semi-structured data? Data has some structure, but not very strict. What do we mean by that? For example, take the JSON format, which you can see in here. It has some structure. Over here, we are storing customer ID with a specific value, first name with a specific value, last name with a specific value. We have the address of the customer stored, and we are also storing all the social profiles related to this specific customer. However, the important thing when it comes to semi-structured data is that the structure is not strict. In the same table, one JSON document might have all the attributes present in here. Another JSON document might not have some of these attributes. There might not be types defined for each of these attributes as well. So when you are storing the data as semi-structured, there is some structure, but the structure is not strict. Typically, semi-structured data is stored in NoSQL databases. Now, what are NoSQL databases? Important thing to remember is that NoSQL does not mean no SQL. NoSQL actually stands for not only SQL. Some of the NoSQL databases actually support querying using SQL. So whenever you read NoSQL or NoSQL, it is not only SQL. Most of the NoSQL databases provide you with flexible schema. The structure of the data is not well defined. You can store the data in the way your application needs it. So you'd structure data the way your application needs it. And there are very, very few constraints on the databases themselves on how you can store the data. You can let this structure evolve with time. If you are a startup and you are building a new application, you might not have a complete understanding of the data you would want to store. And therefore, you'd want your schema to evolve over a period of time. The great thing about semi-structured or NoSQL databases is that these databases can scale horizontally to petabytes of data with millions of transactions per second. Horizontally scaling relational databases is not easy. However, NoSQL databases can be horizontally scaled very easily, and they can handle petabytes of data with millions of transactions per second with minimum latency. There are different types of semi-structured data that you can store in your NoSQL databases: document, key value, graph, and column family. In this step, we talked about semi-structured data. In the next step, let's look at different types of semi-structured data. In this step, let's look at the different types of semi-structured data. Let's start with document. In a document database, data is stored as a collection of documents. So you would have a table, and the table would have a number of JSON documents like this. JSON stands for JavaScript Object Notation. If you're new to JSON, you need to be careful with the formatting of it. You can see that this specific JSON which has in here has a number of attributes which are present. So you have an open brace and a close brace. Between the open brace and the close brace is the entire JSON object. This is what is called the root object. And under the root object, you have a number of attributes. Customer ID is an attribute, first name is an attribute, last name is an attribute, and you have the values for them. At the end of each attribute name and value pair, you have a comma. You can also see that there are child objects in here. Address is a child object which has its own set of attributes: number, street, city, and state. You can also see that we can have arrays in here. Social profiles is an array. You have square brackets which are used in here, and inside square brackets, you have Twitter profile and the LinkedIn profile. So you have two social profiles stored in here. In a typical document database, you'll have a number of such JSON documents stored. Each document is associated with a unique ID. The unique ID associated with the document is called a key. You can see that this document has customer ID, which is the key. And if you want to retrieve this document, you can query the document database by using this ID, and you'll be able to retrieve this specific document back. In addition, in a document database, you can define additional indexes. Let's say you'd want to search by first name or last name, or you'd want to be able to search by the profiles, you can add indexes in your document databases. A very important thing about document database is that all documents don't need to have the same structure. This document in here has a number of attributes. The next document might not have all the attributes present. In that sense, document databases, like all other NoSQL databases, have a flexible schema. There is no strict schema defined on the database. All the variations in data need to be handled on the application side. Whichever application is storing the data on the document database should handle the schema, should know what kind of data is there in the database, what is allowed, what is not allowed, and that's why we call this application defined schema. Typically, information in one document would be stored in multiple tables if we were using a relational database. If I was putting this data in a relational database, maybe I would have a separate table for address, maybe I would have a separate table for social profiles, and I would link them to the customer table. However, when we talk about document database, all the data which is related to a specific entity is typically stored together in a single document. Good use cases for document databases are product catalogs, user profiles, shopping carts. Typically, in all these cases, you would need flexibility in the structure of storing the details, as well as you need high scalability. You would expect millions of transactions per second to be happening if your product is successful. So in these kind of use cases, you would go for document databases. And there are a number of cloud managed services for document databases. In AWS, you have Amazon DynamoDB and Amazon DocumentDB. If you want a MongoDB compatible document database, you can go with Amazon DocumentDB. Otherwise, you can go with Amazon DynamoDB, which is one of the most popular NoSQL database options in AWS. In Azure, you can either go for Cosmos DB SQL or MongoDB API. And in Google Cloud, you can make use of data store. In this step, we focused on the first type of semi-structured data, document. I'm sure you're having a wonderful time, and I'll see you in the next step. In this step, let's look at the other types of semi-structured data. Let's start with key value. Key value is very, very similar to how you store things in a hash map. You have a key which uniquely identifies a specific value, and you have a value which can be a number, a string, or a complex object like a JSON file. Typically, key value databases support simple lookups. For example, over here, I can say I would want to find the value with the key as user1 or user2. Key value databases are not optimized for querying by values. If you want to query by name in here, it might not be supported by your key value database. The typical use cases might be to store session information or to cache some data. And the managed services in the cloud for key value databases are, in AWS, the recommended one is to go with Amazon DynamoDB. In Azure, it's Azure Cosmos DB Table API. And in Google Cloud, it's Google Cloud Data Store. So key value is a very, very simple type of semi-structured data where you store data very, very similar to how you do it in a hash map. You have a key and you have associated value, and you'd be able to efficiently query using the key. The next type of semi-structured data is graph. Social media applications have data with complex relationships. So you might have users who are having a lot of different types of relationships with other users who are present in here. How do you store such kind of data? That's where you would go for graph databases. Graph databases are used to store data with complex relationships. In graph databases, you have nodes and edges. Over here, you have each person as the node, and you have the connection between two persons established as an edge. You can also store attributes on the node. So you can store data related to a specific person. And you can also store attributes on the relationship of one person with another person. So you can also store attributes on the edges as well. Typical use cases for graph databases include storing people and their relationships. Organization charts is one place where you have a lot of people and you have a chart which is showing the hierarchy. Another use case is something like fraud detection. You'd want to navigate a number of different transactions and find out if there is a fraud going on. The managed service in AWS for graph databases is Amazon Neptune. And in Azure, there is Azure Cosmos DB Gremlin API. And the last type of semi-structured data we'll be looking at is column family. Column family databases also have rows and columns. This might look very similar to how relational databases are structured. However, The important thing is that columns are divided into groups called column families. If you look at this example of storing family data, you can see that we have two column families defined for each of the rows. The first one is identity and the second one is contact info. Under identity, we are storing first name, last name, title, etc. And under contact info, we are storing phone number, email, and a lot of other data. One of the things that you would observe in here is the flexibility of the structure. Some rows don't have last name in here. This row does not have a title under the column family identity. This row does not have last name and title as well. And you can also see for this specific column family, some rows don't have an email. When you want to store structured, volatile data in a very efficient manner, that's when you would go for column family databases. The rows can be sparse. You don't really need to have a value for every column in a column family. Typical use cases where you would go for a column family database are IoT streams or real-time analytics, or when you'd want to store financial data, for example, transaction histories or stock prices. All these can be efficiently stored as column family data. And the managed service in AWS to be able to store column family data is Amazon Key Spaces. This is a managed service for Apache Cassandra, which is a very popular column family database. In Azure, you have Azure Cosmos DB Cassandra API, and in Google Cloud, you can make use of Google Cloud Bigtable. In last few steps, we talked about the different types of semi-structured data, and we also looked at some examples of managed services for each kind of data in different cloud platforms. I'll see you in the next step. In this step, let's get started with DynamoDB. DynamoDB is a fast, scalable, distributed database for any scale. It is a flexible, NoSQL, key value, and document database. As we discussed earlier, most of the NoSQL databases are schema-less. Amazon DynamoDB can provide you with single-digit millisecond responses for millions of transactions per second. So it's very highly scalable. When you're making use of DynamoDB, you don't really need to worry about scaling, availability, or durability of your data. All that is taken care of by AWS for you. As the data grows, it is automatically partitioned. And DynamoDB maintains 3 replicas for your data within the same region. When you're making use of DynamoDB, you don't really need to provision a database. When you want to create a relational database, the first thing you need to do is to create a database server. And then you need to create a database. And then you can go ahead and create a table and then store data. However, when it comes to DynamoDB, you don't need to do any of those. You can directly go ahead and create your table. So you can create a table and you can configure the performance you would want. You can configure something called RCU and WCU, read capacity units and write capacity units. Basically, how many reads and writes are you expecting? So you just go ahead, create a table, configure your capacity that you'd need, and your database is ready. DynamoDB also provides an expensive serverless mode. If you don't want to configure RCU and WCU, and if you want DynamoDB to automatically scale based on the number of operations which are happening, DynamoDB also provides a serverless mode. However, at this point, I would say serverless mode is still in a very, very nascent stage. For most of the workloads, I found that it is very, very expensive. The typical use cases where you would go for DynamoDB are when you'd want to store a user profile, when you'd want to store your shopping cart, or when you have very, very high volume read-write applications. Now that we got a high-level overview of DynamoDB, let's look at DynamoDB tables. In DynamoDB, the hierarchy is typically table. Inside the table, you can have any number of items, and each of the item has a number of attributes. Attributes are nothing but key value pairs. What you are seeing in here is an example item or a document. In a table, you can have any number of such items. The primary key in here is mandatory. So the ID1 over here is mandatory. Other than the primary key, the table is schema-less. So in one item, you might have all the attributes. In another item, you might not have any of the attributes except for the ID. So the tables are schema-less other than the primary key. So there is no need to define other attributes or types, and each item in the table can have distinct attributes. There is a maximum limit of about 400 KB per item in a table. You can store as much data as you would want in a table, but per item, the limit is 400 KB. Whenever you create a DynamoDB table, you're creating it in a specific region. However, if you have users in multiple regions, you can mark the table as a global table. When you do that, replicas are created in selected regions. And this would give you good performance for users in other regions as well. Now that we got a high-level overview of the tables, let's look at the different consistency levels which are supported by DynamoDB. The default consistency level in DynamoDB is eventually consistent reads. When you're making use of this consistency level, you might not get the latest data. If you try after a few seconds, you'll get the latest data. However, DynamoDB also offers a consistency level of strongly consistent reads. This allows you to get the most up-to-date data. This would reflect updates from all previous successful write operations. It would show all the updates from all the changes which were earlier performed. The way you can request for a strongly consistent read is by setting an attribute called consistent read to true on your API call. However, there are certain disadvantages in going for a strongly consistent read. This might have higher latency, and this would use more throughput capacity units. So this will have higher latency, and this will also be expensive. You can also perform transactions in DynamoDB. The way you can do that is by making use of the operations transact write items and transact get items. These are all or nothing changes to multiple items, both within and across tables. So basically, you can update multiple items within the same table, or you can update multiple items that are spread across multiple different tables. As part of these operations, you can make use of put item, which is typically used to create a new item, update item, which is used to update an item, obviously, and delete item operations. So you can have any of these operations as part of your transactions. However, transactions are expensive in DynamoDB. In this step, we got an introduction to DynamoDB. I'll see you in the next step. Starting this step, let's look at DynamoDB. If you type in Amazon DynamoDB or DynamoDB, you should land up on this specific service. Amazon DynamoDB, a fast and flexible NoSQL database service for any scale. It is fully managed, key value and document database that delivers single-digit millisecond performance at any scale. Let's go ahead and create a table. As you can see in here, if you want to create a DynamoDB table, it's very, very easy. You don't need to create a database or anything like that. You directly go in and create a table. And as it says in here, DynamoDB is a schema-less database. All that you would need is a table name and a primary key. Those are the only two things that are mandatory. Other than that, everything else inside your data is optional. For example, let's create a simple table. I'll call this table to-do. So I would want to create a to-do table. The only thing which is mandatory is a primary key. I'd want to have a ID field, which is of type string, as the partition key. Let's take the default settings, and I would say create table. So the creation of the to-do table has started. As it says in here, it will be available for use shortly. Within a few seconds, I saw this. The to-do table was created successfully. You can see that the status is now active. You can see the partition key ID in here. And you can also see that we have a read capacity of 5 automatically provisioned, and also a write capacity of 5 automatically provisioned. Right now, there is no data in this table. Let's go ahead and play with this table. So let's go and click to do. And this is where you can actually look at the high-level overview of the table. So you have a partition key. We are making use of a provisioned capacity mode. We have provisioned read capacity units and write capacity units of 5 each. That's the default. And what you want to do is to insert data into this table and play with it. So what I'll do is go in and say explore table items. Right now, the table does not have any items. So let's go ahead and say create item. So I would want to create an item. The only mandatory thing that you need to have is an ID. So I'll enter an ID of value 1. If you want, you can add more attributes as well. So you can say add new attribute. Let's say I would want to add a new string attribute. I can do that. So let's say I would want to enter a description. And the value I would want to enter is learn to dance. And I would want to add another string value as well. This would be username. I'll give my name in here. So Ranga wants to learn to dance. And I can say create item. So you can see that it's very easy to create an item. So we are creating a table, and inside table, you can create items. Once an item is created, if you want, you can go ahead and edit it as well. What I would want to do is to create more such items. So what I'll do is go ahead and say create item. We created the first item using the attribute approach. The other option you can do is also take the JSON approach. So I can say JSON in here, and this is where you can actually use the DynamoDB syntax to edit the JSON. I don't really want to worry about the DynamoDB syntax. So I'll turn off DynamoDB syntax, and this would be much more simpler syntax. So I would want to actually have ID of 2. And let's say I would want to have a description. And let's say I would want to get AWS certified. And comma, I'd want to enter a username in here as well. Username, I'll put this to me as well. So Ranga. If you actually put ID 1 and if you try and say create item, you can see that it says condition request failed. An item with primary key you provided already exists. So you cannot have 2 items with the same ID. Another constraint that we have is that you cannot remove the ID as well. So if I remove the ID and try and create the item, you'd see you must provide a partition key attribute ID with a non-empty value. So I'll do an undo, Control Z. I'll get back the ID. And I'll put the ID as 2. I'll copy this as well so that we can use this and create more items easily. So I'll go ahead and say create item. And now you'd see that we have 2 items in here. I can create more items if I would want. So create item, and I would use the JSON structure as usual. And I would actually go back to, I would disable DynamoDB JSON and paste this in. Now, I pasted this in. Let's make this ID 3. And let's say the description is learn DevOps. And let's say this one, I would want to assign it to Ravi. Now, if I enable DynamoDB JSON, you can see the internal structure which is used by DynamoDB. You can see that in DynamoDB, this is how it is stored. A ID of type string with value 3. Description of type string with value learn DevOps. Username string type Ravi. Now let's say I would want to store a number in here. I can add it in. There is no predefined structure, so I can add whatever I would want. So I'll say I would want to learn it in so many days. Let's say 50 days. Let's enable DynamoDB JSON. You can see that this is stored as number. This is number 50. So internally, this is how DynamoDB stores it. However, to make it easy, we can disable the DynamoDB JSON and we can use this kind of a JSON as well. So what we are seeing in here is that DynamoDB gives you a flexible structure. The only thing which is mandatory in here is the ID field. And you need to ensure that the ID field is not duplicated across multiple items. So you cannot have 2 items with the same ID key. That's the only constraint. Other than that, you can define whatever attributes you'd want in here. One item might have description, another item might not have description at all. And you can add as many attributes as you'd want for your item. You can even have a hierarchy of things inside your item as well. So if you'd want, you can go in here and say, I'd want this thing to have a complex structure. And you can go ahead and say, I'd want to define a JSON like this. So I can say this one will have an attribute 1 with value 10, comma, attribute 2 with value 20. So you can see that your document database gives you a lot of flexibility in how you define your data. You can go ahead and say create item. And until now, what we are doing is something called scan. So when we do a scan, we are querying against all the rows in the table. Scan is a very, very expensive operation. And that's why typically it is recommended to do query. When you use query, you need to query using the primary key or you need to query using the index. This table does not have any additional indexes, so we'll query using the primary key itself. So I can say I would want to query the to-do table and I would want to look for ID 3 and say run. So this is query where we are getting a specific row back. Now let's go back to view table details. This is where we can see all the details around the table. Over here in the indexes tab is where you can create indexes. Right now we are able to query using ID. If let's say I would want to query by using username or things like that, that's when you can create an index. You can go ahead, create an index on the username, and you can start using username to query your table. You can also look at metrics in the monitor tab. Over here you can create alarms if you want. Basically you can look at DynamoDB metrics, for example read capacity units, write capacity units, and if you want you can get notifications. If you scroll down, you can also see all the metrics that are coming in from CloudWatch. You can see the provisioned read capacity units and the read capacity units which we made use of in here. We have executed very few transactions, so we did not make use of a lot of the read capacity units. You can also see a lot of metrics related to write capacity units, latency, and a lot of other metrics in here. DynamoDB also allows you to create a global table. If you want to replicate this table to multiple regions, you can go ahead and say, I want to create a replica. You can choose the regions where you'd want to replicate this table to. Let's do a cancel. In addition, you can also configure backups. You can process all the changes that are happening in DynamoDB as a stream, and also you can configure read-write capacity and a lot of other settings in additional settings. If you scroll down, you'll also be able to manage the encryption. You can see that by default, data is encrypted and this is being managed by DynamoDB. If you want, you can click manage encryption and you can use your own key to encrypt the data. You can create a key in KMS and you can use that to encrypt the data in DynamoDB. I would cancel this. In this step, we played around with DynamoDB. I'm sure you're having a wonderful time, and I'll see you in the next step. In the previous steps, we looked at structured data and semi-structured data. It's time for unstructured data. You have video files, audio files, images, text files, binary files. How do you store them? That's where you would go for object, block, and file storages. Let's look at them in this specific step. What is unstructured data? Data that does not have any structure. Audio files, video files, binary files. These are good examples. There are different places where you can store your unstructured data. For example, what is the type of your hard disk? The type of your hard disk is something called block storage. Whenever you want to associate a hard disk or network storage with your virtual machines, that's when you'd go for block storage. The managed service in AWS for block storage is Amazon EBS or Elastic Block Store. In Azure, it's Azure Disks, and in Google, it's Google Cloud Persistent Disk. Let's look at another use case. You have created a file share to share a set of files with your colleagues in an enterprise. So you have created a file share and you'd want to share it between multiple virtual machines. What is the type of storage you are making use of? That's where you are making use of file storage. And the recommended service in AWS is Amazon EFS. In Azure, you can make use of Azure Files, and in Google Cloud, it's Google Cloud File Store. Let's look at another use case. You want to be able to upload and download objects or files using a REST API without mounting them onto your VM. If you are making use of file storage or if you want to make use of block storage, you need to first connect these or mount these onto your virtual servers. However, in our specific use case, you'd want to be able to upload, download files or objects using a REST API without mounting them onto your VM. What type of storage are you using? That's where you'd go for object storage. And the most popular object storage service is Amazon S3 or Simple Storage Service. In Azure, you'd go for Blob Storage or Azure Blob Storage. And in Google Cloud, you'd be making use of Google Cloud Storage. What we are looking at right now are some of the most popular ways you can store your unstructured data. If you want to store unstructured data as part of your hard disk that is attached to a virtual machine, you can go for block storage. If you want to create a file share, which is shared between multiple virtual machines, that's when you would go for file storage. And if you want to upload, download files using a REST API, you'd be making use of the object storage services in the cloud. In the next few steps, let's look at block storage, file storage, and object storage in much more detail. I'm sure you're having a wonderful time, and I'll see you in the next step. In this step, let's talk about block storage. You want a hard disk attached with your computer. That's when you would make use of block storage. Typically, one block storage device can be connected to one virtual server. You can see that each of these block storage devices is connected to only one virtual server. However, you can connect multiple block storage devices to one virtual server. If you have a computer or a laptop, you can attach a number of hard disks to it. But one hard disk at a point in time can only be connected to one computer or one laptop. And in AWS, if you want to make use of block storage, you have two options. The first one is Elastic Block Store. The second one is Instance Store. Instance stores are physically attached to the EC2 instance. You can see that there is a host computer, and on the host computer, you can have any number of EC2 instances. And on the host computer, you also have additional storage. And this storage is where your instance stores are stored. So instance stores are stored on the same host computer as that of the EC2 instance. So instance stores are physically attached to the EC2 instance. The life cycle of an instance store is directly tied to that of the EC2 instance. If you stop the EC2 instance, the instance store disappears. And therefore, instance stores are recommended only for temporary data. Once the EC2 instance is terminated, you'll not be able to access the data at all. However, Elastic Block Store, on the other hand, is network storage. And therefore, it is more durable. Lifecycle of an Elastic Block Store is not tied to that of the EC2 instance. You can disconnect an Elastic Block Store from an EC2 instance and you can connect it with another EC2 instance. Even after you terminate the Elastic Compute Cloud instance, if you'd want, you can retain the Elastic Block Store device. In this step, we got a quick introduction to the block storage options in AWS, instance stores and Elastic Block Store. I'll see you in the next step. In this step, let's play with Elastic Block Store. I'm in EC2 or the Elastic Compute Cloud, and right now I have no instances running. So what I'll do is I'll quickly launch an instance. So I'll go in here, say launch instance. I'll take the defaults for most of the things which are present in here. I'll give it a name, my instance to play with EBS or Elastic Block Store. Let's go ahead and launch the instance. It's asking for a key pair. Let's select the default key pair and say launch instance. And if I go to instances, you can see that our instance is being launched right now. So whenever we create a virtual machine, we would want to assign some storage with it. And typically, the storage which is assigned is block storage. Where does your operating system run from? It runs from the root volume. And the root volume typically is block storage as well. So we have created an instance and it's now in running state. And now if I go over to Elastic Block Store, this is where you can see the block storage devices which are attached with your EC2 instances. I'll go to volumes and you can see that there is a volume which is in here. You can see that the size of it is 8 GB. If you select this specific volume and go inside, you'd be able to see that this is attached with our EC2 instance, my instance to play with EBS. So this is the root volume which is attached with our EC2 instance. If you connect to the EC2 instance and if you store a few files on the EC2 instance, all those files would be getting stored on this specific volume. If you go to monitoring, you can look at metrics around your Elastic Block Store. We have just created the instance, so there are hardly any metrics available. But after a little while of playing with the EC2 instance, if you come in here and if you look at monitoring, you'll be able to see a lot more metrics. One of the great things about Elastic Block Store devices is that you can modify them even while they are attached with your EC2 instance. If you'd want, you can actually increase the size of it or change the type of it. let's say I would want to increase the size to 15 GB or 20 GB. I can do that while the volume is attached with the EC2 instance. What I'll do now is I'll go ahead and say cancel. If you go to actions, you can also take a snapshot of your Elastic Block Store volume. So for this volume, I can create a copy. A snapshot is nothing but a copy. You can go ahead and say, I want to create a snapshot. I want to take a copy of this specific thing. So this would create a point-in-time snapshot to back up the data which is present on the Amazon EBS volume. The backup will be stored in an object storage service in AWS, which is Amazon S3. I don't really want to create a snapshot. I'll say cancel in here. The place where you can actually look at the snapshots which are created is in here. So you can look at all the snapshots right here. And if you have a snapshot, you'll also be able to use it to create an EBS volume. Let's go back to EC2. Let's go back to instances. And I would go ahead and say instance state, terminate instance. And over here, as it says in here, the default action is that root EBS volume will be deleted when the instance is terminated. I'm fine with that. So let's go ahead and say terminate. So it's shutting down. Let's wait for the instance to shut down. And now the state is terminated. It took about a minute or so. And now if I go to Elastic Block Store volumes, you would see that there are no volumes present in the specific region. So as soon as you have actually terminated a EC2 instance, the Elastic Block Store that is associated with it is also deleted. If you don't want an Elastic Block Store volume to be deleted when an instance is terminated, you can also configure it on the EC2 instance. When you're launching an EC2 instance, for example, if I go ahead and launch a new instance, and over here, I can scroll down. This is where we can configure the amount of storage that we would want as part of our root volume. So you can configure a root volume, and if you want, you can add more volumes. You can add multiple block storage devices with your EC2 instance. And if you go to advanced, if you expand the volume which is present in here, you'd also be able to see additional options which are present in here. If you want, you can also enable encryption, encrypted yes or no. So if you want, you can say yes, and you can choose the key which you would want to use to do the encryption. And you can also configure delete on termination. If you don't want this block storage volume to be deleted when the EC2 instance is terminated, then you can put it to no. In this step, we looked at the block storage service in AWS, which is Elastic Block Store. I'm sure you're having a wonderful time, and I'll see you in the next step. In this step, let's talk about file storage. Media workflows need huge shared storage for supporting processes like video editing. Let's say I have a team which is working on video editing, and they would want to be able to share files between their virtual machines. Enterprise users need a quick way to share files in a secure and organized way. You might be working in a project where you would want to share a few files with each other. The file shares, which are created using file storage, can be shared between multiple virtual servers. And the service in AWS that you can use to create file shares is Amazon EFS. It is a petabyte scale, auto-scaling, pay-for-use shared file storage. If you store less number of files, you pay less. If you want to store more number of files, you need to pay more. So it's pay-for-use, and it's auto-scaling. You can put as much data as you would want, and the EFS file share would grow in size along with your files. You can store up to petabytes of data. Amazon EFS is compatible with Amazon EC2 Linux-based instances. If you want to create a home directory for your users, or if you want to create a file share, or if you want to do content management, that's when you can go for Amazon EFS. There are a couple of alternatives for EFS in AWS. Number one is Amazon FSx for Lustre. This is file system which is optimized for performance. If you have high performance computing and media processing use cases, you need high performance. And that's where you would go for Amazon FSx for Lustre. Amazon FSx for Lustre supports automatic encryption at rest and in transit. the data is encrypted at rest. So basically, while it's stored in a file share, it is encrypted, as well as in transit when you're sending the data from the file share to, let's say, a host computer. Even then, it is encrypted. Another alternative for Amazon EFS is Amazon FSx Windows file servers. These are fully managed Windows file servers, and these can be accessed from Windows, Linux, and Mac OS instances. The great thing about Amazon FSx Windows file servers are that they integrate really well with Microsoft Active Directory. So if you need to support Windows-based environments and enterprises and you would want to create file shares for them, you can consider Amazon FSx Windows file servers. Similar to Amazon FSx for Lustre, this also supports automatic encryption at rest and in transit. In this quick step, we looked at some of the file storage services in AWS. I'll see you in the next step. We looked at block storage, we moved on to file storage, and now it's time for object storage. And the object storage service in AWS is Amazon S3. It's also called Simple Storage Service. S3 stands for Simple Storage Service. It is the most popular, very flexible, and inexpensive object storage service in AWS. You can store objects using a key value approach. You can create a S3 bucket and you can upload files as objects. And each of these files will have a key and the content of the file will be the value. S3 provides you with a REST API to access and modify objects. You can upload objects, you can delete objects, and you can version them. You can do a lot of things with Amazon S3 using a REST API. Amazon S3 provides you with unlimited storage. You can upload as many objects as you would want into your buckets. And it provides you with very high availability and durability. We are looking at the availability and durability of the standard S3 storage class, and it provides you with 4 nines availability, 99.99% availability, and 11 nines durability. It's 99.99 durability. So the chance that you would lose something you put in S3 is very, very, very less. All objects in S3 are replicated in a single region across multiple availability zones. And in S3, you can store a variety of file types. You can store text files, binary files, backups, and archives. These can be used to store media files and archives. You can store your application packages, basically your deployable units, and your application logs as well. You can store backups of your databases, backups of your storage devices. And if you're migrating from on-premises to cloud, you might want some place where you'd want to put all the staging data in. So before you upload a data into a cloud database, you'd want to temporarily store the data somewhere. And S3 can be a great place to put your staging data. As you can see in here, S3 is very, very flexible. It provides you unlimited storage with high availability and durability, and you can store a variety of files. And that's why you'd see S3 being used in a number of use cases. There is one more object storage service in AWS, which is called Amazon S3 Glacier. What is the difference between S3 and Glacier? S3 Glacier is recommended for extremely low-cost storage for archives and long-term backups. You would store frequently accessed data in S3. However, if you have archive data which you will not access frequently at all, in those kind of situations, you might want to go with S3 Glacier. Why? Because it's extremely cheap. It provides you with extremely low-cost storage for archives and long-term backups. So if you have old media content, or if you are storing a few archives just to meet regulatory requirements, for example, old patient records, or you'd want a replacement for your magnetic tapes. You might be storing a lot of data in your magnetic tapes and you'd want to replace them and you'd want some low-cost storage in the cloud. That's when you'd go for Amazon S3 Glacier. Similar to S3, S3 Glacier also provides you with high durability. It provides you with 11 nines durability, and it provides you with high scalability. You can store as much data as you would want in S3 Glacier. It also provides you with high security. Data is encrypted at rest. That's basically when it is stored in S3 Glacier, and also in transfer. That's basically when it is being transferred into S3 Glacier or it is being transferred out of S3 Glacier. In this step, we looked at the two most popular object storage services in AWS. For most of the use cases in AWS, if you want object storage, you are going for Amazon S3. However, if you want low-cost storage for archives and long-term backups, which you are not planning to access in a long time, in those kind of situations, you can make use of Amazon S3 Glacier. I'm sure you're having a wonderful time, and I'll see you in the next step. In this step, let's explore S3, Simple Storage Service. If you type in S3 in here, you should reach S3, Scalable Storage in the cloud. Let's launch up S3. In S3, if you want to store data, you need to create a bucket. Let's go ahead and create a bucket. As it says in here, buckets are containers for data stored in S3. A very important thing to remember is that the bucket name must be globally unique, not just in your AWS account, but across all AWS accounts and in all regions. Let's go ahead and give this bucket a name. I'll call this my bucket in 28 minutes. I'll choose the Asia Pacific Mumbai region. You can choose whichever region you are comfortable with. I'll take defaults for all the other settings and I'll say create bucket. You can see that I'm getting an error saying bucket with the same name already exists. What I'll do is I'll actually add in -123 to this to make it globally unique. And I'll go ahead and say create bucket. Okay. Successfully created bucket. My bucket in 28 minutes, 1, 2, 3. And I can see the bucket in here as well. So let's go and pick up this bucket, my bucket in 28 minutes, 1, 2, 3. By default, we don't have any objects in here. In S3, you can upload objects. How can I upload objects? I can click upload in here. There are multiple ways you can upload content to S3. You can use add files, add folder, or you can drag and drop files in here. What we'll do now is to drag and drop files. In the previous lecture, you'll find a link to be able to download a zip file. If you extract the zip file, you should see folders like this. What I would recommend you to do is to extract the zip file, select everything which is present in the zip file, 2030, cloud, process, tools, and the index.html. Select all of them and drag and drop them in here. And what I would do now is take the default permissions and say upload. You can see that the uploading is now in process. It took about a couple of seconds, I would say, and I saw upload is successful. So what we have done is created a bucket and uploaded objects into the bucket. You can see that now we have 12 files in this S3 bucket. So let's go back to the bucket. I'll click this link which is present in here. This would take us back to the bucket. If you see the bucket right now, you would see something kind of a folder structure in here. So you can see a folder called 2030 under which you have two folders, 10 and 11, and you have another course.png in here. If I go back to the root folder of the bucket, you'll be able to see other folders as well, cloud, process, tools, and everything else in here. Even though S3 is showing this as a folder structure, actually internally S3 stores this as a key value pair. So if I select index.html, the way index.html is stored as a key value. What is the key? The key, if you look at index.html, is index.html, and the value is the content of the object. Let's go to the root and let's pick up something in 2030 folder. So in 2030, let's pick up code0.png. What is the key? The key is 2030/core0.png. Even though S3 is actually showing it as if there is a folder called 2030 and inside that there is a course.png. However, the actual thing is that S3 stores it as a key value pair. This is the key and the value is the content of this specific file. If I go back to 2030 folder and I click inside 10 and select one of the courses in here, you'd see that the key for this is 2030/10/course1.png. This is the key and the value is the content of the course1.png. It's very, very important to remember that even though visually S3 is showing this as if it's a folder structure, internally S3 stores this as a key value pair. Let's select index.html and explore this further. You can see that there are a lot of properties related to index.html. There is a URL you can use to access this specific object. You can see that this is in AP South 1. You can see the details about this specific object. When was it last modified? What is its size? What is the type of object? Now, let's move over to properties and explore the properties tab in here. You can see the high-level overview details of this bucket, which region, what is the Amazon resource name, and what's the creation date. In here, you can also play with bucket versioning. Versioning is a means of keeping multiple variants of an object in the same bucket. Sometimes you might want to store different versions of the same file. In those kind of situations, you can turn on versioning. You can go into edit and you can say, I would want to enable versioning. I'll not enable versioning for now, but it's an option that you have. What will happen if your versioning is on is that if you upload a new object, it would be stored as a new version. Instead of replacing an existing object, it would be stored as an additional new version object. Versioning can actually help you to easily recover from unintended user actions. If versioning is not on, if by mistake a user uploads a file and it replaces existing file, the existing file is lost. However, if versioning is on, you still have a backup of the old version. You can also add tags to your S3 bucket. You can also enable encryption on the S3 bucket. Let's go ahead here and you can say edit, and I would want to enable encryption, and I would want to use Amazon S3 managed keys. A little later, we'll be talking about KMS, key management service. In key management service, you can create your own encryption keys and you can use them to encrypt your objects in S3. For now, let's keep things simple and let's use a key which is managed by S3 itself. So we'll be using Amazon S3 managed keys to encrypt the objects which are present in this specific bucket. What I'll do now is to go ahead and save changes. One important thing to remember is that this will only encrypt new objects in this bucket. The existing objects will be stored unencrypted. Any new objects which will be added in, those are the ones which will be encrypted. So let's go ahead and say save changes. If you scroll down, you can also enable server access logging. So you can go in here, you can say edit, and you can enable server access logging. If anybody tries to access an object in the bucket, it would be logged in a S3 bucket of your choice. For now, I'll go ahead and cancel this. In addition, you can also log events in CloudTrail. Some enterprises also want auditing on the objects which are present in your S3 bucket. Anytime an operation is done, you'd want to log it somewhere. And in AWS, the auditing service is AWS CloudTrail. If you enable AWS CloudTrail data events, if any action is done on any object in S3, it will be tracked in AWS CloudTrail as an event. S3 also has this feature called event notifications. For example, if somebody uploads an object, you'd want to invoke a Lambda function. You can do that by creating an event notification. You can go into create event notification and you can choose which events you'd want to trigger things on. And at the bottom, you'll also be able to choose the destination. You can invoke a Lambda function, or you can send a message to SNS or SQS. SNS is simple notification service and SQS is simple queuing service. Let's do a cancel in here. If you scroll further down, you would see that there is a feature called object lock. Certain enterprises might have regulatory needs or compliance needs, and they don't want to allow deletion of objects. Once something is uploaded, they would want to retain it forever. That's where you can set up object locks. The thing is, you cannot add object lock on an already existing bucket. If you'd want to add object lock, you should enable it while you are creating a bucket. How do I do that? Let's open up buckets in a new tab. And I'll try and create a new bucket. I don't worry about rest of the things. Let's go directly to the feature where we can enable object lock. So this is where you can go in and enable object lock. So while creating your bucket, you can enable object lock. One of the things that you need to remember is that object lock only works on versioned buckets. So if you enable object lock, it would automatically enable bucket versioning as well. I'll close this window and go back to our previous window. In this step, we created a S3 bucket, we uploaded objects to it, And we played around with the S3 bucket. One of the things that might be interesting for you to know is that S3 can also be used to set up a static website. How can you do that? That's what we'll be exploring in the next step. I'll see you in the next step. In the last step, we created a bucket and we have uploaded a number of objects to this. If you look at all these are static objects. We have a HTML file, we have a number of images, and we would want to expose this static content as a website. How can we do that? Let's look at that in the specific step. The first thing I would need to do is to enable website hosting. How can I do that? If you go over to Properties and scroll down to the bottom, there is something called Static Website Hosting. Use this bucket to host a website, and it's currently disabled. Let's go ahead and enable this. Edit, enable. What we want to do is to host a static website, and the index document is index.html. We have a file called index.html at the root. So let's use index.html. Let's take the defaults for rest of the things and say save changes. So we have enabled static website hosting right now. And over here, you can also see the website at which our content is exposed at. So I'll go ahead and click this. You can see that I am getting a 403 forbidden. It says access denied. The reason why we are getting access denied is that there are a few more things that we would need to do before our website is up and running. We will need to set up a few permissions. Let's go to permissions. The first thing that we would want to configure is disable block public access. By default, public access is not enabled for your S3 buckets. You can see that block all public access is on. What we want to do is to disable that. We would want to expose the content of the S3 bucket out to public. So we would want to disable block public access. So let's go ahead and edit this, and I'll disable this. And I'll say save changes. I want to confirm this, and I'll say confirm. Now you can see that block public access is off, and objects in this specific bucket can be public. Is that the end of the story? Will we be able to access? Not yet. There is one more thing that you need to do. That's to configure a bucket policy. You need to configure a bucket policy allowing access to all objects in this specific S3 bucket to public. I'll go ahead and click learn more in here. This would take you to the generic policies and permissions page in here. What we are interested in is bucket policies. On this page, on the left-hand side menu, you would see policies and permissions at the bottom. If you scroll down, you'd be able to see bucket policies. In bucket policies, you'll also be able to see bucket policy examples. You can also get to here by actually searching for S3 bucket policy examples directly. Over here, what we are really looking at is granting read-only permissions to anonymous users. So we want to be able to give public access. Basically, anybody can look at our static website. So we want to grant read-only permission to any user, to everybody. So I'll go ahead and copy this. And I'll go back to my S3 bucket and paste. And I would say edit. And I'll paste this in. Now, a very important thing is to change the name of the bucket. So over here, the doc example bucket is an example bucket. What we want to do is to replace that with the name of our bucket. So my bucket in 28 minutes 1, 2, 3 is the bucket I'm using. You might be using a different name. So go ahead, choose that and put it in here. So for every object in the specific bucket, we are giving public read. So we are actually allowing everybody, basically star in here means public. We are allowing everybody to read the objects in this specific bucket. Let's go ahead and save changes. When I save changes, I get an unknown error and it says policies must be a valid JSON and the first byte must be an open brace. So let's go ahead to the top. Let's see if there's a problem with our JSON. So there's a space at the start. Let's remove that. And let's try saving it again. This time the save is success, and you can see that access is now public. And if I go and launch our website, awesome, our website is now getting launched up. So we are looking at the index.html, which are referring to a lot of static images which are present in the same folder. You can see that we are now able to set up a website using S3. So we uploaded all the content to our S3 bucket, and there were 3 steps in creating a static website. One was going to properties and enabling static website hosting. Once we enable static website hosting, we needed to disable block public access. And now we were ready to expose our objects to public. And to be able to expose objects to public, we needed to configure a bucket policy allowing public read to everybody on these specific actions, get object and get object version. The details are not really important. What is really important is that if you want to create a static website in AWS, one of the options to consider is Amazon S3. I'm sure you're having a wonderful time, and I'll see you in the next step. In the last few steps, we looked at block storage, we looked at file storage, and we looked at object storage. With all the storage services that we talked until now, all the data is stored in the cloud in AWS. What if you'd want to go for hybrid storage? You want to store some data on the cloud and some data on premise. That's when you'd go for AWS Storage Gateway. AWS Storage Gateway provides you with unlimited cloud storage for on-premise software applications and users. And it also provides you with really good performance. AWS Storage Gateway provides you with 3 different options: File Gateway, Tape Gateway, and Volume Gateway. What is File Gateway? Let's say you have a large on-premise file share with terabytes of data. User put files into this file share, and applications use the files from the file share. And you see that managing it is becoming really expensive. You'd want to move the file share to the cloud without any performance impact. How can you do that? That's where you will go for AWS Storage File Gateway. AWS Storage File Gateway provides cloud storage for your file shares. The files which you store in AWS Storage Gateway are finally stored in Amazon S3 and Glacier. The next option is AWS Storage Tape Gateway. A lot of enterprises even today make use of tape backups. If they would want to archive something, they would take a tape backup. These tape backups are typically stored off-site, and the process to take tape backups is expensive, and also these tapes are subject to physical wear and tear. If you want to avoid taking tape backups, in those kind of situations, you can go for AWS Storage Tape Gateway. The great thing about AWS Storage Tape Gateway is that there is no change needed for your tape backup infrastructure. So using the same tape backup infrastructure that you are using currently, you can backup data to virtual tapes. And these virtual tapes will be stored in Amazon S3 and Glacier. So if you want to avoid physical tapes and still take tape backups using your existing tape backup infrastructure, in that kind of scenario, you can make use of AWS Storage Tape Gateway and take your tape backups to Amazon S3 and Glacier. The next type of storage gateway is AWS Storage Volume Gateway. This is hybrid block storage. This is cloud-backed iSCSI block storage volumes. Let's take an example. Let's say you have applications which are inside your corporate data center for which you would want to provide block storage. One of the popular protocols to talk to block storage is iSCSI. So your applications will think as if they are talking to some local block storage. But actually, when you are making use of AWS Storage Volume Gateway, the block storage is stored in AWS. You are storing your data either in S3 or in Elastic Block Store. There are 2 types of storage volume gateways. One is cached, the second one is stored. When you're making use of gateway cached volumes, the primary data store is AWS. So this is the primary data store, Amazon S3. Instead of retrieving all the data from S3, what we would do is we would have an on-premise cache. The frequently accessed data is cached on premises. The alternative is stored. This is gateway stored volumes. In gateway stored volumes, the primary data store is on premises. So this is the primary data store. Your applications will be directly talking to the primary data store, and an asynchronous copy is made to AWS, and this is stored as EBS snapshots. So if you'd want high performance, you'd want to store all the data on premises. That's when you'd go for stored. If you're okay with good performance, you can go with cached. So whenever we're talking about AWS Storage Gateway, we are talking about hybrid storage. If you have file shares that you'd want to move to the cloud, you can go with AWS Storage File Gateway. If you want to take tape backups and you want to store them on the cloud, you can go with AWS Storage Tape Gateway. And if you want block storage volume backups on the cloud, you'd be going for AWS Storage Volume Gateway. If you want high performance, you'd go for stored. Otherwise, you can go for cached option. In this step, we looked at AWS Storage Gateway. I'm sure you're having a wonderful time, and I'll see you in the next step. In this step, let's review some of the storage options in AWS. You want to store unstructured data in AWS? How do you do that? That's where you make use of block storage, file storage, or you make use of object storage. Let's look at some of the options in here. The first one is object storage. The most popular object storage service in AWS is Amazon S3 Simple Storage Service. It provides you with very, very flexible object storage. You can store large objects in buckets using a key value approach. The other type of storage is block storage. This is storage connected to one EC2 instance, similar to your hard disks. There are two types of block storages which are supported in AWS. Elastic Block Store, which is permanent storage, and Instant Store, which is ephemeral storage, which is temporary storage. The other type of storage is file storage. These are used to create file shares. You want to share storage between EC2 instances or virtual machines. The options that you have is EFS, which can be connected from Linux boxes. You have other options, FSX Windows and FSX for Lustre, which is recommended for high performance use cases. AWS also has an archive object service, that is Amazon S3 Glacier. Amazon S3 Glacier provides extremely low cost storage for archives and long-term backups. If you have archive data which you are not planning to access for long periods of time, you can put it into Amazon S3 Glacier. The last storage service that we talked about was hybrid storage, AWS Storage Gateway. In this step, we looked at some of the important options to store unstructured data in AWS. I'm sure you're having a wonderful time, and I'll see you in the next step. In this step, let's look at a few scenarios related to different data stores that we have talked about until now. Let's start with the first scenario. A startup with quickly evolving schema for storing documents. So you'd want to be able to store documents, typically JSON documents, and we are talking about quickly evolving schema. So basically we are talking about schemaless. You'd want as less schema as possible. That's where you can go with Amazon DynamoDB. If you want MongoDB compatible database, you can also go with Amazon DocumentDB. Next, transactional local database processing thousands of transactions per second. In these kind of situations, the recommended option is Amazon Relational Database Service. You'd want to store complex relationship between transactions to identify fraud. Whenever you'd want to store complex relationships, you are thinking about graphs. So you'd want transactions, you'd want to store relationships between them. That's when we are talking about graph, and that's where you'd go for Amazon Neptune. You want database for analytics processing of petabytes of structured data. So we are talking about structured data. So we are talking about relational database, and we are talking about analytics processing. So we are talking about OLAP, online analytics processing of huge volumes of data. That's where we are talking about the data warehousing service in AWS, which is Amazon Redshift. A little later in the course, in the analytics section, we will talk a lot more about Amazon Redshift. You want to create a file share between multiple VMs. You have multiple VMs, you want to share a few files, so you'd want to set up a file share. That's when you would go with file storage. And the file storage service in AWS is Amazon EFS. You want to store profile images which are uploaded by your users. So you have images which you'd want to store, and these needs to be uploaded by your users. So it's better to have a REST API or something which can be used to upload the images, and that's where you'd go for object storage. And the object storage service in AWS is Amazon S3. In this step, we looked at some of the scenarios related to the different data stores that we have talked about. I'm sure you are having a wonderful time, and I'll see you in the next step. In this step, let's talk about identity management in the cloud. You have a number of resources in the cloud. You're creating a virtual machine, you might be creating a database, you might be creating a queue. So there are a lot of resources that we are creating in the cloud. And you have identities. You have human identities and you have non-human identities. Basically, there are people who want to access these resources and perform actions. And also, there are applications, there are other services which are non-human, which also want to access these resources. For example, you'd want to launch a virtual server. You'd want to stop, start, or terminate a virtual server. So there are a lot of actions that you'd want to perform. How do you identify users in the cloud? How do you configure resources that your users can access? How do you configure what actions are allowed on a specific resource? That's where in AWS we would go for IAM, or Identity and Access Management. In AWS, Identity and Access Management takes care of authentication. Is it the right user? Authorization. Do they have the right access? Identity and Access Management, or IAM, provides you with very granular control. You can limit a single user to be able to perform a specific action on a specific AWS resource only from certain range of IP addresses, or only from a specific IP address, and only during a specific time window. So AWS provides you with very granular control using IAM. And using IAM, you can take care of authentication and authorization. You can provide authorization at a very granular level. You can provide authorization to provide specific actions on specific resources only from a specific set of IP addresses during a specific time period only. Let's start with looking at some of the important IAM concepts. The first concept is IAM users. These are users who are created in our AWS account. At the start of the course, we had a root user, and we use the root user to create a new IAM user. These IAM users have credentials attached. You can either have a name and a password attached with your IAM user, or you can have access keys attached with your IAM users. You might have thousands of users, and you don't want to manage permissions at the level of individual users. That's where you would create groups. A group is nothing but a collection of IAM users. So instead of managing permissions at the user level, you can create a group with a number of users, and you can manage permissions at the group level. In addition, IAM also has a concept called role. IAM users have permanent credentials attached. They have a name, password, or they have access keys. However, roles are temporary identities. They don't have any credentials attached. If you'd want to get temporary access to some AWS resource, the recommended approach is to make use of roles. And the biggest advantage of going for roles is that they expire after a set period of time. If you want to provide permanent access to somebody, you can create IAM user. However, if you want to provide temporary access, the recommended approach is to go for roles. Roles expire after a set period of time, and they do not have any credentials attached with them. Now, how do you assign permissions to IAM users or groups or roles? That's where you would go for policies. You can attach policies with IAM users, IAM groups, and IAM roles. And these policies provide permissions to your IAM identities. So policies provide permissions for IAM users, groups, and roles. Before we get further into IAM, let's look at an example policy. Over here, we are using this policy to give permissions to a specific user. A policy is nothing but a JSON document with one or more permissions. You can say, I want to allow or deny. That's effect. And you can specify which resource. So you can say resource, which resource are you providing access to? And you can say what actions are allowed on a specific resource. And you can also specify conditions. Do you want to specify any restrictions on IP address ranges or time intervals? Let's look at an example in here. You can see that this specific policy is allow. We are putting a star in here. This means you want to allow all actions, and you're putting star in here as well. That means you would want to allow all actions on all resources. However, if you want to restrict a set of actions, you can specify something like this as well. You can say, I only want to allow S3 get or S3 list actions on specific bucket. So I am listing a name of a bucket in here. So I would want to allow get and list only on specific bucket as well. So an IAM policy helps you to define the restrictions. In this step, we talked about the fact that IAM or Identity and Access Management is the authentication and authorization service in AWS. We talked about the fact that IAM provides you with very granular control. And we talked about the most important IAM concepts. IAM users, IAM groups, and IAM roles are the different identities. And you can use policies to define permissions for these identities. I'm sure you're having a wonderful time, and I'll see you in the next step. In this step, let's explore IAM. IAM, Identity and Access Management. This is where you manage access to your AWS resources. Let's go into IAM. Over here, if you go in, you will be able to see multiple menu items on the left. The important ones for us are user groups, users, roles, and policies. Policies define permissions, and you can assign permissions to users or user groups or roles. Let's start with exploring users and user groups. Earlier in the course, we created a user group called developers, and we created a user called in28minutes_dev. That is the exact user I'm making use of in here. This in28minutes_dev is assigned to the group developers. And what permissions that the developer group have? The developer group has administrator permissions. If I go to permissions, you can see that this has administrator access. So it has all access to everything inside my AWS account. Now what we'll do is we'll create another user with limited access. So what I'll do first is I'll go ahead and create a group. Anytime we would want to create a user of a specific type, what I would want to do is to create a group that represents that specific type. So let's go ahead and create a group. This set of users, what I would want is to give them access only to EC2 instances. I'll call this group as EC2 group. And I would want to limit the permissions that I would want to assign to this specific group. I only want them to have access on EC2. So I'll type in EC2, press enter. You can see that there are a wide variety of EC2 related policies in here. What I want to configure is EC2 full access. So only access to EC2, EC2 full access. So he'll be able to do all things on EC2 instances. So he'll be able to do all things for EC2 service only. Let's go ahead and choose that rule. Let's go ahead and choose that policy and say create group. So anybody who belongs to EC2 group will be able to play with EC2 service only. You can see that right now we don't have any users for that specific group. Let's go ahead and create a user. I'll go to users and I would say add users. I'll call this guy as EC2-user and I'll give him AWS Management Console access only. So he'll be able to use AWS Management Console and log in. I'll assign a custom password. And I would not want him to reset the password. So I'll disable this and I'll say next permissions. To give permissions to the user, I can either add him to the group, or you can copy from an existing user, or you can attach policies directly. What I would do is to attach him with a group. So I will choose the group EC2 group. This would give him access to only EC2. Once I assign him to a group, I'll say next. And what I'll do now is I'll go ahead and say review. The details look good. So let's go ahead and create the user. So the creation of the user is successful. Now I would want to log in and test with this specific user. I would want to check his access. How can I do that? I'll do a right click, copy link, and I'll also start up an incognito window. So this is kind of a private browsing window. So I'll go in there. I'll go to that URL. The name of the user that we have the name we gave to that user is EC2-user. I'm entering his password. And I would say sign in. You can see that your EC2 user is able to sign in into the AWS console. Now let's see if he's able to launch a EC2 instance. Let's go ahead to EC2. And over here, there are no instances running. So let's go to EC2 instances. And let's see if he's able to launch an instance. Let's launch an instance. I'll just call it test. I'll take defaults for everything which is present in here and say launch instance. Oops, it's asking for a key pair. So let's choose EC2 default and say launch instance. You can see that this guy is able to launch a EC2 instance. Let's see what else he is able to do. Let's wait for the instance to start up. Within a few seconds, I saw the instance state is running. The EC2 user has access to do anything with the EC2 instances, so he can even terminate it. So I can go in and say instance state, terminate instance. And I would want to terminate this. So you can see that he's able to play with the EC2 instance. He can perform actions on all the things that are part of the EC2 service. Now let's check another service. Let's go to S3, scalable storage in the cloud. You can see that when I go to S3, I get an error. It says you don't have permissions to list buckets. You can see that all the buttons in here are also disabled. So what we are seeing is that the EC2-user, the user which we created with only permissions to EC2, will only be able to do things on EC2. This is how you can do authorization in AWS. You would be making use of IAM. So you would create a user and you would give him restricted permissions. Now, what are the different types of permissions you can configure for users? Let's explore that right now. I will close this incognito window and I'll go back to the window where we were logged in with in28minutes_dev. In28minutes_dev has admin access. So he'll be able to access all the services in AWS. So let's go ahead to IAM. And go over to policies. Policies is where you can manage the permissions. You can see that there are a number of policies which are defined by AWS. All these ones with the AWS icon are what are managed by AWS. Let's look at a few examples related to S3. So I'm searching for S3. And over here, you can see that we have an example policy, Amazon S3 full access. If I expand this, you'll be able to see what access it provides. You can see that the effect is allow. So basically we are allowing a set of actions. You are allowing S3 related actions on all resources. Now, if you actually go further down and look at S3 read only. So S3 read only access. You can see that this is only allowing get and list actions. So you can see that there are a lot of predefined policies which are provided by AWS. And these are the policies which we would typically make use of when we would want to assign permissions to users. You can create your own permissions as well. You can go ahead and say, I would want to create a policy, and you can define a custom policy. But most of the times, we would be making use of AWS managed policies. This is how you can assign permissions to your users. So until now, we focused on giving permissions to users. Let's start looking at another scenario right now. You want to give permissions to an application which is running on an EC2 instance to access S3 bucket. How can you do that? That's where you can make use of roles. You can go over to roles, and I would create a role. And this role, I would want to associate it with a AWS service. Over here, what we want to do is to allow an application which is deployed to EC2 to talk to S3. So I will choose AWS service, and we would want to allow EC2 instance to call a AWS service which is related to S3. So I'll choose EC2 in here, and I'll say next. And what is the permission that we would want to give? We would want to give, let's say, all access on S3. This role should be able to access everything on S3. So I typed in S3, pressed enter, and now I can assign S3 full access. And I can go ahead and say next. I'll call this EC2 role to access S3. And I would say create role. You can see that when I'm creating a role, there are no credentials attached with it. There is no user ID, password, or a key that is attached with the role. Now that we have a role, you can take it and assign it to your EC2 instance. For example, I can go to services, EC2, and I would go to instances. Let's go and launch an instance. And when we are creating a EC2 instance, if you go to advanced details in here, if you expand advanced details, you should see IAM instance profile. This is where you can go in and select a role. So we have created a EC2 role to access S3. So you can create this EC2 instance with this specific role. And what would happen is when an application is deployed to this specific instance, which wants to access S3, it will be able to automatically use this role, and it will be able to access the content which is present in S3. So whenever you want an application which is deployed on EC2 or Lambda or ECS or EKS, when you want it to talk to another AWS resource, for example, like a database or S3 or any other resource in AWS, the recommended way to grant permissions to the application is by creating a role. So you create a role, give it the right access, and assign it to the compute resource. Over here, our compute resource is an EC2 instance. To the EC2 instance, we are assigning a role with the right permission. The great thing about this is that there are no passwords involved. You don't really need to configure any passwords anywhere. The permissions are directly assigned to your compute resource. In this step, we looked at a lot of things related to IAM. We looked at different IAM policies that are present. We also looked at an IAM user and how you can create an IAM user and how you can give permissions to him. And we also looked at IAM roles, how you can use IAM roles to effectively give permissions to your compute resources. I'm sure you're having a wonderful time, and I'll see you in the next step. In this step, let's talk about IAM best practices. Number 1, create individual users. Do not share your credentials between users. So for each user, there should be an IAM user mapped. Next is manage permissions with groups. If you have thousands of users, managing permissions at a IAM user level is very, very difficult. That's why group your IAM users, create groups, and manage permissions using IAM groups. Always grant least privilege. If somebody wants to be able to list a set of things on an S3 bucket, only give the permissions to list objects on that specific bucket. Do not give him generic access. It's very, very important to follow the principle of least privilege. In AWS, you have a service called AWS CloudTrail, which can do auditing for you. AWS CloudTrail can track all the events that has happened in your AWS account. You can track events, API calls, and a lot of things that happen in your AWS account. So it's always recommended to turn on AWS CloudTrail service. The next best practice is to configure a strong password policy. Make sure that you have a password policy which mandates a minimum length of at least 10 characters. You should have uppercase letters, lowercase letters, special characters, and numerals as well. So make your password policy as strong as possible. The next best practice is MFA, multi-factor authentication. AWS IAM supports multi-factor authentication. So you can enable multi-factor authentication in IAM for privileged users. When a privileged user logs in, when an admin logs in addition to asking for user ID and password, IAM will also ask for a second factor of authentication. The users will need to provide a second factor of authentication from their MFA device. The device might be a hardware device like Gemalto, or it can be a virtual device. It can be an app which is installed on user's smartphone. The next recommendation is to use temporary credentials or IAM roles for Amazon EC2 instances. For example, if you want EC2 instance to talk to an S3 bucket, the best way to implement that is to create a role with the permissions on the S3 bucket and assign the role to EC2 instance. This would ensure that you are not creating any permanent credentials, and whenever EC2 instance wants to talk to the S3 bucket, it can make use of the role, which provides it with temporary credentials. The next best practice is to use IAM roles to share access. If you want to provide cross-account access, for example, you have multiple AWS accounts for each of your environments. You might have a dev AWS environment and a production AWS environment. And if you want to give a dev AWS account user permissions to the production AWS account, you can create IAM roles for that as well. So if you want to share access, even there, you can make use of IAM roles. Next best practice is to rotate security credentials regularly. It's very, very important to mandate changing of passwords and keys regularly. The last best practice is to reduce or remove the use of root. When we created our AWS account, the account which we created was root account. Anybody who has access to the root account can do anything he wants with your AWS account. And that's why it's recommended not to use root account at all. As soon as you create an AWS account, it is very, very important to start creating an IAM user with admin permissions, and from then on, make use of the admin IAM user only. Never use your root account for day-to-day operations. In this step, we looked at some of the best practices related to IAM. I'm sure you're having a wonderful time, and I'll see you in the next step. Starting this step, let's look at encryption of data. And to be able to understand encryption of data, let's start with understanding the different states data can be in. Data can be at rest. That's basically when data is stored on a device or a backup. For example, data on your hard disk, data in a database. This is stored on a device or in a backup. So this is data at rest. So data on a hard disk, in a database, backups, archives, these are all data at rest. Next, data in motion. Data in motion is data which is being transferred across a network. Let's say you are trying to store some data from your EC2 instance to a database. This is data in motion. This is also called data in transit. Examples are data that is being copied from on-premise to cloud storage, an application in a VPC talking to a database. Data in motion can be of two types as well. One is you're moving data in and out of AWS, for example, on-premise to AWS or AWS to on-premise. And the other type of data in motion is within the AWS network itself. So we have talked about data at rest, data in motion. The last data state is data in use. This is active data in a non-persistent state. For example, data in your RAM, random access memory. RAM is not a persistent store, but this is active data. Now that we understood the different states that data can be in, let's talk about encryption. What would happen if you store data as is? What would happen if an unauthorized entity gets access to unencrypted data? Imagine losing an unencrypted hard disk. That's not good. The first law of security is defense in depth. Typically, enterprises encrypt all data, data on your hard disks, data in your databases, data on your file servers. Is it sufficient if you just encrypt data at rest? Nope. You'd also want to encrypt data in transit as well. The data which is being transferred between your application and the database as well. Data which is being transferred from your AWS network to on-premises and on-premises to AWS network as well. And how do you encrypt data? There are two approaches. One is symmetric key encryption. In symmetric key encryption, algorithms use the same key for encryption and decryption. So you can see that I have plain text, and the encryption algorithm uses the key and creates the ciphertext or encrypted text. And if you want to decrypt from ciphertext, the decryption algorithm will make use of the same key, and this would result in the plain text back. Whenever we're talking about symmetric key encryption, there are three key factors. Number one is making sure that the encryption algorithm which is used is really, really strong. Number two is securing the data encryption key. You don't want to lose the data encryption key. And the third one is, how do you share the data encryption key? Let's say I'm doing the encrypting and I'm sending the ciphertext to someone. For them to be able to decrypt it, they would also need the data encryption key. How can I share the data encryption key with them? So these are the three key factors when it comes to symmetric key encryption. Let's now talk about asymmetric key encryption. What is asymmetric key encryption? There are two keys, public key and private key. This is also called public key cryptography. So you would encrypt data with your public key. So if you want to convert plain text into ciphertext, you would make use of your public key. And you would decrypt with your private key. So the ciphertext is converted to plain text back using the private key. So what we will do when we are making use of public key cryptography or asymmetric key encryption is we would share our public key with everybody. Anybody who wants to encrypt data and send it to us can use our public key, encrypt the data, and send it to us. However, we keep the private key with ourselves. We don't share the private key with anybody. Now, you might be wondering, will somebody not be able to figure out the private key if I share the public key with them? The answer to that is that the creation of public key and private key is based on very, very complex mathematical operations. If you create public keys and private keys of sufficient length, for example, 128 bits, then it is impossible to figure out your private key using your public key. Now, you might be wondering, we are talking about encryption, we are talking about symmetric keys, asymmetric keys. How can you create asymmetric keys? How can you create symmetric keys? That's where in AWS, you would go for a service called KMS and Cloud HSM. KMS and Cloud HSM can be used to generate, store, use, and replace your keys, both symmetric and asymmetric. KMS is a multi-tenant key management system. So the key in here is multi-tenant. So your KMS is shared between multiple AWS customers. KMS integrates with all the storage and database services in AWS. You have data which is stored in different storage services. You have a number of database services as well. And KMS can integrate with them and automatically encrypt the data which is stored in that specific service. In KMS, you can also define key usage permissions. You can say this service can make use of the key. This person can make use of the key. You can also configure cross-account access. So a single KMS key can be used between multiple AWS accounts. KMS also has the feature to automatically rotate master keys once a year. When it comes to security, rotating keys frequently is very, very important. In KMS, you can automatically rotate keys once a year. One of the important things is if you delete the key, then you cannot decrypt the data which is encrypted using that key. So you need to be really, really careful when you delete a master key. And that's the reason why KMS provides a feature called scheduled key deletion. You can say, I would want to schedule the deletion of this key. And for a couple of weeks, you can check if that key is being used or not. If after a couple of weeks, you see that the key is not used at all, then you can go ahead and delete the key. The mandatory minimum wait period to delete a KMS key is 7 days. And the maximum can be up to 30 days. So KMS is multi-tenant key management service. However, if you want a dedicated single tenant hardware security module, in those kind of situations, you can go for Cloud HSM. There are certain domains, for example, banks, for example, financial institutions, where it is not recommended to share the key management service with multiple tenants. That's where you would need a dedicated single tenant hardware security module. That's where you would go for Cloud HSM. One of the very, very important things to remember is that even AWS cannot access your encryption master keys which are present in Cloud HSM. So it's very, very important that you are ultra safe with your keys. The recommended setup when you're using Cloud HSM is to use 2 or more hardware security modules in separate availability zones. In this step, we talked about encryption. We talked about symmetric encryption, asymmetric encryption, and we talked about the fact that KMS and Cloud HSM can be used to create your symmetric and asymmetric keys in AWS. I'm sure you're having a wonderful time, and I'll see you in the next step. Starting this step, let's look at KMS, Key Management Service. Securely generate and manage AWS encryption keys. I'll go over to Key Management Service. Easily create keys and control encryption across AWS and beyond. AWS Key Management Service is a managed service that makes it easy for you to create and manage keys and control the use of encryption across a wide range of AWS services. What we'll do now is we'll create a Key Management Service key and we will use it to encrypt data in S3. So let's start with creating a Key Management Service key. I can go ahead and say create a key. You can see that there are 2 types of keys that we can create: symmetric keys and asymmetric key. Symmetric key is when the same key is used for encryption and decryption. When you're going for asymmetric, you're creating a key pair. You're creating a public key and a private key. So a different key is used for encrypting and the different key is used for decrypting. Let's stick with symmetric key for now. What we want to do with the key is to encrypt and decrypt. We would want to encrypt and decrypt data using this specific key. Let's go ahead and click next. I'll choose the defaults on the next page and say next. Over here, I would need to enter an alias. So I'll call this my key to encrypt data in S3. And I would say next. On the next page, you can define the permissions on the key. The first thing that we would define is the key administrators. Basically, the IAM users and roles who can administer the key, who can manage permissions for this specific key. Let's say I would want in28minutes_dev to be the only guy who should be able to manage permissions for this specific key. So I'll select in28minutes_dev. And also we are configuring key administrators to be able to delete this key as well. I'd go ahead and say next. Next, we are defining the key usage permissions. Who can use this key? Again, I would give it to the same user in28minutes_dev. If you want other AWS accounts to access this key, to make use of this key, you can also add their details in here. You can say add another AWS account and you can enter the ID of the AWS account in here. For now, I don't really want to worry about it. So let's click remove and I would say next. So our configuration for the key is ready. Let's go ahead and say finish. So we now have a key ready. We would want to use this and encrypt data in S3. How can we do that? Let's go to our S3 bucket. So S3, scalable storage in the cloud. I would say create a bucket. Let's create my KMS encrypted bucket. That's the name I would give it. Hopefully it's unique across. I'll choose the defaults for all the options in here except for default encryption. You'd see that server-side encryption is disabled by default. What we want to do is to enable it. And you can see that by default it's choosing Amazon S3 managed keys. What we want to do is to use our own key, the key which we have created in KMS. So I'll choose AWS Key Management Service key. And I would go ahead and say, I would want to choose from my own AWS KMS keys. What's the key name? It's present in here. My key to encrypt data in S3. This is the one which I want to make use of to encrypt the data. So we are making use of this key to encrypt the data. Let's say create bucket. Oops, a bucket with the same name already exists. So I'll add in 28 minutes to make this unique. So let's go ahead and say create bucket. And let's go to the KMS encrypted bucket and upload a few objects. For now, I'll just upload one file. So let's go ahead and upload. Let's go ahead and upload any file. I'm uploading index.html, which we made use of earlier. You can pick up any file in there, a small file, and upload it in here. You can say upload. If you pick up the index.html file, you'd see that in encryption, if you scroll down, you can see under server-side encryption settings that the default encryption is enabled and it's making use of a key from KMS. And you can also see the key which is used to do the encryption. If you click this link which is present in here, it will open up a new tab where you can see the key which we have created in KMS. So you can see that this is my key to encrypt data in S3. This is the key which is used now to encrypt this data. So you can see that the file which is uploaded is automatically encrypted using the key from KMS. So what we have done in this specific step is we created a key in KMS and we mapped it to an S3 bucket. And once we mapped it, we saw that any object that is uploaded to that S3 bucket by default will be encrypted by making use of the KMS key. What I'll do now is delete this index.html. So I'll go ahead and say, select this index.html, delete. And I would want to type in permanently delete, and say delete objects. Successfully deleted objects. And now I want to delete this specific bucket. So let's go back to buckets. Choose the my KMS encrypted bucket in 28 minutes and say delete. I need to enter the name of the bucket now. So I'll copy this and paste it in here and say delete bucket. Okay, now the bucket is deleted. Let's see if we can delete the key in an easy way. Let's go to KMS, Key Management Service. And I'm selecting the key and I would want to perform actions. You can see that there is no action to delete the key directly. The thing is, if a key is used to encrypt data, you'll also need the key to decrypt data as well. So if you delete a key and if that key is used to encrypt data somewhere else, then you will not be able to access the data at all because the data is encrypted and you don't have the key. AWS wants to be really, really safe when it comes to the keys. And that's why they don't provide you with a direct delete feature. You can either disable the key or you can schedule key deletion. So you can say, I would want to schedule the deletion of this key. And you can configure a wait period. The minimum wait time is 7 days. And the maximum is 30 days. So what I'm right now doing is scheduling key deletion. And I would put the waiting period as 7 days. If for 7 days nobody is using this key, then AWS would go ahead and delete the key. So let's go ahead and schedule deletion. Oops, I need to confirm. And then I can schedule deletion. In the meanwhile, if you find that you're making use of this key somewhere, in that kind of scenario, you can come here and say key actions. You can even cancel key deletion. If you don't cancel key deletion, after 7 days, this key would be deleted by AWS. In this step, we looked at some of the important features related to key management service. I'm sure you're having a wonderful time, and I'll see you in the next step. In the last few steps, we discussed a number of services related to security in AWS. Let's explore some scenarios related to that in this specific step. Which of these are temporary identities? IAM roles or IAM users? The answer is IAM roles. IAM roles are temporary identities. They don't have any credentials attached with them. They don't have either a user ID or a password or a key attached with them. On the other hand, IAM users are permanent identities. When you're creating a user, you'd be assigning a user ID and a password, or you'd be assigning a key with it. How do you define permissions for IAM identities in AWS? The IAM identities are IAM roles or IAM users or IAM groups. And the way you can actually assign permissions to them is by making use of IAM policies. In your IAM policies, you can configure effect, whether you want to grant or deny. And you can configure what actions are allowed on what resources, and you can also specify certain conditions. You want to assign permissions for Amazon EC2 instances. Should you use IAM users or IAM roles? So basically, you are running an application on your EC2 instance, which might be talking to DynamoDB or which might be talking to S3 bucket. And therefore, your application needs permissions to access the details which are present in S3 bucket or in Amazon DynamoDB. How do you assign permissions to your applications which are running on EC2 instances? The way you do that is by going for IAM roles. You would create an IAM role with the permissions on DynamoDB table or on your S3 bucket, and you would assign the role to your EC2 instance. That's how your application which is running on your EC2 instance gets the permissions to access the right resources. Next, which of these services can be used to create symmetric and asymmetric keys for encryption? If you're using the same key for encryption and decryption, it's a symmetric key. If you're using different keys for encryption and decryption, you're making use of asymmetric keys. When we are talking about asymmetric keys, we'll have a key pair, a public key and a private key. And the way you can create these in AWS is by either making use of Amazon KMS or Cloud HSM. If you're okay with a multi-tenant service, you can go with Amazon KMS, Key Management Service. However, if you want a dedicated single tenant hardware security module for regulatory compliance, in those kind of situations, you can go with Cloud HSM, Cloud Hardware Security Module. In this step, we looked at some of the important scenarios related to security in AWS. I'm sure you're having a wonderful time, and I'll see you in the next step. In this step, let's get started with Amazon VPC, Virtual Private Cloud. What is the need for Amazon VPC? In a corporate network or an on-premises data center, can anyone on the internet see the data exchange that is happening between an application and the database? Let's consider an application which is talking to a database which is inside a corporate data center. Can anyone outside this specific network see the communication which is happening between the application and the database? The answer is no. Can anyone from internet directly connect to your database? Can anybody from internet be able to connect to this database and perform operations against it? The answer again is typically no. You don't want to allow anybody to directly connect to this database directly from internet. Typically, you need to connect to your corporate network, and then you would want to access the applications or the database. Corporate network provides a secure internal network for protecting your resources, your data, and your communication from external users. Not only your application and the database, but also the communication which is happening between the application and database is not visible from outside. How do you create such networks in the cloud? How do you create your own private network in the cloud? That's where you would go for VPC or Virtual Private Cloud. Amazon VPC is your own isolated network in the AWS world. All the network traffic within a VPC is isolated. Basically, it's not visible from any other Amazon VPCs. And you, as the customer, you can control what traffic is allowed into a VPC and what traffic is allowed from a VPC. So you can control all the traffic coming in and going out of a VPC. The best practice is to create all your AWS resources. Whether we talk about compute, storage, databases, any of the AWS resources that you create, it is recommended to create them in a VPC. This helps you to secure these resources from unauthorized access, and also you can enable secure communication between your cloud resources. One of the most important concepts in a VPC is something called a VPC subnet, a virtual private cloud subnet. The question is, why do we need a subnet? Different resources are created on the cloud. Databases, compute, you have load balancers, and a lot of other resources. And each type of resource has its own access needs. Public elastic load balancers are accessible from internet. A user should be able to directly connect to an elastic load balancer. He might be typing the URL of an elastic load balancer, and he should be able to talk to the elastic load balancer over the internet. These type of resources are called public resources. These are resources which need to be exposed on the internet. There are also things like EC2 instances and databases which should not be directly accessible from the internet. If anybody has to go to the EC2 instance, they have to go through the load balancer. Nobody should be able to directly access the EC2 instance or directly access the database. And these resources are called private resources. Only applications within your network should be able to access the private resources. So the question is, inside a VPC, how do you separate public resources from private resources? That's where you would go for VPC subnets. VPC subnets allow you to separate private resources from public resources. The way you do that is by creating a separate subnet for your public resources and a separate subnet for your private resources. You can see that an application which needs to be exposed onto the internet is in the public subnet. However, your database, which should be private, which should not be accessed directly from the internet, it's inside a private subnet. Resources in a public subnet can be accessed from internet. However, resources in a private subnet cannot be accessed from internet. But resources in public subnet can talk to resources in a private subnet. Whenever we create a VPC, the VPC is associated with a specific region. This specific VPC is created in US East 1. Whenever you create a subnet is created in an availability zone. So each subnet has a specific availability zone. For example, US East 1A, US East 1B, or so on and so forth. So if you have the VPC in US East 1, you can create subnets in US East 1A or 1B or 1C or anywhere within that specific VPC. Until now, we talked about the fact that VPC allows you to create your own isolated private network, and inside the VPC, we create subnets so that we can separate public resources from private resources. Now, let's shift our attention to how you can create a private subnet or a public subnet. What is the difference between a public subnet and a private subnet? In a public subnet, communication is allowed from subnet to internet and back from internet to the subnet. So you can access resources in a subnet from the internet, and the subnet resources can also send requests to internet. How does the communication for subnet with the internet happen? The way it happens is through something called an internet gateway. An internet gateway is what enables internet communication for subnets. A public subnet is nothing but a subnet that has a route to an internet gateway. So any subnet that has a route to an internet gateway that has access to internet is what is called a public subnet. When you create a private subnet, you would ensure that that subnet does not have a route to an internet gateway. So a private subnet will not be able to talk to internet because it does not have a route to an internet gateway. So the internet gateway is what sits between the subnet resources and the internet. An internet gateway has a one-to-one mapping with a VPC. Inside the VPC, you will have an internet gateway. In the subnet, if you create a route to the internet gateway, then that becomes a public subnet. There are two formats of IP addresses, IPv4 and IPv6. And internet gateway supports both IPv4 and IPv6. Whenever we create resources inside a subnet, they are assigned private IP addresses. For communication within a subnet, we always make use of private IP addresses. However, if we want to allow communication from internet, we would want to also assign public IP addresses. Your users will be making use of public IP addresses and accessing your resources from the internet. And those public IP addresses are converted to private IP address for the resource by the internet gateway. So the internet gateway is the one which translates private IP addresses to public IP addresses and vice versa, public IP addresses to private IP addresses. In this step, we got a quick introduction to VPC, We also saw why we need subnets, and we also saw how we can create public subnets and private subnets. I'll see you in this step. Let's focus on NAT devices. Let's say you have created a number of EC2 instances inside a private subnet. However, you would want to allow them to download patches from internet. So you'd want to allow outbound communication to internet from your EC2 instance. However, you don't want inbound communication coming in. Let's look at an example. What if you want to allow only outbound traffic to internet from your public subnet while denying all inbound traffic? So you want to deny all inbound traffic, all the incoming traffic into EC2 instance, you'd want to deny it. However, you'd want to allow outbound traffic to internet. Let's say EC2 instance wants to download a patch. You'd want to allow that. That's where you go for NAT devices. Allow outbound internet access for private subnets. This allows instances in a private subnet to download software patches while denying inbound traffic from internet. There are three options you can go for when it comes to NAT devices: NAT instance, NAT gateway, and egress-only internet gateways. If you go for a NAT instance, you are doing all the work. You need to set up an EC2 instance, you need to make use of a specific NAT AMI, and you need to configure everything related to that. You are also responsible for ensuring that it's highly available. And as usual in the cloud, we would want to go with a managed service. And the managed services for NAT devices in AWS are NAT gateway and egress-only internet gateways. The important thing to remember is that NAT gateway only supports IPv4. It only supports IP version 4. So if you want to make use of IP version 6, in that kind of scenario, you have to go with egress-only internet gateways. However, if you want to make use of IPv4, you would go with NAT gateway. With both NAT gateway and egress-only internet gateways, you will have no maintenance because this is a managed service. You'll get high availability and you'll also get high bandwidth. So if you want to allow only outbound traffic to internet from your private subnet, you'd go for NAT devices. And the recommended NAT devices are NAT gateway for IPv4 and egress-only internet gateways for IPv6. I'm sure you're having a wonderful time, and I'll see you in the next. In this step, let's explore VPCs and subnets. I'm right now in the Mumbai region. That's the region which I've been using throughout the course. What I would recommend you to do is to type in VPC, Virtual Private Cloud, and you'll be taken in to this specific page. Over here, you can see that this specific region, Mumbai, has 1 VPCs and 3 subnets. These are created by default for you. These are called the default VPCs and subnets, which are automatically created in the specific region. If I go over and change this region to, let's say, US East North Virginia, I have not used this region at all until now. So this is a fresh region I'm going into. And even here, you can see that there is a VPC which is already created with 6 subnets. You can see that one region had 3 subnets and the other one has 6 subnets. The thing you need to understand is that the number of subnets is equal to the number of availability zones in that specific region. US East 1 is one of the most popular AWS regions and it has 6 availability zones. If I go into the subnets and pick up one of these, and if you scroll down, you'd be seeing that this is in US East 1E. If I uncheck this and select the next one, you'd be able to see that it's in US East 1B. Similar to that, you'd see that all the others are in the other availability zones. This is 1F. And if I select the next one, it would be 1D, 1C, and the last one, you want to guess? It should be an easy guess. It's in 1A. You can see that all of them are created in availability zones A to F. US East 1 is the region, and the availability zones are US East 1A to US East 1F. These are all created by default for you. If you want, you can also create your own VPCs. So you can say, I want to create my own VPC, and you can create your own private VPCs. And once you create a VPC, you can go and create your own subnets as well. I don't really want to worry about creating a VPC. So what I'll do is I'll do a cancel. And what I'll do now is I'll go to internet gateways. You can see that a default internet gateway is created in every VPC, you can see that this internet gateway is attached with this specific VPC. If you click this VPC, you would see that this is the default VPC which is present in this specific region. So there is an internet gateway which is created and which is associated with our VPC. And if you go to the route tables, you'd see that there is one route table which is present. And if you look at the routes in the route table, you can see that there are two routes which are configured in here. The second route which is in here is a specific route. All the addresses inside the VPC, you'd want to target local resources. All other addresses, the requests are being redirected to internet gateway. And this is the same route table that your subnets also are making use of. So if you go to the subnet and if you go to the route table, you'd see that even these subnets are making use of the same route table. You can see the same two rules in that specific subnet routes as well. So you can see that your subnet has a route to the internet gateway. So all the subnets which are present in here are public subnets. If you want, you can go ahead and create your own subnet without a route to the internet gateway, and then it would become a private subnet. But by default, the subnets which are created are all public subnets. What we are seeing is the fact that in our AWS accounts, in each region, there is a VPC created. And inside that VPC, in each availability zone, there are subnets created. And there is also an internet gateway which is created and associated with the VPC. And this internet gateway is also referred to in the default route table that is associated with all the subnets. So all the subnets that are created by default are also public subnets. If you'd want over here, you can also create egress only internet gateway. So you can go ahead, if you want to make use of IPv6 addresses, then you can create a egress only internet gateway in here. You can also create a NAT gateway. If you created a private subnet, and if you'd want outgoing access to internet for the resources which are present inside your subnet, inside your private subnet, then you can even go ahead and create a NAT gateway in here. The NAT gateway is not part of the free tier, so I would not recommend you to go ahead and create a NAT gateway. What I would do now is to do a cancel. In this step, we looked at some of the important features related to VPCs and subnets. I'm sure you're having a wonderful time, and I'll see you in the next step. Most enterprises today are going for hybrid cloud. In this step, let's discuss what is the difference between public, private, and hybrid cloud. And we'll also look at the networking options that AWS provides for setting up hybrid clouds. Let's quickly start with public versus private versus hybrid clouds. What is a public cloud? You host everything in the cloud. You do not need a data center anymore. So all your resources are in the cloud. So you are not putting in any capital expenditure. So you are not investing money ahead of time. All that you are doing is paying for using the resources. When you are making use of public cloud, all the hardware resources are owned by the cloud platform. It might be AWS, Azure, or Google Cloud, but the hardware resources are owned by the cloud platform. All hardware failures and also the security of the data center is now the responsibility of the cloud platform. So when you're going for public cloud, the hardware is owned by the cloud platform and shared between multiple tenants. A tenant is nothing but a customer who rents the infrastructure, you, me, and other enterprises. What is private cloud? When you're making use of a private cloud, you host everything in your data center. This needs capital expenditure. You need to invest money ahead of time. And you'd also need a team to maintain this infrastructure. Obviously, a private cloud delivers higher level of security and privacy. The last option is hybrid cloud. A hybrid cloud is a combination of both public cloud plus private cloud. So you would use public cloud for some workloads and private cloud for others. A good example is connecting an on-premise app to a cloud database. Going hybrid cloud provides you with flexibility. You can either go on-premises or you can go cloud based on a specific requirement. Now, you'd want to connect AWS with on-premises. You'd want to set up a hybrid cloud. What are the options that are present? The first option is AWS Managed VPN. These are tunnels from VPC to on-premises. When you are setting up a AWS Managed VPN, the traffic between AWS and your on-premises goes over the internet. and it is encrypted using IPsec protocol. You would set up a VPN gateway to connect one VPC to the customer network. And you would install a customer gateway in the customer network. If you don't want your traffic to go over internet, you can go with AWS Direct Connect. It's a private, dedicated network connection to on-premises. The great thing about Direct Connect is that it would reduce your internet bandwidth costs. Why? Because this traffic does not go over internet. And it also provides you with consistent network performance. You are making use of a private network, so it provides you with reliable network performance. However, a word of caution. Establishing Direct Connect connection takes a little while, typically about a month. And it is recommended to have a backup DC connection. So it's always recommended to establish a redundant Direct Connect connection for maximum reliability. Another thing to remember is that Direct Connect is a private connection only. The data on it is not encrypted by the network. In this step, we looked at two options to set up hybrid cloud in AWS. AWS Managed VPN and AWS Direct Connect. I'm sure you're having a wonderful time, and I'll see you in the next step. In this step, let's review some of the important things that we learned about VPC or the Virtual Private Cloud. A VPC is a virtual network to protect resources and communication from outside world. The resources and communication between resources inside a virtual private cloud is not visible to other VPCs. A subnet allows you to separate private resources from public resources. An internet gateway is what is the difference between a public subnet and a private subnet. An internet gateway allows a public subnet to talk to internet. A NAT gateway or a egress-only internet gateway allows internet traffic from private subnets. If let's say you have an EC2 instance in a private subnet and you'd want to allow it to download OS patches or some application-related patches, you can set up a NAT gateway if you are making use of IPv4 addresses, or you can set up a egress-only internet gateway if you are making use of IPv6 addresses. The next two services are related to setting up connection from AWS to on-premises. If you want a private dedicated connection from AWS to on-premises, you can go with AWS Direct Connect. If you want a shared encrypted tunnel over internet to on-premises, you can go with AWS VPN. I'm sure you're having a wonderful time, and I'll see you in the next step. Starting this step, let's look at DevOps. If you search for DevOps on Google, you would see a number of complex definitions. I saw some definitions which run into a few pages. I like to keep things really simple. So whenever I think about DevOps, I think about the three elements of great software teams. In my experience, all the great software teams that I've worked with focused on these three elements. Number one is communication. There are a number of sub-teams in your software team. You have a business team, you have a development team which is responsible for build and test. You have operations team which is responsible for maintaining the application in production. Having great communication between all the sub-teams in a software team is essential for building a great software team. In Agile, we brought the business and development team together and we created a Scrum team with representation from both business and development. DevOps takes this to the next level. DevOps also combines the operations team into the mix. So we have the business team, development team, and the operations team all working together in building great software. So DevOps focuses on improving communication between the team by bringing all of them together. Another important thing is quick feedback. There are a lot of steps in developing software. You have requirements, design, coding, testing, deployment to multiple stages, and a lot of other steps. In each of these steps, you'd want to get immediate feedback. The earlier you find something is wrong, the easier it is to fix. So DevOps encourages the use of practices like continuous integration, continuous deployment, continuous delivery, so that you'll be able to find problems fast and you'll be able to fix them faster. The last element of great software teams is automation. Automation not only reduces the effort in doing something, but also makes it predictable. Agile focused on automation testing. Agile focused on improving unit tests, system tests, integration tests, and a lot of things related to that. In DevOps, in addition to automating testing, we also focus on automating infrastructure provisioning your cloud resources. We focus on automating deployments. We also focus on automating your monitoring of your applications. So for me, DevOps is nothing but getting better at the three elements of great software teams. Let's now look at one of the most important practices in DevOps, which is continuous integration, continuous deployment, and continuous delivery. As we discussed earlier, there are a lot of steps in software development. And what we are looking at in here are the steps which are involved from the time you commit something to a version control to the time it is pushed over to production. Once you commit code, you would want to run unit tests, integration tests, you would want to create a deployable package, maybe you would create a Docker image, you'd want to deploy it to a specific environment, you'd want to run the automation tests. If the testing approval comes in, then you'd want to deploy it to the next environment, so on and so forth until you reach production. So as you can see, there are a lot of steps which are involved. And to be able to get quick feedback, we'd want to do these things continuously in small iterations. Continuous integration is all about continuously running your tests and packaging. The first 4 steps in here is what represents continuous integration. So as soon as somebody commits code in, you'd run unit tests, integration tests, and you'd also create a deployable package. Continuous delivery takes it to the next step. In addition to doing these 3 steps, you'd also deploy to an environment, and if possible, you'd want to run a few automated tests as well. So continuous delivery is about continuously deploying to test environments. Continuous deployment takes it to the next level. Can we automatically deploy to production as soon as somebody commits some code in? Typically, most enterprises have some kind of manual approvals before the code is finally deployed to production. The goal of continuous integration, continuous delivery, and continuous deployment is to automate the different steps which are involved in taking the source code live from the time it is committed to source control to the time it goes live in production. So continuous integration, continuous delivery, and continuous deployment enable you to get quick feedback. By doing this continuously in small iterations, if there is a failure, we will know it really early. Let's now look at some of the important CI/CD tools in AWS. AWS Code Commit is a fully featured private Git repository. This is very, very similar to GitHub. AWS Code Pipeline helps you to create your CI/CD pipelines. AWS Code Build helps you to build and test code. You can create your jar files, var files, and you can also create your Docker images using Code Build. Once you build your packages, you would want to deploy them. That's done using Code Deploy. Code Deploy would automate deployments, for example, ECS, Lambda, or EC2 instances. Another important service that is part of CI/CD lifecycle is ECR, or the Elastic Container Registry. Once you create a Docker image or a container image, you'd want to push it somewhere. The service in AWS to store your Docker images or container images is Elastic Container Registry. In this step, we got a high-level introduction of DevOps and CI/CD in AWS. I'm sure you're having a wonderful time, and I'll see you in the next step. In this step, let's focus on another important DevOps practice, which is infrastructure as code. Let's consider an example. I'd want to create a new VPC and a subnet. I would want to provision a Elastic Load Balancer. I would want to create an auto-scaling group with 5 EC2 instances, and I would also want to create a RDS database. I would want to install Python on my EC2 instances. And I would want to create 4 such environments: dev, QA, stage, and production. Doing this manually will take a lot of time, and there is every chance that I make mistakes. How about automating this? That's what is called infrastructure as code. Instead of manually doing all these steps, you'd want to automate the provisioning and configuring of your cloud resources. Infrastructure as code is all about automating provisioning and configuration of your resources. Typically, most of the times we would do infrastructure as code in the cloud. The goal of infrastructure as code is to treat infrastructure the same way as application code. So you would want to track infrastructure changes over a period of time. Typically, all your infrastructure as code scripts and code will be put in version control. And therefore, you can track the changes over a period of time. And by automating everything, you bring repeatability into your infrastructure. Whenever you'd want to make a change, it's very, very easy. Make the change and run a script. Infrastructure as code has a number of advantages. You can automate the deployment of resources in a controlled, predictable way. And you can avoid mistakes that can happen with manual provisioning of resources. Whenever we talk about infrastructure as code, there are two parts to it. One is infrastructure provisioning. That's basically provisioning the resources in the cloud. Provisioning AWS resources, for example, EC2 or Elastic Load Balancer or a database. Now, what are the tools that you can use to do infrastructure provisioning in AWS? The cloud neutral option is Terraform. In Terraform, you can write Terraform templates to provision AWS resources. Another alternative to Terraform is Pulumi. In Pulumi, you can write code in your favorite language. You can write code in, for example, Python, JavaScript, or Java, and you can use code to provision your AWS resources. Now, there are also AWS specific options. AWS CloudFormation is one of the most popular services in AWS to do infrastructure provisioning. When you're using AWS CloudFormation, you're provisioning AWS resources using JSON templates or YAML templates. Another alternative that AWS provides is AWS CDK or the AWS Cloud Development Kit. Similar to Pulumi, even in AWS CDK, you can provision resources by writing code in popular programming languages. You can make use of Python, JavaScript, Java, write code, and provision AWS resources. The difference between Pulumi and AWS CDK is that Pulumi is a cloud neutral tool. However, AWS CDK is a cloud specific tool. It's specific to AWS. If you're focused on provisioning only serverless resources, then AWS has an alternative which is called SAM. This is called Serverless Application Model. So these are the tools that you can use to do infrastructure provisioning in AWS. My preference would always be to go with cloud neutral options, Terraform or Pulumi. But if you're an AWS shop, then any of these options might work for you. So the first part of infrastructure as code is infrastructure provisioning. And the second part is configuration management. If you provision a EC2 instance, you want to install the right software and tools on the EC2 instance. This is called configuration management. There are a number of open source tools for configuration management. Chef, Puppet, Ansible, and SaltStack are some of the popular ones. There is also an AWS service that can help you with configuration management. The service is called OpsWorks. OpsWorks helps you to run Chef and Puppet in AWS. In this step, we looked at what is infrastructure as code, what are the advantages of infrastructure as code. We looked at the two parts of infrastructure as code, infrastructure provisioning and configuration management. And we looked at some of the important tools regarding infrastructure provisioning and configuration management. I'm sure you're having a wonderful time, and I'll see you in the next step. In this step, let's explore AWS CloudFormation. Automate the provisioning of your cloud infrastructure. AWS CloudFormation provides a common language to describe and provision all the infrastructure resources in your environment in a safe, repeatable way. When we are making use of CloudFormation, if you want to provision resources, you need to create a CloudFormation stack. You can create your own template, or you can make use of a sample template to quickly get started. Let's go ahead and create a stack. What I'll do is I'll make use of a sample template. This template can be a JSON or a YAML file, and we would define all the resources that we would want to create in this specific template. What we'll do is we'll make use of a sample template related to WordPress blog. As it says in here, this template would install WordPress with a local MySQL database for storage. So this would create a EC2 instance, install WordPress on it, and it will also create a MySQL database, and it would also establish a connection between the EC2 instance and MySQL database. All the configuration related to that is present in this S3 bucket. So this is a sample template which is present in here. If you want, you can actually copy this URL, go to a new tab and press enter. And you'd be able to see the entire CloudFormation script which is present in here. You don't really need to understand everything which is present in here. At a high level, the way you can think about it is this is some kind of template where all the resources are defined. And if you want to create resources in an environment, all that you need is to run CloudFormation using this specific template. Let's go back to Management Console, and I would say next in here. On the next page, we can configure a stack name, my first CloudFormation stack. I'll take the defaults for DB name. Make sure that you configure a DB password and a DB root password. You can also create a admin account name. I'll call this admin. Next, you can choose the instance type. I would choose the instance type as T2 micro, and I would choose a existing key that we have earlier created when we were playing with EC2 instances. And I would want to allow access from everywhere to this WordPress blog. Let's go ahead and say next right now. On next page, I would take defaults for all the options, and I would say next. We are all set to create our stack. Let's go ahead and say create stack. In this step, we initiated the creation of our first CloudFormation stack. The creation of this stack will take a little while. I would recommend taking a break, and I'll see you in the next step. In the last step, we kickstarted the creation of our CloudFormation stack. It took about 15 minutes, at the end of which I saw that the creation of our stack is complete. If you go to Outputs, you'd be able to see the URL of the site which we have set up. So the website URL of the site that we have set up is in here. So let's click this. And over here, we can start the configuration of WordPress. So my most amazing website. You can also configure a username and a password in here. This would be the WordPress admin user ID and password. So I'll say admin, and I'll configure my own password. You can also configure your email, and you can go ahead and install WordPress. WordPress has been installed. Thank you and enjoy. Let's log into WordPress. I'll enter my username, my password, and I would say login. So we are now seeing the admin dashboard for WordPress. This is where you can start customizing your website. If you want to see the current state of our site, I can say visit site. So I can go over in here, go to visit site, right click, open link in new tab. And you can see that right now we just have one post in here. This is a sample page which is present. If I want, I can go ahead and add in more posts. I'll go to posts and I can say add new. And I would add a title. I am having a wonderful time learning AWS. And you can type the content of the page in here. I am having a great time learning AWS. And I'll say publish. Let's go ahead and publish again. Okay, our post is now published. If I go to the website and refresh, okay, you can see the post in here. If you click it, you can see it on its own page as well. So what we are doing in here is we are playing around with WordPress. This is WordPress admin, where you can create your posts, and this is a website where your users can come and see what's on your website. This WordPress website is running on an EC2 instance. If I go over to EC2, you'd see that there is one instance which is running right now. This is the instance which is created by our CloudFormation stack. So this is where our WordPress site is running in from. Now what I'll do is I'll go back to CloudFormation. So go to CloudFormation. And if I click this stack which is present in here and go to resources, you can also look at the different resources which were created as part of our stack. You can see that we have created a security group and a web server, a EC2 instance as part of our stack. If you want to make any updates to your stack, you can also use update feature. Once you've played with it sufficiently, you can go ahead and delete your CloudFormation stack. So I'd go ahead and delete this stack, delete stack. In this step, we saw how easy it is to make use of CloudFormation. You define your resources in a CloudFormation template. And once you define your resources in a CloudFormation template, you can easily use it and create your resources in the cloud. Over here, we are creating a couple of resources, but if you look at typical applications in the cloud, they might make use of 10, 15, 20 resources. So you can configure all those resources in your CloudFormation template, and you can automate the provisioning of them using CloudFormation. I'm sure you're having a wonderful time, and I'll see you in the next step. In this step, let's look at a couple more services related to DevOps. We'll be looking at monitoring and debugging services in AWS. We'll be looking at Amazon CloudWatch and X-Ray. Let's start with CloudWatch. CloudWatch helps you to monitor resources and applications in AWS. CloudWatch provides you with a number of features. The first one is CloudWatch Metrics. It provides you with metrics for your applications and resources. If you want to find metrics around your EC2 instances, if you want to find metrics around your RDS databases, or if you want to look at metrics related to DynamoDB, that's where you would go for CloudWatch Metrics. The next service which is part of CloudWatch is CloudWatch Logs. If you want to look at system logs, application logs, or custom log files related to your applications or AWS services, that's where you'd go for CloudWatch Logs. Whenever you have a problem, you can go to CloudWatch Logs, look at the logs, and solve your problems. So CloudWatch Logs is the centralized service to store all your logs in AWS. The next service that is part of CloudWatch is CloudWatch Alarms. In CloudWatch, you have a number of metrics. How about creating alarms based on these metrics? Let's say the CPU utilization went above 90%. I want to alert my operations team. Those are the kinds of alarms that I can create using CloudWatch Alarms. So with CloudWatch Alarms, you can create alarms based on CloudWatch metrics and take immediate action. You can send an email, or you can create a new EC2 instance when CPU utilization goes over 80%, for example. Another important service in CloudWatch is CloudWatch Events. CloudWatch Events allows you to take immediate actions based on events on AWS resources. For example, call a AWS Lambda function when an EC2 instance starts. So based on any of the events which occurs on AWS resources, on EC2 instance, for example, a start event, a stop event, a terminate event, or any of the other actions that you can do on an EC2 instance, you can react to them and you can take immediate actions. For example, call a AWS Lambda functions. CloudWatch Events is now called Event Bridge. Another example is you would want to notify an Amazon SNS topic when an auto-scaling event happens. So you can create a CloudWatch event, listening on the auto-scaling event, and notifying a Amazon SNS topic when it happens. So CloudWatch has metrics, logs, alarms, and events. Now, if you want to debug problems, that's when you'd go for X-Ray. It helps you to analyze and debug problems in your applications. When you're going for a microservice architecture, a request might go through n number of microservices. A lot of AWS services might also be involved. X-Ray helps you to trace your request across all these resources and applications. So you can trace your request across microservices and AWS resources. So if you're debugging a specific request, you can see what all services were involved, what all microservices were involved, and that can help you to debug the problem easily. In this step, we looked at Amazon CloudWatch and X-Ray. I'll see you in the next step. In this step, let's look at CloudWatch, monitor resources and applications. Earlier, we played with a number of compute services, a number of database services, and a lot of other services. Every service out there in AWS generates metrics, and all of them are tracked by CloudWatch. As we discussed earlier, CloudWatch provides you with a lot of features. Metrics, logs, alarms, events, and a lot of others. Let's start with metrics. So you can go ahead and say all metrics. And this is where you can see all the metrics that are coming in from different kinds of applications. What I have is a DynamoDB table. So let's go ahead and pick up DynamoDB in here as an example. And let's look at a few table metrics. We have a table name called to do. So let's pick up all the metrics related to that. And you can see them in here. You can see the graph around all the metrics related to DynamoDB in here. If you want, you can alter the timeline. So you can look at more detail by going out to 1 hour. And you can see all the details around the different metrics related to DynamoDB. Similar to that, if you have any other resources that are created in AWS, you can go in here and you can look at all the details related to those metrics. And you can also change the time period for which you don't want to look at the metrics for. If I go back to all, you'd see that almost every service in AWS would be listed in here. So DynamoDB, EBS, EC2, ECS, Elastic Beanstalk, Lambda, whichever service you'd name, you'd see the metrics for that in CloudWatch. CloudWatch logs enables you to see all the logs. So if I go over to log groups, you'd see 2 log groups in there right now. These log groups were created when we created the Lambda function and when we created the ECS service, Elastic Container Service. You can go into a log group and look at all the logs inside that. So inside the log group, you have multiple log streams. We invoked the Lambda function a number of times, and for each of those invocations, there was a log stream created. You can go in here and look at the logs for that specific invocation. You can also create alarms in CloudWatch. Let's go ahead and click all alarms. You can go in and say, I want to create an alarm. I want to create an alarm based on specific metrics. So I'll go in and say, I want to select a metric. I'll go in and say, I want to select a metric. Let's say I would want to pick up a metric from DynamoDB table that I have. DynamoDB and search. You can see all the DynamoDB metrics in here. So let's pick up DynamoDB table metrics. Let's create a metric around consumed read capacity units. Let's select this. And if I would want, I can go ahead and create the conditions under which I would want the alarm. So let's say if the consumed read capacity units is greater than certain threshold. So let's say if the consumed read capacity units is greater than 10, I'm just taking numbers out of random in here. So if it's greater than 10, I'd want to get an alarm. So you can come in here and you can say, I'd want to get a notification to this specific email address. So this is how you can make use of CloudWatch alarms. In CloudWatch alarms, you can look at metrics, you can set a threshold, and you can get a notification based on it. The notification can be an email notification, or you can send a notification to SNS topic. So SNS is the simple notification service. SNS uses something called a publish subscribe pattern. You can publish alarms to SNS from here, and there can be subscribers who can be listening on that alarm in SNS. So you can, for example, call a Lambda function or do a wide variety of things based on the notifications that are coming in from the alarm. So let's go back to CloudWatch. The next thing that we can also do in CloudWatch is to configure events. Alarms are based on a certain metric. When something goes beyond a certain threshold, you'd want to trigger an alarm. Events are different things that are happening in AWS. For example, a EC2 instance is started or stopped. That's an event. So even based on the events which are happening in AWS, you can trigger actions. That's what you can do in events. In events, you can create rules. So you can go in and say rules. Right now, the CloudWatch events is being renamed. CloudWatch events is being renamed to Event Bridge. As it says in here, Amazon Event Bridge builds upon and extends CloudWatch events. What we'll do is we'll go to Amazon Event Bridge. Let's click that. Go over to Amazon Event Bridge. In Amazon Event Bridge, you can create rules. A rule watches for specific types of events. When a matching event occurs, the event is routed to the targets associated with the rule. So let's go ahead and create a rule. You can give the rule a name, my first event bridge rule. You can run the rule based on an event, or you can even schedule it. For now, let's run it based on a specific event. Let's click next. I don't want to listen to AWS events. And at the bottom, you can configure the event pattern. Let's say I would want to listen to all the events which are happening in EC2. So I can go in and say EC2. I'd want to listen on all events. And I can say next. And on the next page, we can select the target. You can select what should happen when that event happens. I can say I would want to call a Lambda function, for example. I would want to call a specific Lambda function, and you can, for example, configure a Lambda function that you would want to invoke. For example, the my.node.js Lambda function that we have created. So whenever that specific event happens, the Lambda function would be invoked. So what we are looking at is that if you have events that you would want to listen on and you would want to take actions based on those events, in those kind of situations, you can go for Amazon Event Bridge. Let's go back to CloudWatch. And the last thing that we would want to look at is X-Ray. We looked at X-Ray a little bit when we talked about AWS Lambda as well. Right now, you can see that AWS is making X-Ray a sub-menu under CloudWatch. Actually, X-Ray is a service on its own, but most of the times, X-Ray and CloudWatch go together. And that's why AWS is making X-Ray a sub-menu under CloudWatch. Let's go ahead and select Service Map. Right now, you do not see a lot of information in here. However, if I go to a larger time period, for example, 6 hours, you can see a trace of a Lambda function invocation which happened earlier. Whenever you have a microservices architecture or things like that, you'd want to trace requests across microservices or across AWS services. That's where X-Ray is really, really useful. If your call goes through multiple Lambda function and you'd want to be able to debug it, you can see all the Lambda functions that your request went through in X-Ray. So CloudWatch and X-Ray is a great combination if you want to debug problems. CloudWatch provides you with a number of metrics. CloudWatch provides you with logs, and you can also configure alarms and events. X-Ray provides you with all tracing information. I'm sure you're having a wonderful time, and I'll see you in the next step. In this step, let's explore a few scenarios related to DevOps in AWS. Actually, this is a generic thing, not really specific to AWS. What is the difference between continuous delivery and continuous deployment? Continuous delivery is continuous deployment to test environments. Let's say a piece of code is committed to version control. What you do is you do your continuous integration, check that your code is compiling, run your tests, and after that, you would actually deploy it to a test environment, maybe a QA environment, maybe a staging environment. That's what continuous delivery is all about. In continuous deployment, you would take an additional step. You would have continuous deployments to production. Some enterprises might also have a mandatory manual approval before code is put out to production. Next, what are popular tools for automating infrastructure provisioning in AWS? Earlier, we talked about IaaS has two parts. One is to provision infrastructure, and the other one is to configure it. So we are talking about infrastructure provisioning and configuration management. And in AWS, if you want to do infrastructure provisioning, you have a number of options. There are AWS specific options like AWS CloudFormation, AWS CDK, AWS SAM, and you also have the cloud neutral options like Terraform and Pulumi. My favorite among these is the cloud neutral option Terraform. However, if you want to do infrastructure programming in your favorite programming language, then you can think about Pulumi as well. Similar option is also provided by AWS CDK. You can write code in multiple programming languages to automate your infrastructure provisioning. If you are provisioning serverless resources, you can also think about AWS SAM, Serverless Application Model. Next, recommended managed service for configuration management in AWS. Configuration management is all about installing the right software on the provisioned resources. For example, installing your application runtime or applying a OS patch or applying a patch to Python which is running on an EC2 instance. All these fall under configuration management. And the recommended managed service for configuration management in AWS is OpsWorks. Chef and Puppet are open source tools which can be used for configuration management. And OpsWorks is an AWS managed service to make use of Chef and Puppet in AWS. Which managed service can be used to trace your request across microservices and different AWS services. The service which we are talking about in here is Amazon X-Ray. when you have any applications or microservices that are deployed in AWS, a request to one of these microservices can involve multiple microservices and multiple AWS services. You can trace your request across these by making use of Amazon X-Ray. How can you troubleshoot problems using system, application, and custom log files in AWS? What is the service you would be making use of? Yep, you are right. It's CloudWatch logs. CloudWatch logs provides you centralized log management in AWS. All logs from AWS services and your applications can be sent out to CloudWatch logs, and you can use CloudWatch logs to troubleshoot your issues. In this step, we looked at some of the important scenarios related to DevOps in AWS. I'm sure you're having a wonderful time, and I'll see you in the next step. In this step, let's look at some of the big data and streaming services in AWS. Let's get a quick introduction to big data right now. Whenever we talk about big data, we are talking about 3 V's: volume, variety, and velocity. Right now, we have huge volumes of data. So we are talking about terabytes to petabytes to exabytes of data. So huge volumes, huge variety as well. Earlier, we learned about structured data, semi-structured data, and unstructured data. So we have huge volumes of all varieties of data. And the data is coming in different velocities. The data might be coming in batch, or it might be streamed in as well. These are the 3 V's typically used with big data. And whenever we talk about big data, there are 2 different terminologies which are made use of: data warehouse and data lake. What is the difference between a data warehouse and a data lake? A data warehouse has petabytes of storage and also compute typically. In a data warehouse, data is stored in a format ready for a specific analysis. So you have processed data, huge volumes of it, ready for analysis, and you can execute queries and get information or intelligence from it. That's what data warehouses allow you to do. One of the popular data warehouses a few years back is Teradata. And now most of the data warehousing is done in the cloud. In Google Cloud, the data warehousing service is BigQuery. In AWS, it's Redshift. And in Azure, it's Azure Synapse Analytics. So when we are talking about BigQuery or Redshift or Synapse Analytics, what they allow you to do is to store data in structured format. You can store data in tables, and you can define relationships between your tables, and you can use queries, or very, very complex queries, to analyze your data. The other alternative is data lake. In data lake, we retain all the raw data, typically in compressed format. The key difference between data warehouse and data lake is that in data warehouse, we store the data in a format which is ready for specific analysis. So when we go for a data warehouse, we know exactly what analysis we would want to do. But we would go for a data lake to retain all the data. We don't know how we will use this data at a later point in time. So we would want to retain all the data. And typically, the object storage service in the cloud is what is used as a data lake. In AWS, the object storage service is Amazon S3. In Google Cloud, it's Google Cloud Storage. In Azure, it's Azure Data Lake Storage Gen 2. So these are the object storage services in the specific clouds, and these are typically used to store all the data in a data lake. The great thing about data lake is that it provides you with flexibility. At a later point in time, if you find that some data is important, you would have all the data in here. So it provides you with flexibility while saving cost. Data lake does not use expensive hardware. So storing data in a data lake typically is cheaper than storing data in a data warehouse. Once you store the data in a data lake, you can do ad hoc analysis on demand. There are multiple services which are present in each of the cloud platforms, which can read directly from the data lake. Azure Synapse Analytics, BigQuery, Redshift Spectrum, Amazon Athena. These can directly read from your object storage services. So you can execute queries against the data which is directly stored in a data lake. So what we are talking about are the 2 ways you can store huge volumes of data in the cloud. The 2 approaches are typically data warehouses and data lakes. In data warehouses, you store data which is ready for a specific analysis. In data lake, you store all the data so that you have the flexibility to query whatever you'd want in the future. Typically, querying from a data warehouse will be much faster than querying from a data lake. Until now, we looked at big data, we looked at data warehouse and data lake. Big data, data warehouse, data lake, these are all technical terms. And all these things come under the umbrella of data analytics. The goal of data analytics is to convert raw data into intelligence. You'd want to uncover trends and discover meaningful information. You'd want to find new opportunities and identify weaknesses. You'd want to increase the efficiency and improve customer satisfaction. You want your data to help you make right business decisions. You might be getting your raw data from any number of different sources. Customer purchases, bank transactions, stock prices, weather data, monitoring devices. The goal of data analytics is to use this raw data and get intelligence from it. You'd want to decide when to organize future sales based on past customer behavior. You'd want faster diagnosis and treatment using patient history. Now, how can you do data analytics? Let's look at the workflow. The first step is data ingestion. You want to capture raw data. The data might be coming in from various sources. It might be stream data or it might be data coming in as a batch. So you have weather data, sales records, and user reactions on websites. So a lot of sources from which you might be getting data from. Once you have the data ingested, you'd want to process the data. The data in its raw form might not be suitable for querying. You might want to clean the data. You might want to remove duplicates. You might want to filter data. There might be outliers or anomalies which you'd want to remove. And you might also want to aggregate data. Instead of acting on data at a minor level, you might want to aggregate data at a day level or a week level and then look at it. You might also need to transform the data from one format to another format. Once you process the data, you can store the data to a data warehouse or a data lake. Once the data is stored, you can query from it, you can run queries to analyze the data, and you can also create visualizations around your data. These visualizations can make it easier to understand the data and make better decisions. So you can create dashboards, charts, reports, and identify trends. Visualization helps businesses spot trends, outliers, and hidden patterns in data. So what we are looking at is the fact that having raw data is not useful at all. What we want is to get intelligence from data. And to be able to get intelligence from data, we need to have multiple steps. We ingest data, we process it. After that, we would store it into a data warehouse or data lake. This is where your big data services come into picture. And once you have data stored, you can query it or you can have visualizations around it. Let's now look at some of the important services in AWS related to data analytics. The first one is Amazon Kinesis. If you have real-time streaming data coming in that kind of a scenario, you can make use of Amazon Kinesis. Kinesis can help you to process real-time streams, and also if you want to ingest the data to our data store, you can also do that using Kinesis. Another service in AWS that can be used to process real-time streams is MSK. This is fully managed service in AWS for Apache Kafka. We already talked about the data warehouse in AWS, which is Amazon Redshift. If you are making use of Hadoop or if you are making use of Spark, in that kind of scenario, you can make use of EMR, which is the managed Hadoop framework in AWS. Another important analytics service in AWS is AWS Glue. It is a fully managed ETL, extract, transform, load service in AWS. Typically, you might have a data in one format. You might want to transform it and load it into another data source. That's where you can go for AWS Glue. Earlier, we talked about the fact that the recommended data lake storage in AWS is Amazon S3. If you want to set up a data lake very easily in AWS, you can make use of AWS Lake Formation. This helps you to easily set up a secure data lake in AWS. You can query data directly in S3 using SQL by using Athena. If you have data in S3 or if you have data in Redshift, you can use QuickSight to create dashboards. If you want visualization, if you want to look at business analytics, you can make use of QuickSight. Let's look at a couple of sample end-to-end architectures. For example, let's say you have streaming data which is coming in and you'd want to be able to query it in a serverless way. You can use Kinesis to store the stream to S3. And you can query directly from S3 using Athena. Another architecture we'll be looking at is batch architecture. Let's say you have some data in multiple databases. What you can do is you can use AWS Glue to load the data into the data warehouse. For example, Redshift. In this specific architecture, we are making use of Redshift. Once the data is in Redshift, you can visualize it using QuickSight. In this step, we got a high-level overview of the different AWS analytics services. I'm sure you're having a wonderful time, and I'll see you in the next step. Welcome back. In this step, let's look at some of the machine learning services in AWS. Before that, let's get a quick introduction to what is machine learning. Artificial intelligence is all around you. Self-driving cars, spam filters for your emails, email classification that is done by Gmail, fraud detection for all your banking transactions. These are all done using artificial intelligence. What is artificial intelligence? Artificial intelligence is the theory and development of computer systems that are able to perform tasks normally requiring human intelligence. For example, visual perception, understanding what's in an image, understanding what's in a video, speech recognition, hearing and understanding the language, decision making, and translation between languages. So it's basically computer systems that are able to perform tasks that need human intelligence. That's what AI is all about. And there are two types of AI. One is called the strong AI or the general AI, and the other one is called the narrow AI or the weak AI. The goal of strong AI is to create machines which have the same intelligence as that of a human. Intelligence of a machine is equal to intelligence of human. A machine that can solve problems, learn, and plan for the future. A machine which is an expert at everything, including playing sports, games. A machine which can learn like a child and build on its own experiences. The thing is, we are really far, far away from achieving this. The current estimates for achieving strong AI are at least a few decades away. All the artificial intelligence that we are seeing in action right now is narrow AI or weak AI. This focuses on a specific task. For example, self-driving cars or virtual assistants. And machine learning is one of the approaches for narrow AI where we learn from data, where we learn from examples. So there are two types of AI, strong AI and narrow AI. Strong AI is long way away. And one of the approaches to achieve narrow AI, which is to focus on a specific task, is machine learning. Machine learning focuses on learning from data, learning from examples. Let's quickly compare machine learning with traditional programming. Traditional programming is based on rules. You'd write a lot of conditions, you'll write a lot of code saying if this, then do that. You'd write a lot of logic to decide a lot of things. For example, if you want to predict the price of a home, you design an algorithm taking a lot of factors into consideration. You take location of the house, home size, age, condition, market, what is the status of economy. You take all those things into consideration and you might design an algorithm. You'd write a lot of rules to decide the price of the home. However, machine learning takes a different approach. Machine learning tries and learns from examples. So you'd give millions of examples to a machine learning program, and this would create a model, and you would use the model to make predictions. So if you want to predict the price of a home using machine learning, you need a lot of historical data, and you would create a model using the data, and you will use the model to do predictions for your house prices. The challenge with machine learning is that you'd need huge number of examples. There is a lot of data that you would need. Another challenge is the availability of skilled personnel. There are not sufficient number of developers who are proficient with machine learning. The third challenge is complexity in implementing ML ops. Updating your model, managing the model over a period of time, and making sure that it is working properly. All that is very, very challenging. There are a lot of steps which are involved in doing that. So machine learning is all about learning from examples. Instead of writing a lot of rules like traditional programming, we would try and learn from data, and we would create a model based on the data, and we will use the model to predict. And there are a lot of challenges with respect to machine learning. And that's why there are multiple approaches to doing machine learning in AWS. AWS provides options for even people who don't know machine learning to be able to perform some of the machine learning tasks. Let's look at the 3 approaches in which you can make use of machine learning in AWS. Number 1 is use pre-trained models. There are models which are already created by AWS. They are exposed as an API, and you can use these models to get intelligence from your text, from your images, from audio and video. Examples are Amazon Comprehend, Amazon Recognition. Amazon Comprehend helps you to get intelligence from text files. Amazon Recognition helps you to get intelligence from audio and video. These are pre-trained models. They are available as APIs. You can go and directly use them. The other approach is to build simple models. You might have some programming experience, but you might not have all the experience that a typical data scientist has. You might not have the right experience to choose a machine learning algorithm. In those kind of situations, AWS provides a service called AWS SageMaker AutoML, Automated ML. All that you need to provide for this is the data, and AutoML can create variety of models, test which one of them is working best for you, and set you up with that specific model. The last approach is to build very, very complex models. This is where you have a data scientist and a large team, and this helps you to build your own machine learning models in your own machine learning frameworks from zero. And the service to be able to do that is Amazon SageMaker. So as you can see, there are 3 approaches to use machine learning in AWS. Making use of pre-trained models which are available as APIs in AWS. The second approach is to make use of Amazon SageMaker. If your team has experience with machine learning and you have data scientists and experienced people in the team, you can go and build complex models using Amazon SageMaker. Or you can make use of the AutoML feature in SageMaker, where it can directly generate the models based on the data, and it can even evaluate the models and help you choose the right model. Let's look at a few more details about these 3 approaches. Let's look at a few examples of pre-trained models in AWS. Amazon Comprehend. This helps you to analyze unstructured text. For example, on my Udemy course, there are a lot of reviews. I would want to look at a review and find out if it's positive sentiment or negative sentiment. I can use Amazon Comprehend to do that. It will be able to look at the review and it will be able to tell, okay, this is a positive review, this is a negative review. So it can analyze text and give you intelligence from it. Amazon Recognition can search and analyze images and videos. It can look at an image and identify a few tags for that specific image or few labels for that specific image. It will be able to identify different objects that are present in there. It can also do the same thing for videos as well. Amazon Transcribe can do speech recognition. From audio, it can generate text. Amazon Poly is the opposite. It can turn text into lifelike speech. Amazon Translate can translate from one language into another language. Amazon Personalize helps you to add real-time recommendations to your application. You can feed information about your users to Amazon Personalize, and it would give you the recommendation, the product to recommend to your user. Amazon Fraud Detector helps you to detect online fraud faster using machine learning. You can pass in all the transactions to Amazon Fraud Detector and it can detect online fraud. These are some of the examples of pre-trained models in AWS. You don't need any machine learning experience to be using these models. The other approach is to create your own models. There are a lot of steps that are involved in creating your model. Number 1 is to obtain the data. Once you obtain the data, huge volumes of data, you need to clean the data. Make sure that every row of data is good. And then you need to do something called feature engineering. You need to identify what is the input and what is the output. The input to a machine learning model is called features and the output is called a label. For example, if I'm trying to predict a house price, the label is the house price. The features are all the inputs, maybe the location, maybe the size of the home. All those can become features. So you need to do feature engineering. The 4th step is to create a model using the dataset and choosing the right machine learning algorithm. To be able to choose the right machine learning algorithm for a dataset, you need to have a lot of experience with machine learning. Once you create a model, you need to evaluate the accuracy of the model. If the accuracy does not meet the standards, then you need to again retry and do this cycle again and again until you have a model which meets your accuracy needs. Once you have a model, you can deploy the model for use in production. Another important thing to remember is that it's not a one-time process. You need to keep updating the model over a period of time. If, let's say, the data used to create the model has changed, in that kind of situation, you need to recreate the model again. So creating machine learning model and deploying them is really, really complex. And the way you can do that in AWS is through a service called Amazon SageMaker. It simplifies the creation of your models. It helps you to manage data. It helps you to manage your machine learning code. It helps you to manage the compute. Where do you want to run the machine learning code, EC2 instance or wherever you want to run them. And it also helps you to manage your machine learning models. It helps you to prepare data. It helps you to train models. It helps you to publish and deploy your models and also to monitor models. So you can do training, validation, and deployment. All these for machine learning models can be done by using Amazon SageMaker. At a high level, there are a couple of options to create models. One is AutoML. AutoML helps you to build custom models with minimum ML expertise. When you're using AutoML, all that you need to do is to provide SageMaker with the data. So you would say this is the data and you would identify the inputs and the outputs. Amazon SageMaker would do the training. It would try and create different types of models. It will evaluate the model. It will check if the model has good accuracy. And it would provide a summary report for you. From the evaluation report, you can choose which model you would want to make use of. So if your team has minimum expertise with machine learning, you can go for AutoML. However, if you have data scientists in your team, then you can completely build your own models. There are a wide variety of machine learning frameworks like TensorFlow, PyTorch. You can use them. You can create your own models. You can create your own workflows. And you can create your own pipelines using Amazon SageMaker. In this step, we talked about what is machine learning, and we looked at the 3 approaches to machine learning which are possible in AWS. You can either use the pre-trained models which are available in AWS, or you can use SageMaker in either of the modes. Either you can use AutoML to simplify the creation of models, or if your team has expertise in machine learning, then you can make use of the machine learning frameworks to create your own models. The goal of this video was not to make you an expert on machine learning, but just to give you a high-level overview of the different approaches to machine learning. Machine learning is an evolving field, and I think it's very, very important for everybody to have some knowledge, a high-level overview of machine learning. I'm sure you're having a wonderful time, and I'll see you in the next step. In this step, let's look at some of the machine learning services in AWS. Let's start with Amazon Comprehend. Analyze unstructured text. Let's go in there. As it says in here, Amazon Comprehend provides natural language processing and text analytics. It is an NLP service that uses machine learning to find insights and relationships in text. Let's try and launch Amazon Comprehend. What we'll do is real-time analysis. There's a sample text which is present in here. You can see that based on this sample text, Comprehend is generating a lot of information. Entities, key phrases, language. If there is any personally identifiable information, it also understands the sentiment, and it can give a little bit of details around the language syntax as well. Instead of using the sample text from here, what I'll do is I'll pick up one of the reviews in AWS Certified Cloud Practitioner course, and I'll use that to test Amazon Comprehend. Let's go ahead and select one of the reviews which is present in here and analyze the sentiment on that. So let's go ahead and put the text in here in input text, and let's say analyze. So you can see that the entities in here are identified. So you can see Ranga is identified as an organization, and you can see that second course is a quantity, and you can see the confidence level in identifying that as well. You can also go to key phrases and look at the key phrases. So GCP Cloud Course is a key phrase. My second course is a key phrase. The certification exam is a key phrase. And it also can identify the language for you. It says English with 0.98 confidence, 98% confidence. And you can also see if there is any personally identifiable information in there. You can see that there is no personally identifiable information in there. You can go in and also analyze the sentiment. It says the sentiment is positive. If you read the review, it has very, very positive sentiment. And it says it's positive with 99% confidence. So this is what you can do using Amazon Comprehend. You can take a piece of text and you can analyze if it's positive or not. What are the different entities which are present in there? What are the key phrases which are present in there? What language is the text written in? And is there any personally identifiable information in that specific piece of text? So this is all the analysis that Amazon Comprehend can do for you. Next, let's go to recognition. REK. It's not REC, it's REK. So Amazon Recognition, REK, search and analyze images. Let's go over there. Deep learning based visual analysis service. You can search, verify and organize millions of images and videos. If you want to look at images, if you want to look at videos and identify objects which are present in there, or if you'd want to generate labels based on them, that's when you'd go for Amazon Recognition. Let's go ahead and try a demo. You can see that Amazon Recognition is looking at this specific image and generating all these labels. You can see that it is 98.8% confident that there is a car, there is an automobile, there is a vehicle, that there is a person in here, and you can see a lot of other details in here. So you can see a lot of other labels that are identified for this specific thing, that there is a building in this specific picture. The picture is taken most probably in some city, and each of these is associated with a confidence level as well. If you pick up another image which is present in here, let's select this image which is present in here. It analyzes and says this is a city with 99% confidence and there are buildings. And if you go further, you'll be able to see that there is water in the picture and the confidence level is 92%. If you want, you can also upload your own image and you can analyze that specific image. As you can see in here, if you have images to process or videos to process and if you want to identify objects in there, that's when you'd go for Amazon Recognition. Let's look at another demo. Let's do celebrity recognition. You can see that based on this image, Amazon Recognition is able to recognize that the person in the image is Jeff Bezos. And the confidence level you can see is pretty high, 99.7%. And if I select the second image which is present in here, this is Andy Jassy, the CEO of Amazon. You can also use Amazon Recognition to do face comparisons. You can compare two faces and see if they are the same. You can see that this is saying similarity is 99.9%. You can also find text in a specific image. In this image, what's the text that is present? And there are several other demos which are present in here. I would recommend you to spend some time looking at all these demos to understand what are all the features that Amazon Recognition provides you with. The next service we'll be looking at is Poly, P-O-L-L-Y. Turn text into lifelike speech. So let's go to Amazon Poly. And I would say try Poly. You can type whatever you'd want in here. For example, I'll paste in the review that we have copied earlier. And you can click listen, and you can listen.
I have already taken GCP Cloud course from Ranga, and this is my second course from in 28 minutes. Concepts are well explained from basic to the level on how to...
The speakers were a little away from the mic. I'm not sure what you have heard, but what it's doing is to convert the input text into voice. You also have flexibility in choosing which voice you'd want to make use of. There are also a number of other machine learning services. For example, Translate. This provides you with powerful neural machine translation. So you can translate the text from one language to another language. What we are looking in this specific step are some of the machine learning APIs that are provided by AWS. I'm sure you're having a wonderful time, and I'll see you in the next step. In this step, let's look at a few scenarios related to machine learning fundamentals. Number one, categorize. Building a computer system as intelligent as a human, an expert at everything, an expert at playing all sports and games. What type of AI are we talking about? We are talking about strong AI. Next, building a computer system that focuses on specific tasks. For example, self-driving cars, virtual assistants, or detecting objects from images. This is where we are talking about weak AI or narrow AI. And this is where all the typical machine learning solutions focus on. Category of AI that focuses on learning from data, learning from examples. What do we call it? We call it machine learning. Which AWS service helps you to analyze if user reviews are positive? So you have a website where users are posting reviews and you'd want to automatically determine if a review is positive or negative. That's where you can go for Amazon Comprehend. Which AWS service helps you to identify objects in an image? So you have an image and you'd want to identify objects in it and you'd want to probably label the image. That's where you can go for Amazon Recognition. Which AWS services help you to build simple models without needing data scientists or AI and ML skills? Let's say you have your own data and you'd want to use it to create a simple model. However, you don't have any experience with machine learning frameworks or you don't have any data scientists on the team. That's where you can make use of Amazon SageMaker, Autopilot, AutoML feature. Which AWS service helps you to build complex ML models? If you have data scientists and if you'd want to make use of machine learning algorithms and build complex machine learning models, that's when you'd go for Amazon SageMaker. In this step, we talked about some of the scenarios related to machine learning fundamentals. I'm sure you're having a wonderful time, and I'll see you in the next step. Almost every enterprise out there is undergoing digital transformation. In this step, let's understand what is digital transformation and also understand the role cloud can play in digital transformations. What has changed in the last decade? There are a lot of things that have changed in the last decade or so. Number one, how consumers make their purchase decisions. Today, I make most of my purchase decisions based on feedback from my friends on social media. How we do things also changed drastically. Earlier, I needed a laptop or a computer to do most of my transactions. Today, I do 99% of my transactions on my mobile phone. Another thing which changed drastically is the amount of data that we have access to today. We are in the big data world. We are talking about petabytes, exabytes, and huge volumes of data. Once we have that data, we would want to get intelligence from that data. We would want to get insights from data. And the process of getting intelligence from data has evolved a lot as well. Artificial intelligence and machine learning have taken giant leaps in the last decade. The other thing which has drastically changed is the amount of access startups have to technology at scale. Today, a startup in India can deploy an application to multiple parts of the world at a click of a button. That is made possible by the cloud. So the major changes of the last decade or so are social, mobile, big data or analytics, and the cloud. Because of these changes, even startups today have the power to disrupt large enterprises. And therefore, enterprises have to adapt. What are the things that enterprises can do to adapt? Number one, they can provide awesome omni-channel customer experiences across social media, across platforms. They can provide great customer experiences. The next thing they can do is to get intelligence from data, make use of big data, AI, ML, and get intelligence from the data that they have. This would help them to personalize consumer offerings. For example, Amazon knows what I typically purchase. So they can personalize the Amazon website for me based on the intelligence that they are getting from the data that they have. Another important thing enterprises need to do is to enable themselves to make changes faster. Instead of thinking in the traditional data center, software development lifecycle, manual IT ops way, they should start thinking in cloud, containers, DevOps, and automation route. And all these changes that enterprises need to make are part of something called digital transformation. Like most of the things in IT, we don't really have a standard definition for digital transformation. This is a definition that I like. Using modern technologies to create or modify business processes and customer experiences by innovating with technology and team culture. So most important thing is it's not just adapting new technology, but it's also about using the technology to create new business processes or modify existing business processes and provide better customer experiences. And digital transformation also needs a change in the team culture. A very, very important thing about digital transformation is to focus on why and not how. The important thing enterprises need to first decide is why do they want to do digital transformation? Do they want to increase the pace of change? Or do they want to grow their revenue? Or are they doing digital transformation for improving their cost savings? It is very, very important to have a clear idea of why you are doing digital transformation before trying and bringing in all the modern technology. And one of the first steps that enterprises take for digital transformation is cloud. Cloud is a big enabler for digital transformations. Cloud provides you lower cost, so you can get infrastructure at lower cost. And you can reduce your responsibilities. If you are making use of the managed services in the cloud, you don't really need to worry about availability, scalability, and a lot of other things. You can focus on your business applications. Cloud provides you with higher capabilities. If you want to do DevOps, if you want to do machine learning, if you want to do analytics on the cloud, it's much more easier than doing them in your data centers. And cloud can also increase the speed to market of your solutions. However, adopting cloud needs a change in skills, mindset, and culture. So your team needs to understand the cloud and have the right mindset and culture to adapt the modern architectures. So you'd be thinking about modern architectures like microservices, serverless, containers, Kubernetes. You'd be thinking about more agile processes. You'll be thinking DevOps. And you would also need the right talent with the right skills. And you need to have the culture of experimentation and innovation. Let's look at a few examples of cloud mindset. In the cloud, we are looking to rent infrastructure. We are not looking to buy infrastructure. When you're using a data center, you are planning ahead of time about infrastructure. But in the cloud, you provision it whenever you need it. In the data center, you're thinking about virtual machines. However, in the cloud, whenever we think about deploying an application, we are thinking about platform as a service or making use of containers or making use of the serverless services. Typically, when we go to the cloud, we are thinking about team members who have T-shaped skills. We are talking about DevOps teams. You should have really good skills in one area and you should have good knowledge on other areas as well. So maybe you are a developer, but you are expected to know a little bit about all the operation services which are present in AWS as well. So we are looking at T-shaped skills when we go to the cloud. Another important factor when we go to the cloud is to automate the releases. We are looking at continuous integration, continuous deployment with flexible release options. We looked at a wide variety of release options, canary, A/B testing, blue-green deployments. So cloud provides you with a lot of flexibility in how you release your applications. And you can also automate your entire release process. When you go to the cloud, we are looking for automating our infrastructure. So we are looking at infrastructure as code. And the attitude when you go to the cloud is move fast by reducing cost of failure. If you automate your testing, if you automate your releases, if you automate your infrastructure creation, and if you automate your monitoring, you'd be able to find out any problems very, very early and you'll be able to fix them fast. Therefore, you can move fast. In this step, we got a high-level overview of digital transformations and how cloud can enable digital transformations. We also talked about the mindset you would need to have when we are building cloud applications. I'm sure you're having a wonderful time, and I'll see you in the next step. Cost management is very, very important in the cloud. And to be able to do cost management very, very well, there are three fundamental things that you need to understand. One is total cost of ownership. Next is the expenditure models in the cloud versus expenditure model in a data center, CapEx versus OpEx, and also the different pricing models which are present in the cloud, consumption-based versus fixed price. Let's look at these in the specific step. Let's get started with total cost of ownership. Whenever we talk about deploying applications to the cloud or whenever we talk about deploying applications to a data center, we will need to talk about total cost of ownership. What does the total cost of ownership include? It includes infrastructure costs. It includes the cost of procuring servers, databases, storage, routers, everything related to that. And it should also include the costs to maintain the infrastructure. You also need to include your licensing costs. You have software licensing costs and hardware licensing costs. You need to take your networking costs into account as well. The cost to establish a connection and also the cost to transferring data. Data which is coming into the cloud is called data ingress. Data which is moving out of the cloud is called data egress. You also need to take your personnel costs into account. Dev team, test team, ops team, business team. And if you have an infrastructure, then infrastructure maintenance team. And also there are several other costs. If you're missing any SLAs or compliance needs, then penalties related to that. If you're making use of any third-party APIs, then the costs related to that need to be included as well. And you'd also need to include your electricity costs. So whenever you are designing solutions or whenever you are migrating to the cloud, make sure that all these factors are accounted for. Make sure that you are taking total cost of ownership into account. So make sure that you are comparing apples to apples. So the first lesson related to cost management is to take total cost of ownership into account. Next, let's look at expenditure models. The expenditure models are CapEx versus OpEx. A good example of capital expenditure is money spent to buy infrastructure ahead of time. When you buy infrastructure, you'll also need to spend money to maintain infrastructure over a period of time. You might need a team to manage this infrastructure as well. A good example of capital expenditure is deploying your own data center with physical servers. Another example is in the cloud. If you purchase reservations ahead of time, let's say I'm purchasing a 1-year reservation or a 3-year reservation, even that comes under capital expenditure. If I would want to lease software for a year or a couple of years, that also comes under capital expenditure. So any money you spend ahead of time comes under capital expenditure. The alternative is operational expenditure, OpEx. This is money spent to use a service or a product. Typically, OpEx has zero upfront costs. You pay for the service as you use them. So this is also called the pay-as-you-go model. For example, provisioning virtual machines as and when you need them. Another example is making use of serverless function as a service, for example, AWS Lambda, and paying for the number of invocations for the specific function. So the second thing that we would want to focus on when it comes to costs is to understand the model under which you are spending your money, whether you are using CapEx or OpEx. When you are running your own data center or when you are purchasing reservations in the cloud, you're going for CapEx. However, when you are spending money to use a service or a product, when you provision VMs as you need them, or when you pay for invocations of a serverless function as a service, in those kind of situations, you are making use of OpEx or operational expenditure. The third thing that you need to understand is even under operational expenditure, there are two different pricing models. There is a consumption-based pricing model and there is a fixed price pricing model. What is consumption-based? You are billed for only what you use. A good example is serverless function as a service. If you are making use of a Lambda function, you only pay for the number of invocations, the duration of the invocations, and the memory consumed. The alternative for consumption-based is fixed price. You're billed for these instances in the cloud, irrespective of whether they are used or not. You provision a VM instance. This is a fixed pricing model. It does not matter if there are applications running on the VM instance. It does not matter if there are any requests coming into that specific application. If you provision a VM instance, you need to pay for it. So this is a fixed price pricing model. So you pay for the lifetime of the VM instance, irrespective of whether you use it or not. You provision a Kubernetes cluster, let's say with 5 nodes. You need to pay for everything inside the cluster, irrespective of whether you are deploying microservices to the Kubernetes cluster or not. In this step, until now, we looked at 3 important things that you need to take into consideration whenever you think about costs in the cloud. Let's look at a few services in AWS that can help us to manage our costs. The first one is AWS Billing and Cost Management. This helps you to pay your AWS bill and monitor your AWS usage. You can go to Cost Explorer and you can view your AWS cost data as a graph. You can filter by region, availability zone, tags, and you can also see future cost projections. AWS Budgets helps you to create a budget. You can also create alerts. Another important service is AWS Compute Optimizer. It recommends compute optimizations to reduce your costs. For example, right-sizing your EC2 instances, choosing the right instance type, making sure that your autoscaling group is properly configured. Those are the things that Compute Optimizer can look at and provide automated recommendations. If you want to estimate the cost of your architecture solution in AWS, you can go for AWS Pricing Calculator. The AWS Pricing Calculator replaces a couple of old tools, which are AWS Simple Monthly Calculator and Total Cost of Ownership Calculator. So the important tools that you need to remember as far as billing and cost management in AWS are concerned are AWS Billing and Cost Management, AWS Compute Optimizer, and AWS Pricing Calculator. Now that we looked at some of the important services related to AWS to manage your costs, let's look at some of the best practices. The first one is to group resources based on cost ownership. So make use of things like tags to group resources. If you are a large enterprise, you might be creating thousands of resources in the cloud. It is very, very important to identify which resource belongs to which application and which business unit. Make sure that on each resource, there's a tag identifying which application, which business unit it belongs to. That makes it very, very easy to group resources based on the cost ownership and assign costs to a specific business unit or application. When we are moving to the cloud, typically we are moving in from capital expenditure to operational expenditure. And therefore, it's very, very important to have regular cost reviews. It is recommended to have at least weekly cost reviews. And ideally, these cost reviews should include all the teams. You should have your executive team, management team, business team, technology team, and your finance team involved in these cost reviews. The third recommendation is to estimate the cost of the solution before you deploy. So the recommendation is to make use of pricing calculator, estimate the cost of your solution, and only then deploy it. The fourth recommendation is to make use of the cost management features. You can create budgets, you can set alerts on the budgets so that you are alerted about expenses very, very quickly. The other best practices when it comes to the cloud is to stop the resources when you don't need them. Typically, when we run things in the data center, we will keep them running for a long time. Irrespective of whether we are making use of an application or not, we'll keep the application running. However, in the cloud, it is very, very important to stop the resources when you're not using them. So if there is no testing going on, stop all the resources related to the test environment. In the cloud, it's always recommended to go with managed services. So it is always recommended to make use of platform as a service instead of infrastructure as a service. This will help you to reduce your responsibilities and helps you to focus on your code. In this step, we looked at some of the best practices related to cost management in AWS. I'm sure you're having a wonderful time, and I'll see you in the next step. In this step, let's explore some of the important services related to managing costs in AWS. Let's start with the AWS Billing Dashboard. The AWS Billing Dashboard is part of something called Billing and Cost Management. If you type in billing in here, you'd be taken to billing. Access, analyze, and control your AWS costs and usage. Over here, you can see a dashboard with a high-level details around your billing with respect to AWS. You can see the current month's total forecast. You can see the total number of active services that we are making use of. You can see the number of AWS accounts that are active at this particular point in time, and you can also see the number of active AWS regions. If you go over to bills on the left-hand side, you'll be able to see the bill for the current month. You can see that for the current month, my bill is 0.14. And there were a couple of things that were not part of the free tier, which I made use of. You can see that I'm being billed for Elastic Compute Cloud, Elastic Container Service, and Elastic Container Service for Kubernetes. The Elastic Container Service and Elastic Container Service for Kubernetes are not part of the free tier. That's why I'm being billed for them. And in Elastic Compute Cloud, if I expand this further, you'd see that I have created T2 micro instances, and also I created T3 medium instances. T2 micro is part of the free tier. So you can see that I'm not being billed for usage for T2 micro. However, T3 medium on the other hand is not part of the free tier, and you'd see that I'm being billed for it. So if you go over to your bills, you can see the current month bill, the previous month's bill, and some of the details related to that. If you want to get further details about your usage of AWS, you can go to Cost Explorer. And you can say launch Cost Explorer. Over here, I would say view in Cost Explorer. And over here, you can get visualization around your AWS costs. Over here, I'm looking at my daily details. You can see how much I'm being billed for over the last few days. If you want, you can also look at it by service. So I can say by service, and you can see the billing by service. You can see that most of my bill is coming because of Elastic Container Service for Kubernetes. If you want, you can also go and group by region. You can say region, and you'd see that most of my consumption is in Asia Pacific, Mumbai. You can also group by instance type. You can see that one of the instance types I'm being billed for is T3 medium. And for the other ones, the ones in yellow, there is no assigned instance type. So this might not be a billing which would be directly associated with EC2. It might be related to some other service. So if you want to explore your usage in AWS as well as costs, one of the best places to go is cost management, and you can make use of this tool called Cost Explorer. And I'll go back to the previous window where we were looking at AWS billing. We already looked at budgets earlier. This is where you can come in, you can create your budget. Earlier we created a budget for $1, and right now I can see how much I've used and what is current versus budgeted. So you can set your budget and you can track your costs against the budget. You can also create detailed reports using budget reports. You can go ahead and create a budget report. You can give it a name. You can say what should be part of your report. And you can say, I'd want a daily report or a weekly report on a set of email addresses. Another very useful tool with respect to managing costs in AWS is AWS Pricing Calculator. It's at the URL calculator.aws. So if you go to calculator.aws, you'll be able to see the AWS Pricing Calculator. Estimate the cost for your architecture solution. Configure a cost estimate that fits your unique business or personal needs with AWS products and services. Let's go ahead and create an estimate. Let's say I would want to make use of a few EC2 instances. So I'll type in EC2 and I would say configure. Over here, I can choose which region I would want to create a EC2 instance in, and I would want a quick estimate. If you scroll down, you can configure your EC2 instance details. I would want to make use of Linux OS. You can configure how many vCPUs you want, how much memory you would want. And based on your requirements, the pricing calculator would suggest a EC2 instance type. You can see that based on these requirements, 4 vCPUs and 16 GB memory, the lowest cost EC2 instance is T4G X large right now. It's also showing the price for it in here. If you want, you can also create a reservation. If you create a 1-year reservation, this is the price you would get it for. If you scroll down further, you can configure how many EC2 instances you'd want. If you want 10 EC2 instances, you can put it down in here. You can also configure your pricing strategy. The default pricing strategy is on-demand instances. The other option is you can create reservations. You can say I would want to create a 1-year reservation or a 3-year reservation. When you go for a reservation, the price will be a little lower. The last thing you can configure in here is the storage you would want to attach with your EC2 instance. Let's say I would want to configure 10 GB of storage, or I'll want to attach a 10 GB storage with my EC2 instance. At the bottom, you can also see the total monthly cost. So based on our configuration, the total monthly cost would be $99.11 USD. If you want, you can see the details also in here. So the cost related to EC2 instance is $98.11 USD, and the cost related to the storage that we are attaching, the EBS or the Elastic Block Storage, is $1 USD per month. Now I would say save and add service. Let's say I would want to add a RDS instance as well. And let's say we would want to make use of RDS for MySQL. I would go ahead and add in Amazon RDS for MySQL. Configure that. Let's take the defaults. And for the default RDS instance, you can see that the cost is really, really high. It shows a little bit more than $5,000 right now. The reason the cost is very high is because the instance type which is made use of is DB-M4 10x large. And you can see that this has 40 virtual CPUs and 160 gigs of memory attached with this. If you want to create a smaller database, you can go and change this. So instead of that, you can probably choose DB-M4 large, which has 2 vCPUs attached with it. And you can see that your cost comes down drastically. So you can go in here, you can explore the different types of instance types which are present, what is the cost for using them, and you can make the right choice as to what kind of configuration you would want. Once you have chosen the right type of hardware for your MySQL instance, I can go ahead and say save and view summary. Over here, you can see the final costs for your architecture. We are setting up Amazon EC2 and Amazon RDS for MySQL. And the total 12-month cost for this would be around 4,000 USD. If you don't want to make use of any other service, you can add it to your estimate as well. If you're planning to deploy a solution to AWS and you'd want to get an estimate, that's when you'd make use of AWS pricing calculator. I'm sure you're having a wonderful time, and I'll see you in the next step.